Hello everyone and welcome to this captivating exploration to the world of blockchain technology by Intellipaat. In this video, we are diving into one of the most revolutionary concepts of our time. Whether you are a tech enthusiast or a curious learner or simply someone looking to understand the buzz around blockchain, you are in the right place. Imagine a digital realm where transactions are just not secure, but are also transparent and tamper-proof. Think about a system where trust is not bestowed upon a single entity, but distributed among participants. This is the essence of blockchain, a groundbreaking technology that has the potential to reshape the industries, challenge conventions, and empower individuals like never before. Over the next few minutes, we will unravel the key concepts behind the blockchain, from its foundational principle to its real-world applications. We will explore how it all began with the invention of cryptocurrencies like Bitcoin and how it's evolved over the multifaceted tool with far-reaching implications. Whether you are interested in understanding how transactions are verified without intermediaries, how data integrity is ensured through clever cryptographic techniques, or how smart contracts are changing the way agreements are executed, we have got you covered. So buckle up as we embark on this journey through the intricate pathways of blockchain technology. By the end of this video, you will not only grasp the fundamentals, but also gain the insights into how blockchain is shaping our digital future. Let's begin by taking a look at our agenda for today's session. So we will begin with understanding what is blockchain. Then we will move on to the fundamentals of blockchain. We will also understand what is Bitcoin. As we move further, we will see the two types of cryptography algorithm. Then we will understand how blockchain networks looks from high-level design perspective. Moving ahead, we will initiate a transaction in the network. Then we will have Merkle Trees of odd numbers of transactions. After which we will see proof of work versus proof of stake. Then comes the advantages of smart contracts. And then we will talk about gas in Ethereum, as well as what is DAO and Introduction of Solidity. And lastly, we will discuss few important blockchain interview questions. But before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us.
What is blockchain? Blockchain technology is a way of recording and storing information in a secure and decentralized manner. It is a digital ledger of transactions that is maintained and updated by a network of computers rather than a single centralized authority. Think of it like a digital ledger that keeps track of all the transactions made in a certain network. Each time a transaction is made, a block is added to the end of the ledger and a record of that transaction is stored on it. This block is then linked to the previous block in the chain, hence the name blockchain. How does it work? In a blockchain network, transactions are verified by a group of computers called nodes. When a transaction is made, it is broadcasted to the entire network, and the nodes work together to validate the transaction and add it to the next block in the chain. Once a block is added to the chain, it is extremely difficult to alter or tamper with the information stored on it. This is because every block in the chain contains a unique code called a hash that is generated based on the information stored in the previous block. If someone tries to alter the information stored in one block, it will change the hash of that block, making it easily noticeable by the other nodes in the network. Benefits of blockchain technology. One of the key benefits of blockchain technology is its security. Because it is decentralized and each block in the chain is linked to the previous one, it is extremely difficult for anyone to tamper with the information stored on it. Another benefit is transparency. In a blockchain network, all transactions are recorded and stored on the ledger for everyone to see. This makes it easy for anyone to view the history of transactions and verify that they are accurate. Finally, blockchain technology also has the potential to increase efficiency and reduce costs. By eliminating the need for intermediaries such as banks in transactions, blockchain technology can speed up the process and reduce the fee associated with traditional transactions. Applications of blockchain technology. Blockchain technology has a wide range of potential applications. It can be used in finance, healthcare, supply chain management, and even voting. For example, in finance, blockchain technology can be used to make cross-border transactions faster, cheaper, and more secure. In healthcare, it can be used to securely store and share patient information. In supply chain management, it can be used to track the movement of goods and ensure their authenticity. Conclusively speaking, Blockchain technology is a revolutionary way of storing and recording information that has the potential to transform many industries. By providing a secure and transparent ledger of transactions, it has the potential to increase efficiency, reduce costs, and increase trust in the digital world. Whether it will live up to its potential remains to be seen, but it is a technology that is worth paying attention to in the coming years.
Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
So let's move ahead and try to understand what exactly is blockchain. So see this diagram that you see over here on the screen. If we break the word blockchain into two different words, we get block and chain. So basically blockchain is nothing but chain of blocks connected together. Okay, blockchain is nothing but chain of blocks that are connected together. So when we have these chain of blocks that are connected together, we have a few questions that comes up in our mind, like what exactly is a block? We don't know what exactly is a block. We don't know what exactly this block holds within itself, right? Why do we even need these blocks? Okay, what do they hold within themselves? And last and most important question is how exactly they are chained up with each other. Okay, fine, we have a block and it's connected to other chains to form a chain of blocks, but what's more important is how does it holds. Okay, and lastly, how these are chained up with each other. Okay, when we say that it is nothing but chain of blocks that are connected together, how exactly it is chained, because it is nothing but a digital piece of data, right? It is not a physical block that we can tie up with another block and show that yes, this is how they are chained up together. It's actually just a digital piece of data, right? So when it is just a digital piece of data, it's an obvious thing that there should be some mechanism which is linking the two blocks. So we'll try to understand, learn about that as well. But yeah, on a very high level, if we talk about blockchain, it is nothing but a chain of blocks that are connected together to form a blockchain network. Now, few important and fundamental questions like what is a block, what it holds, and how they are chained up together. Let's move ahead and try to learn and discuss about these important aspects. First and foremost, what exactly is a block? So to understand what is a block, we'll have to actually understand what is a transaction. Okay, so to actually understand what is a block, firstly we'll have to understand what is a transaction in a blockchain network. So if in a general manner, if I have to talk about a transaction, can anybody tell what does a transaction mean to you in a layman term, in a general term? What does a transaction mean to you? What do you understand by the term transaction?
Let's have a quick quiz question, guys. And the question is, what is blockchain technology primarily known for? And your options are securely storing physical assets, providing instant financial transaction, distributing digital content, or creating tamper-evident and transparent ledgers. Please mention your answers in the comment section below.
So see, that's correct. So what happens is whenever we hear the term transaction, okay, we mostly think that it's gonna be a financial transaction, right? So we mostly think that it's gonna be a financial transaction between two people where we are exchanging some money or some financial asset among each other. But necessarily it doesn't always have to be like that, right? So what's more important is that whenever we talk about the term transaction, it can either be an exchange of information or the exchange of a financial asset. Okay, it's not important that it only has to be the exchange of a financial asset, that is money. It can also be an exchange of information. When I say exchange of information, it can be any data, any personal information, or any other ergonomic information that we want to pass on to the other person. That's also a kind of transaction. Okay, which means that in blockchain, everything that happens is a transaction. Okay, everything that happens in a blockchain network is a transaction only. Does it mean that, does it mean that whatever is stored in blockchain is always in the form of transaction? Is that what do I mean to say? Yes, that's absolutely correct. So whatever I store in the blockchain network, it's always a transaction. Okay, whatever I want to store in the blockchain network, it's always in the form of a transaction. Now, when I say that I want to store something in the blockchain and it has to be a transaction, there must be a place where I can store these transactions, right? There must be a place where I can manage these transactions. So obviously it has to be, there should be some place. So there are two ways. Either we have a single point centralized server. Okay, this is a centralized server wherein I can store multiple transactions at one place. Obviously, this is one way, and this is the traditional way how people and organizations have been managing the data before the world of blockchain. But now, with the help of blockchain, we can store these transactions in these blocks. We can store multiple transactions in these blocks. Okay, and obviously the creation of transaction is nothing but creation of data. So when creation of data, when we are talking about the creation of data, it is a continuous process and it will keep on happening and happening and happening, right? So we just cannot have one single block that would be responsible for storing the transaction. Obviously this block will have certain limit of data, and only that limit of data can be stored within this block. So what if the limit of this block is achieved? What will do after that? So post that obviously we'll have to create a new block. So when we create a new block, most importantly, we need to understand that with the help of creation of this new block, what's most important is that again, this new block will be created by someone and would be capable of storing the transactions. Okay, that's one thing. Now, again, when this block is filled, a new block will be created, would be responsible for storing the transactions. When this block will be filled, a new block would be created, would be responsible for storing the transactions. Which means, most importantly, we need to understand that the blocks are nothing but they are responsible for storing the transactions. What is the only use of blocks? The blocks are responsible for storing the transactions. And whenever we talk about storing the transactions, the most important thing is as soon as we go on creating the block, the blocks will start storing transactions within themselves. Okay. And this process of creation of blocks will continue to happen again and again and again. Right. So this is where this transaction things comes into picture. And this is exactly how the transactions are managed. Importantly, the data can be stored and managed in multiple ways, but the reason why we are storing it in multiple blocks and in a distributed manner is with respect to the security. So as we progress in the course, we'll try to understand that how exactly the splitting of data in multiple blocks in a distributed format actually helps in the security part. The data that is present in the blockchain can never ever be tampered or deleted or edited or modified. Okay, so whatever data we are storing in the form of transactions within the block, that can never ever be tampered or modified. Okay, that can never ever be tampered or modified. Not even it can never ever be deleted as well. We can never erase this piece of data. And even today, if we want to see the data that is present in the first block of the Bitcoin or the Ethereum network, we will be able to see that as well. Okay, so at least we are clear with one thing as of now, that the transactions are stored within the blocks. And now, important thing to understand over here is, so with this, our first two questions gets cleared very easily. First and foremost, what is a block? A block is like a building block of the blockchain network, which is responsible for storing the data in the form of transactions, of course. And second question is what it holds and why do we need blocks? So obviously, first, it holds the transaction in the form of, the data in the form of transaction. And why it is needed? Because it is the only storing capability. It has the only storing capability which can store the transactions and the data within the block, right? That's the reason it is very much required. Now the last question is, how is it chained? The most important thing is how exactly it gets chained. We have this concept of block hash and transaction hash. So let's try to understand that first and foremost. What is a block hash and what is a transaction hash? And then with the help of that, we'll be able to understand that what exactly is this. So yeah, now we need to understand. So before we, I was just saying that before we move and try to understand the concept of how these blocks are chained up with each other, we'll need to understand that how these we'll need to understand the concept of block hash and transaction hash. So we'll try to understand what is a block hash and what is a transaction hash. Okay. So as we all know that every transaction has to be unique, right? I hope we understand, and we understand the sincerity of that. Every transaction has to be unique. So how do we ensure that every transaction has to be unique? With a special parameter that is known as transaction hash. So every transaction is uniquely represented by a property that is known as transaction hash. And transaction hash, if we have to define transaction hash, then transaction hash is nothing but a unique property given to a particular transaction, or a unique property that uniquely defines a transaction. That is nothing but a transaction hash. Similarly, what is block hash? So block hash is a unique property of a block which uniquely represents a block. Okay, so every block will have a hash, and every block hash will be uniquely assigned to a particular block. Similarly, every transaction hash will be uniquely assigned to a particular transaction, which means in a blockchain network, these two hashes play very important role. Okay, in a blockchain network, these two hashes play a very important role. The first type of hash is the block hash, which is nothing but a unique property of a particular hash, okay, of a particular block. And secondly, we have transaction hash, which is nothing but a unique property of a particular transaction. And how these block and transactions are uniquely identified? They are identified with the help of these properties, that is block hash and transaction hash. I hope now that completely makes sense to all of you. So now another important thing to understand about this is that this block hash that I'm talking about over here is not stored in the current. So this block hash that I'm referring to over here is not actually stored in the current block. Rather, this block hash is always stored in the next block's header. So this hash that I'm referring to over here, the block hash that I'm talking about over here, is never stored in the current block. Rather, it is stored in the header of the next block. Now we need to understand another important thing. What is this concept of block header that I just talked about? This is a new term, right? Which we haven't discussed as of now. What is a block header? So what happens is, if you see that rightmost block, if you see this block that I have drawn over here, you can clearly see that the block is divided into two parts. Okay, a block is divided into two parts. The first part is the block header, which occupies around a very small amount of space it occupies within a block. And the second type of the second part of this block is the transaction list. This transaction list that I'm talking about over here is nothing but, this actually contains all the data and all the transactions. This transaction list that you are seeing over here, this is what contains all the data and all the transactions. Whereas the block header only contains some 5 or 6 different fields that are only responsible for holding the identifiers of these blocks. Okay, so these are responsible for holding those types of parameters which uniquely defines these blocks. Now, obviously, this we will learn and understand in greater detail as we move ahead. So basically, that's what I was telling about, that whenever we talk about the block header, it just contains some 5 or 6 different parameters that are responsible for helping the block to be identified. Now, what are these 5 or 6 different parameters? What exactly are these 5 or 6 different parameters? That we will cover and learn about that in greater detail as we move towards block structure. Okay. So when we learn about what is the block structure, then we'll learn about what exactly is, how the block is structured from within inside, then we'll learn about all these 5, 6 different parameters. But one parameter that we are very much interested as of now is that is known as PBH, that is known as previous block hash. So this one parameter is very much important for us right now. That is known as previous block hash. What this previous block hash can be. So now what we need to understand is, what I was telling is that every block hash is a unique property of a block. As I already told to all of you, that block hash is nothing but a unique property that is assigned to a particular block, and previous block hash is nothing but when the hash of the current block is stored in the header of the next block. Similarly, hash of this block will be stored in the header of the next block. So in the next block, when it is getting stored, what will it be called as? It will be called as previous block hash, because it is the hash of the previous block, right? Similarly, when the hash of this block is getting stored in this block, it's previous block hash. So it's every block hash. What it means is every block's hash is being stored in the header of the next block. Every block's hash is being stored in the header of the next block. And this exactly is what is creating the block hash, right? This exactly is what is known as previous block hash and the relation between the current block and the previous block. And this is what, allows with the chaining part. So this actually creates a chain of blocks. So whenever we talk about blockchain, I hope now this makes sense to all of you, that blockchain is nothing but chain of blocks that are connected with each other. Each and every block is responsible for holding multiple transactions and related data. Every block and transactions have unique hashes that uniquely every block and transaction have unique hashes that uniquely identifies each and every transaction and each and every blocks that are present. And when the hash of the current block is stored in the next block, that is what is known as previous block hash. So this is all in all the learnings that we have done till now. So what is this etherscan.io? It is basically a block explorer. So every blockchain will have a block explorer that would be responsible for giving you all the information about the current blockchain. Everything that's happening on the current blockchain, you can get to see and get to know it from here. Okay, everything that happens onto the blockchain network will be visible over here, like what is the current ether price, what are the total number of transactions, what is the gas price, what's the finalized block, safe block, everything. Obviously at this point of time we don't know all these parameters. Also, we don't know what is market cap, we don't know what is last finalized block, we don't know what is last safe block, and everything. Of course, we'll understand that as we move ahead. But what's more important to understand, why did I open it right now, is I wanted to show that every block, so all the latest blocks that are created will be visible over here. So you see right now the latest block that was created is 168055757. If I refresh it, you will see some more blocks would have been created. This is very, very real time. You see, the last one that we saw was 168055757, and now we see so many new blocks are created. Again, if I refresh, again I'll see some more new blocks coming up. So you see, earlier was 63, now I see one new block added 64. Okay, so this is what I see, that everything that happens onto the blockchain network, I'll be able to see it in real time over here on this platform that's known as Block Explorer. Now what's important over here is, let me open up this block, and I see that there's something known as parent hash. I see I see over here something that's known as parent hash. What is the height? Block height is nothing but the block number. Okay. What is block height? Block height is block number. And what does this block number represent? Okay. Yeah, that's correct. So it is nothing but the total number of blocks that have been created till now. Okay, it is the total number of blocks that have been created till now. So when I say that it is total number of blocks that have been created till now, this basically means that these many number of blocks are already created before this. Okay, these many number of blocks are already created before this. And when I say that these many number of blocks are already created before this, another important thing to understand over here is uh, the blocks are always counted like this. This is the zeroth block, this is the first block, this is the second block, this is the third block, this is the fourth, like this. So if I say that the position of this block is this, what would be the total number of blocks that are present in the blockchain network? One more than the present, exactly, because we are starting from zero, of course.
Zero.
Okay, so this is the total number of blocks that are present till now in the blockchain network. And any block height of any particular block represent its position from the zeroth block. So this block height, the height of this block is 3, which means it represents this block's position from the zeroth block. So you see this block's position from zeroth block is first position, second position, third position. Like this, it is 168057064 block. Another important thing to understand is that this block, the zeroth block of any blockchain network, is a unique block that is known as the zeroth block of any blockchain network is a unique block that is known as Genesis block. Just a terminology, nothing else. The zeroth block of any blockchain network is known as Genesis block. So if I go now, another important thing, now the block height of this block is 64, ending with 64. And if I click on the parent hash, what would be the block height of this parent hash? Obviously the previous block, right? So it should be 63. And that's exactly correct, 63. Similarly, if I go to the parent hash of this block, it will be pointing me to 62. That's correct, 62. And like this, we can say that every block is connected to its previous block with the form of previous block hash. But what about the zeroth block? Let's go to the zeroth block. What will be the parent hash of zeroth block? Because before that, there is no hash, right? So you see, this is a finalized block which was created back in 2015, and yet the data is available in it. Fine, that is another thing. But if we see the parent hash of this block, it is 00000, which means there is no block that exists before this block. The real world data can be accessed by the users only for whom it is targeted. Okay, which means if I have shared some data with you, you can access that real data. Others will only see the hashes. So now we should be familiar with the terms like block, block hash, transactions, transaction hash, genesis block, blockchain, the previous block hash, the block header. I think we should be familiar with all these terms that I've mentioned. Collectively, these whole blockchain that I'm referring to, collectively, it's known as ledger. So ledger is not a unique thing. It's not that there are multiple ledgers, like the way we have multiple transactions present within a blockchain, the way we have multiple blocks present within a blockchain. Do we have multiple ledgers also present in the blockchain? No. Ledger is always only one. What is a ledger? Ledger is nothing but a unique term given to chain of blocks that are connected together. It is just a unique terminology. So now we'll try to move ahead and try to understand what exactly is Bitcoin. So whenever we, okay, anybody who knows what's Bitcoin before we actually discuss it? Anybody who would like to tell anything about Bitcoin? So it doesn't always have to be technical. Okay, so please be ensured and please be assured that it always, not also technical, but it also doesn't always have to be the correct answer. It's just that I do it generally for creating some engagement. Okay, so it's just a kind of engagement practice that I try to bring in. And obviously it should be a forum for discussion. Okay, so we should discuss and learn, and that should be an interactive way of learning. I just don't want that everything should be unidirectional. Okay, I just want it to be bi-directional so that it can always happen between us. So Bitcoin is, firstly and foremost important thing is that many people think, so I'll first like to clear out all the myths. Okay, a lot of people have myths about Bitcoin, that Bitcoin and blockchain is all same. When we talk about Bitcoin, it is nothing but talking about blockchain. And when we talk about blockchain, it is nothing but talking about Bitcoin. It's absolutely not like that. Although, like now, almost everybody is clear with these things, but yet I feel it important to make sure that even if someone has any such kind of myths, you need to understand that no, it's not like that now. Okay, Bitcoin is a completely different thing. Blockchain is a completely different thing. What we are talking about over here, Bitcoin, the Bitcoin that we are talking about over here is a type of cryptocurrency. Okay, it's basically a cryptocurrency. What's a cryptocurrency? It's a digital currency which are not tracked and managed by any centralized organization. Okay, so cryptocurrencies are the digital currencies which are not tracked and managed by any centralized organization. They work under the hood of technology blockchain, and they are completely just dependent on blockchain, and they are dependent on the peers who are using it and managing it. Okay, it is dependent on peers for the usage and management. Now, another important thing about Bitcoin is it's one of the first cryptocurrency. Okay, and that is what that's why it plays a very major role when it comes to blockchain technology. It plays, Bitcoin has its own position and recognition. The reason for that is, of course, because it is one of the first cryptocurrency, and it's one of the first pioneers for blockchain technology. Okay, so it is the one which actually pioneered blockchain as a technology to market. It delivered blockchain as a technology to market. Okay, if we can say that if we would have not, we can say that if it would not have had, we would not have had Bitcoin, we could not have had blockchain as well. Although cryptography is one of the core fundamental principles within all these blockchain, Bitcoin, and everything, that existed since long and long back. But blockchain as a technology was first, you know, applicable to a product using that. That was Bitcoin. So a few points to discuss about blockchain and Bitcoin that are mentioned over here, and that is nothing but uh, Bitcoin is the first blockchain focused decentralized digital currency. It uses consensus to control its creation and management rather than relying on some central authorities. It is held electronically in a peer to peer open ledger that is known as blockchain. They are not printed, rather, they are produced by people using softwares that solves mathematical problem. Okay, so everything that you see over here is a part of mathematical problems that are solved by some puzzlers, and that's how these currencies are created. Although there is a slight change in this, but again, that change we'll discuss at later point of time. So yeah, this is all about Bitcoin. Why should we use Bitcoin? Because it's super fast, really cheap, it's absolutely decentralized. You don't have to worry about chargebacks, just payment security. It's not inflationary, it's make your own money, and it's really private. Few things that you can read theoretically, few points of why should we use Bitcoin. Now, another important thing is where and how do we get Bitcoin? And with this, we come to the concept of wallets. Okay, so now we'll try to understand the concept of wallets, how wallets are used, and how exactly are they beneficial with the uses of blockchain as a technology. So we'll try to learn about wallets in details. Let's move ahead. Yeah, so whenever we talk about wallets, we can say that wallets are basically responsible for holding anything that is important to us. It again, in this case as well, it can be a cryptocurrency, it can be a financial asset, or it can be a informative asset. It doesn't always have to be money only whenever we talk about wallet. So in a manner, in a way, if you see, even Google Drive is a kind of a digital wallet, but it's not used for storing money, but it's used for storing some important documents that you might need at any point of time, right? So that's what a wallet is. But unlike that in blockchain world, unlike that in blockchain world, wallets are little different over here. Okay, unlike that in blockchain world, we can say that wallets are responsible for connecting the two world. Okay, so this world is what's known as Web 2.0, and this world is what is known as Web 3.0. Okay, so this wallet acts as a gateway that helps you to connect to the blockchain network. Okay, this wallet acts as a gateway that helps you to connect to the blockchain network. And not only this, but also these wallets are responsible for helping you to store your public and private keys. Okay, these wallets are also responsible for helping you to store the public and the private keys. Okay, so whenever I say now, another two more terms are created over here, that is a public and a private key. Obviously, then we'll again come back to the concept of wallet, but we'll have to slightly deviate over here because two new terms have popped up, that is a public and a private key. But at least on a high level, we understand now what exactly is a wallet. A wallet helps you to connect to the blockchain network. A wallet provides you a gateway to access the ledger. Okay, a wallet provides you a gateway to access the ledger. Let's suppose I'm going ahead and creating a bank account. Please understand this very carefully. Let's suppose I'm going ahead and creating a bank account. Okay, so I get two things. Let's assume that I get two things. The first one is the bank account number, and the second thing is I get a confidential, very confidential data, like we can say maybe an internet banking password. Okay, a internet banking password. So bank account number, what is the primary use of a bank account number? So the primary use of a bank account number is to identify us, right? The bank account number is used for identification of that customer by the bank. Whereas on the other hand, the internet banking password that you get is a very, very confidential data that is used for authenticating you. Whenever you are doing any kind of transaction, it is used as an authentication key with the help of which you are authenticated, right? In the same way, we can say that whenever you open an account in a blockchain network, whenever you try to open an account on a blockchain network, you will get two keys. The first key would be a public key, and the second type of key would be a private key. So the public key that you get over here is basically a type of key that you can share with anybody and everybody. Okay, you can share it with anybody and everybody. But on the other hand, you get another type of key that is known as private key. Now, this key that you get, the private key that you get, is basically a type of key that you cannot share with anybody, or you just cannot share with anybody. If you try to share it with anybody, you will just lose all the funds that you have within your account. Okay, that's very important to understand, that you'll just lose all the funds that you have within your account. Okay, so it's a very, very confidential data that you just cannot afford to share with anybody and everybody. Now, another important parameter, another important aspect or property of this private key is, as you know, you have got a bank account number and you got a user internet banking password. For some reason, if you think that your internet banking password is you know it's compromised, or for some reason if you lose your internet banking password, at any point of time you can always regenerate it, right? At any point of time you can always regenerate it or recreate it, right? But unlike this, you can never ever recreate a private key, which means you just get a public key and a private key. If you lose your private key, let's suppose you have lot of funds that are stored in this account. In your public and private key pair, you have lot of funds that are stored. And for some reason, if you lose this private key, you can never ever regenerate it, and you can never ever recreate it. Does it mean that all the funds that are present within this private key will be lost forever? Is that what do I mean to say? Yes, exactly. If you lose your private key, you'll just lose out all the funds that you have within your particular blockchain network. Yes, so there are other softwares that are known as wallets. You can go on any wallet and create a account for yourself on any blockchain network. Let's suppose there is a wallet and there is a Ethereum blockchain network. You can go on a wallet and select Ethereum blockchain network and create an account on Ethereum blockchain network, and that would uniquely create a public and a private key for you. Yeah, MetaMask is one of the wallets. Like that only, there are multiple other wallets that are available using which you can create this public private key pair for you. See, at the end, they are wallets and they all follow a simple algorithm for creation of public and private keys. Okay, it's a common standard protocol that all the wallets follow for creation of public and private key. It's not that different types of wallets will use different types of algorithm for creation of public private keys. No, whatever the wallet may be, all of them will only use these specified and standard algorithms for creation of public and private keys. Okay, so let's try to understand this. So cryptography is basically one of the type of algorithm which is used for encrypting the data. Okay, which is used for encrypting the data. So let's suppose I am the sender of the data. Okay, and someone over here is the receiver of the data. Okay, so whenever I'm sending a data, there are a lot of people present over here. That is known as communication channel, right? CEC, communication channel. So a lot of people are present over here who are part of this communication channel. How do I ensure that my data is not, taken away by them, or these people who are a part of this communication channel, they should not be able to understand what we are discussing, right? What the sender is sending to the receiver. So what sender does is sender encrypts this data. Okay, sender encrypts this data and then sends it to the receiver, so that when the receiver receive, which means that so that only the desired receiver should be able to get this data and nobody else in between. Even if in between anybody tries to interpret that data, because it is present in the encrypted format, they won't be able to understand it, they won't be able to get it. Okay, so this is very important because this cryptography is one of the ways how we can secure the data that is transferred over the communication channel. Okay, this is one of the way how we can secure the data that is transferred over the communication channel. Now there are two different types of cryptographic algorithms. There are two different types of cryptographic algorithm. The first type is symmetric cryptography and the second type is asymmetric cryptography. The first type that is available over here is symmetric cryptography. And when we talk about symmetric cryptography, it is a type of cryptography in which the encryption key is same as decryption key. Now, what is encryption key? The key which is used by sender to encrypt the data. Just a minute. Now, what is encryption key? The key which is used by sender to encrypt the data and then send that packet of data to the receiver. And then what is decryption key? The key which is used by receiver to decrypt the data and get the original data. Okay, so the sender uses the encryption key. This is EK. This is EK, that is encryption key. So sender uses encryption key to encrypt the original data to a packet of encrypted data. This encrypted data is sent to receiver. The receiver can use a decryption key to decrypt this data back to the original data. Now, symmetric cryptography is a type of cryptography in which the encryption key is same as decryption key, which means that the key which is used for encrypting the data is same as the key which is used for decrypting the data. Whereas on the other hand, we have asymmetric cryptography. On the other hand, we have asymmetric cryptography, which means that the encryption key is not same as decryption key, which means the data that is used for encrypting a transaction or a piece of data, okay, the key which is used for encrypting a piece of data is not same as a piece of key that is used for decrypting a piece of data, okay, which means the encryption key is different from that of a decryption key. Now, another important thing is which one blockchain uses. So obviously, the blockchain uses the asymmetric cryptography. Okay, which one blockchain uses? Blockchain uses asymmetric cryptography. How blockchain uses asymmetric cryptography? Because we have two different pair of keys. The first one is public key and the second one is private key. So sender uses their private key to signature this transaction. For encryption, the public key of receiver is used, and for decryption, the private key of receiver is used. Okay, so you see there are two keys used, that is public key of receiver and the private key of receiver. The public key of receiver is used for encrypting the data, and their own private key can be used by the receiver to decrypt the data. Is it clear to all of you what is a cryptographic algorithm and how two different types of cryptographic algorithms are available and how the public and the private key is a part of asymmetric cryptography that is used in blockchain? So what happens is, let's just think from a receiver's perspective. So receiver will have a public key and a private key, right? A public key and a private key. So public key, by the name only you can understand, it can be shared with anybody and everybody. So the receiver will share his or her private key, public key to the sender. The sender, whatever piece of data the sender wants to send, will use the public key of the receiver and encrypt the data accordingly. Okay, this
Mhm.
encrypted data would be encrypted using the public key of the receiver, and now this encrypted data will come to the receiver, and only the receiver with his or her own private key can decrypt the data, because nobody else can decrypt, because this public key was used for encryption, so the corresponding private key can only be used for decryption, right? So this is how
Mhm.
the public and private keys are used for encryption and decryption of data. Okay, perfect guys. So I'll just pull up one more image for you, and I hope you should be able to understand this. Just go through this image and see if you are able to relate it. Okay, so now what we are going to see is we are going to move ahead and try to understand how these public and private keys are generated. We'll actually see the different cryptographic algorithms that are used for generation of these public and private keys. So yeah, as over here you can see, this is just a cryptographic representation of how the public and the private keys are generated within the Ethereum blockchain. And this is what we'll go ahead and understand in detail. So one of the most important thing to understand over here is the concept of passphrase, also known as seed phrase, okay? Also known as the raw input. So what happens over here is that this seed phrase that you see acts as one of the most important things for actually for the generation of the private key. So this seed phrase acts as a input, seed phrase, or we can say passphrase, whatever you say. So this passphrase acts as an input, and using this, we give this as an input to one of the hashing algorithm. We give this as input to one of the hashing algorithm, and the output that is generated is the private key. So as you can see over here, that this is a passphrase. Let's suppose I give my name as the input, and once I give my name as an input to this passphrase, then a private key would be generated. Now this is your private key. How this private key has been generated? So we have taken Saurabh as a input or as a passphrase or seed phrase, gave it to SHA-256. SHA-256 is the hashing algorithm. And when we give this as an input to SHA-256, then what happens is the output that is generated is basically known as private key. Now, this private key that you see over here, this private key that you see over here is further passed to a elliptic curve generator. There's yet another key that is known as elliptic curve generator. So it is passed to elliptic curve generated, and using that, x and y coordinates are created from this private key. Okay, from this private key, the x and y coordinates are created by passing through the elliptic curve generator that you can see over here, this diagram that you see. And once that is done, then we concatenate the x and y coordinate and pass it as an input to CAC 256. Okay, what we do is we concatenate the x and the y coordinates, we pass it to CAC 256. Then the output that is generated is the public key. You see, so step number one is the private key is the 256 random bit output. After this pass phrase is passed to short 256, then this short 256 output, that is the private key, when it is further passed to the elliptic curve generator, the x and the y coordinates are generated. Then this x and y coordinates are concatenated and passed to a CAC 256. Then a CAC 256 hash is generated, which is the public key. So this is how the private key and the public key are generated. But in a real life use case, we use another term that is known as address or account address. In our real life use cases, we use another term that is known as account address. Now, what is this account address? It is nothing but the last 20 bytes of this public key. You see the highlighted last 20 bytes prefixed with 0x. Okay, it is the last 20 bytes of public key prefixed with 0x. This acts as a main account for anybody to receive and transfer funds. The reason for that is quite simple. When we already have a public key and a private key, then when we already have a private key and a public key, then why do we need this address? The reason for that is simple. Let me copy this private key and show it to you. So I gave Saurabh as input. This private key was generated and the public key that was generated was this. So is there a way to differentiate between the public and the private key? Of course not, right? There's no way to differentiate between this public and this private key. I mean, this private key and this public key. That is the reason, to avoid this confusion and to avoid the anonymous behavior of public and private key, we actually bought a concept of address that would be used for, that would be used for signing the transaction and that would be used for encrypting the data. So with this, we can clearly say that yes, this is the address, because first and foremost, it is only of 20 bytes rather than private key and public key being 32 bytes. Both of these are 32 bytes, but address is only of 20 bytes. And secondly, it is prefixed with 0x. So that again gives another recognition to this, right? So this is exactly how the public and the private keys are generated. So three algorithms are used over here: short 256, CAC 256, and ECD cover, that is known as elliptic curve generator. Yeah, so the public key is generated. So how it is generated? Once the private key is generated, after that it is passed to the elliptic curve generator. Elliptic curve generator will actually break down the same private key into the x coordinate and the y coordinate. So the x coordinate and the y coordinates would be segregated after passing it to elliptic curve generator. Then what we do is we concatenate both the value. Concatenation in string is nothing but adding both the string. So we concatenate both the value and pass it as an input to CAC 256 hashing algorithm. When we pass that as an input to CAC 256 hashing algorithm, this is the output that is generated. Now this output that is generated is the public key. So let's suppose one string is SAUNDARYA, another string is Saurabh. When I say that I'm concatenating, so let's suppose this is X and this is Y. So when I say that I'm concatenating X and Y, it will become, so that is yet another hashing algorithm that we use for generation of a further, what do you say, generation of a further uh, output of this hashing algorithm, and that the output of this CAC 256 acts as a public key. So this is exactly how the public and the private keys are generated. So now what we'll do is we'll try to understand what are different types of wallets. Again, now we will be coming back to the concept of wallets. And now I think we totally understand what is a wallet. So first and foremost, wallets are responsible for providing access to the blockchain network. They provide a gateway to access the ledger. And secondly, they also can store the public and the private keys. And when we say that they can store the public and the private keys, whenever we store the public and the private keys, what are public and private keys? We have discussed that. How they are generated, we have discussed that. What they are used for, we have discussed that. Now we'll discuss about what are different types of Bitcoin wallets or blockchain wallets. So now we'll discuss about what are different types of wallets, and then we have mobile wallet, then we have desktop wallet. So when we have these many different types of wallets, we need to understand that the purpose of all these wallets remains same, irrespective of whether we are talking about web wallet or we are talking about mobile wallet or we are talking about desktop wallet. Irrespective of all of them, the purpose of all these wallets remain same. What does it mean that the purpose of all these wallets remain same? It basically means that all these wallets are responsible for again connecting you to the ledger and helping you to store the public and the private keys. So when I say that they are responsible for helping you to connect to the ledger and storing the public and the private keys, does it mean that whether it is web wallet or mobile wallet or desktop wallet, all of them are doing the same thing? Yes, exactly. All of them are doing the same thing. And now that all of them are doing the same thing, what is the need of so many different types of wallets? If all of them are doing the same thing, then what's the need of having a web, mobile, and desktop wallet? It is just for user convenience. Okay, it is just for user convenience. If you are more comfortable and if you are more convenient with a web wallet, you'll use a web wallet. And if you are more convenient with a mobile wallet, you'll use a mobile wallet. And if you're more convenient with a desktop wallet, you'll use a desktop wallet. Okay, that's the only significance of all these different types of wallets. After these web, mobile, and desktop wallet, we have something that is known as hardware wallet. Okay, now this is the interesting thing. Let's try to understand what is purpose of having a hardware wallet. And before even that, how does this hardware wallet looks like? Okay, how does this hardware wallet looks like? So a hardware wallet like a treasure wallet looks like this. So this is a treasure wallet. This is a hardware wallet. Okay, then we have Ledger Nano S. Let's see for the Ledger Nano S. I'll have to search it. Yeah, here it is. So this is a Ledger Nano S wallet, Ledger wallet. Okay, this is yet another hardware wallet. So these two are the most popular hardware wallet. The first one is Trezor wallet. This is a Ledger wallet. Now, one of the most fundamental questions that should come to our mind is when we already have web, mobile, and desktop wallet providing all the different platforms for the user to access the wallet, and probably web, mobile, and desktop wallet would be free of cost. And even if it is not free, although it is free, but even if it is not free, it would be very less chargeable. So what is the need of this hardware wallet, which of course would be chargeable because we have to get a hardware device, which of course will incur some cost, right? What's the need of this hardware wallet? Okay, so yeah, most importantly, see what happens is still we need to understand, although we say that blockchain is very secured, it's very safe, it's very transparent, immutable, and multiple other things. Although we can say, and that's true also, it's not just we are saying, it is true. But we need to understand that our wallets still reside on the Web 2 layer, which means it still uses some traditional web technology for development of web, mobile, or desktop wallet. We still use traditional web technology like traditional web servers, not a distributed server. It's still residing on the traditional web servers, whatever wallet we take, whether it's web, mobile, or desktop wallet, right? And if that web, mobile, and desktop wallet is storing our private key.
Let's have a quick quiz question, guys. And the question is, Which of the following is a characteristic of a blockchain technology? And your options are centralized control, high energy efficiency, slow transaction speed, or publicly accessible data. Please mention your answers in the comment section below. Just a quick info guys, Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. Repeat. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
Then of course, that private key is being stored on some centralized server. That private key is being stored on some centralized server, which of course is not safe. If some hacker comes and hack into the server and steals our private key, then again, using this private key, they can easily go onto the blockchain network and do any kind of transaction on our behalf, right? On our behalf, they can do any kind of transaction. So this is where we need to secure our wallets. It's very, very important to secure our wallets, because even though blockchain and Web 3.0 is very secured, safe, transparent, and whatnot, even though all those things are still in place, but if we are not able to secure our private key, we just cannot uh, say that it's actually secured, right? So, and obviously, the blockchain cannot come and secure your private key. It's a key which is given to you, right? It's a key. The locker making company, okay, a physical locker might be very, very safe and secure. Okay, maybe one of the best companies in the world is making a physical locker which you are using for safety of your home. Okay, a physical lock, but that physical lock making company cannot ensure that you cannot lose your locker key. If you lose your locker key, or if you just if someone steals your locker key and bypasses the security of the lock, then of course you cannot blame the locker making company, right? Because it is your fault. You mishandled your key, right? Or someone stole it from you. So we cannot question the security of blockchain in all this, because they have given us a key and it's our responsibility to keep it safe. Okay. If someone steals it from us or hacks it from some server, again, it's not the, it's not a problem of blockchain technology. So that is the reason securing the private key is equally important. Okay, it's equally important to secure these private keys and to ensure that they are always in the right place. So for this reason, because the web mobile and the desktop wallet are still using some traditional web server technologies, there might be a chance that our private keys gets misplaced, or there might be a chance that our private keys get lost, right? And that's exactly where hardware wallet comes into picture. So hardware wallet stores your private key within this hardware. Okay, your private key is not exposed to any traditional server. Your private keys are stored within this hardware, which only is connected to the internet only for some fraction of seconds. Okay. On the other hand, on web, mobile, and desktop wallet, your private key is always 24 cross 7. It is available on the traditional web servers. On the other hand, the hardware wallet only is connected to internet for some like fraction of seconds, or maybe hardly a minute, only when you want to do the transaction. You plug in your hardware wallet, you do the transaction, and you plug it off. Okay, hardly giving a chance to any hacker to even to get to know that yes, some machine has been plugged in and I need to do this and that and blah blah blah, right? So the most important thing is that's where the security of hardware wallet comes into picture. That what actually it is doing is it is just removing your private key and keeping it in a secured, safe device, which is away from internet. Okay, it is not doing any very unique or very complicated thing. Nothing. It's just a pen drive, small device, which is just taking away your private key from some traditional web server and putting it in a hardware wallet. That's it, right? There's no rocket science over here. The only science involved over here is just to make sure that your private key is not available on the traditional server. That's it. Is there an alternate way to ignore the hardware wallet? And is there a cheaper way to do this? Yes, of course. You can just create a notepad file. You can just create a notepad file in your system, and you can take this private key from here and put it in this notepad file and save it. This is actually a type of wallet, and that's known as paper wallet. That's known as paper wallet. What is paper wallet? It is one of the most secure cold storage solutions. What is exactly it is? It's basically nothing but you take your private key and write it down on a piece of paper, a blank paper. Okay, you write down your private key on a piece of blank paper and lock it somewhere in the safe locker. That paper becomes your wallet because it is holding your private key. Or you put it in a notepad file and save it somewhere. The notepad file becomes your wallet because it's holding your private key. So what do I do with this private key? When I have to do the transaction, where do I go? So you can go to any wallet that is supporting paper wallet. So any wallet that is supporting paper wallet, you can go on those wallets and do the transaction by manually entering the private key. So you don't actually have to put your or place your paper wallet private key on these servers. You can just do the transaction, and for authentication, you can just put in your private key. That's it. And they will not be storing your private key. So your private key is just stored with you on your physical paper, or in a notepad file, or you can even memorize it. Although that's the least preferable way, but of course you can do it if you want. To be honest, mostly it is used by traders, high volume traders. Okay, so the people who store and who manage and use lot of funds and cryptos, they definitely would prefer to use it because it's one of the most safe wallets. But we as a developer would never ever prefer to use a hardware wallet because we don't have to store some real funds or some real money. We don't deal with real money, right? We mostly deal with development of projects and development of decentralized applications. So we don't require it. This organization is completely blockchain based organization. Okay, so everything that they do, all the transaction and everything that they do is in the form of cryptos. Okay, so now another important thing and very important thing to understand over here is because they do everything in crypto, so obviously all the transactions and everything will be done in the cryptocurrency and blockchain only. So because this as an organization has an account of public key and a private key, obviously, the private key has to be shared with both the owners because there are two owners for this company, right? So both the owners will have this private key, the access to this private key, because both are equal partners in this company. And if you share this private key with two persons, if you share this private key with two persons, anybody does the transaction, private owner two using this private key does the transaction on the blockchain. Will anybody be able to figure it out who has actually done that transaction, whether it is owner one who has done the transaction or owner two who has done the transaction? What do you think? Can anybody guess? Is there a way to figure out that? So yeah, of course, nobody can figure out who actually did this transaction because obviously the private key is same, right? And the transactions are always having a to and a from. So the to address remains the private key address, and that can never be figured out by anybody, right? That can never be figured out by anybody. So that is the reason. That is the reason it's very important to understand that this particular kind of concept cannot go through, right? This particular kind of concept cannot go through. So for such reason, to avoid such reason, what we have to do is we have to ensure that there should be some other way. So what we do is we bring in a concept of multi-signature wallet. So using this multi-signature wallet, what will happen is both the owner one and owner two, will be given their respective private keys. Both the owners, owner one will be given PK1 and owner two will be given PK2. both the owners will be given their respective private keys, and they can use in their respective private key to sign a transaction. So owner 1 can use their respective private key to sign a transaction. Owner 2 can again use the respective private key to sign a transaction. And in this way, we can always figure it out that who actually did the transaction. You can also put certain conditions like 1 out of 2 or 2 out of 2, which means whenever you are doing a transaction, how many signatures are mandatory for that transaction to pass through? How many signatures are mandatory for that transaction to pass through? Is it just one signature is enough, or is it that two signatures are enough? Or if you have even one more owner, you can even create one more private key, that is PK3, and you can also define 3 out of 3, which means all three signatures are required, or any two director can sign, or any one director can also sign to do the transaction. In this way, you can understand that this is what a multi-signature wallet means, which means multiple signatures would be allocated to multiple people, and respectively they can use their respective signature to actually sign the transaction.
Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. Repeat. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
Now we are going to see and understand that how the blockchain network looks from a high level. Okay, the whole blockchain network, how does that network looks from a high level perspective or a high level design perspective? Okay, so that's what we're going to cover now. So for that, see, this is how our current system server architecture looks like, and this is how a blockchain distributed system architecture looks like. Okay, so what is it? Let me explain you briefly. So this is a single point server wherein you are given, maybe you can have your own private server, or from someone who is already having a huge server, you can rent out a small server like cloud services, what Google, Amazon, all of them do is that they are actually managing all the hardware infrastructures in terms of servers, making sure that the uptime of these servers are always available. And what you do is you just rent out a small portion of these servers, just as per your need. So this also this is a very nice model because it not only saves you from all the complications of hardwares and networking, but it also allows you to only use and only pay for what you use and only use for what you need. Okay, so this is where the whole cloud thing came up, but obviously that's a completely different thing. So what we are discussing over here is no matter whether it is a virtual private server, or whether it's a physical private server, or whether it is a small portion that's basically called as rented server. Whatever it is, it's always a centralized data control, which means there is always someone who is controlling and who has the access to the whole server. Okay, like in case of AWS, it is Amazon who has the access to the control the whole server. In case of GCP, it is obviously the Google. In case of obviously Azure, it is Microsoft. And if you're holding your own private physical server, then in that case, you yourself are the one who is the owner of that server. But does that mean that all the data that is available on your server is controlled by you? Not fully, but yes, to an extent, you can definitely control the data. When I say not fully and to an extent, what does it mean? There might be a chance that you are not able to fully read the data that is available within your server. If in case some policies are created by the organization, then those organization might not be able to read your data. But yes, at any point of time, if they want to delete your data or tamper your data, they can do that. Okay, so at least they can delete your data. At least their server can fail and the whole data can be erased off, right? So at least that's the reason I said that to some extent they have the control over the data that you're putting, because at the end it's like living in a it's like living as a tenant in a house. Okay, so it's not your house, you are basically living in someone else's house, and obviously they have more rights. The owner of that house has more rights as compared to you. In the same way, you can just for a layman perspective, or from a layman's perspective, you can understand of this like that. Okay, now coming to blockchain distributed data storage. Over here, all of them individually act as a single point server. All of them individually act as a single point server, which means there is no such big server, there is no such big cloud space, or there is no such renting of the server as well. It is like, let's suppose we are 19 or 20 people, 17 people over here, right? So we just assume that all of us, all the 17 people, decide that all of us will contribute 100 GB from our memory, from our system, okay, or maybe 500 GB from our system. So we just all 17 people among us, we decided that let's contribute 500 GB from everyone's system. So 500 GB from each and every person's system would be specifically reserved for storing the network data. Okay, so let's suppose you have 1 TB, and out of 1 TB, 500 GB is available for your personal use, howsoever you're using it. But then the other 500 GB which you have contributed to the network would only be used for storing the network data and the network information. So what happens is, with this, what happens? You yourself are managing your data. You are actually not dependent on anybody to store your data, right? You are actually not dependent on anybody to store your data. So with this, and a very important thing is the data availability is always available, because the same data, the beauty of blockchain technology is, first and foremost, there are a lot of people who are connected to each other in a distributed manner, of course, that is one thing. And all of them are managing the same piece of data. All of them are managing the same piece of data. But then we will discuss about those things maybe probably at a later point of time. But yeah, at this point of time, at least we are clear with what is a single point server, or what is the current server architecture, and how the blockchain architecture looks like. At least we are clear with this part. So what exactly happens, how the data is stored, how it is managed, and all those things we'll discuss at later point of time. But at least we are clear with that how the data looks like from a from a top level perspective. The same piece of data, how it looks like in a single centralized server, and how it looks like in a blockchain centralized server, blockchain distributed server. So that would actually help us to understand that what exactly it is. So this is very important part for us now, but let's start from here. What exactly is blockchain? So blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions, but virtually everything of value. Okay. So this is a major difference. So I was just few minutes back, I was telling and I was explaining that there's a major difference between the Ethereum blockchain and a Bitcoin blockchain. Obviously, there are a lot of blockchain networks. To be honest, there are a lot of blockchain networks. And in today's world, I can easily say that there are at least 200 different blockchain networks that are available, that are at least known. Okay. And if I have to talk about unknowns, when I say unknowns, it means that they don't have so much of transaction and so much of recurrency of daily transaction DPS, then obviously there would be more than 1,000 blockchain networks. But at least if I have to talk about some which are known and which at least have 200 to 300 transactions happening daily on their blockchain, then also I can count 200 different blockchain networks. But is it that is it that all these blockchains are equally important and equally used? To be honest, no. If I have to say how many authentic and really useful blockchain networks are there, I would just say 15 or 20, or even 15 would be enough. So 15 blockchain networks. The total, if we talk about the total ecosystem of different blockchain networks, it's around 2000. As I just told, from 2200 are known, and from these 200, 20 or 15 at max are the one which are actually useful and which are trying which the networks which are actually trying to do something different, something innovative, and something they're taking the blockchain in a progressive way. Okay, which means these 15 are the important ones. And if I have to talk about the top 4 or 5, I mean, obviously the top one and the maximum used one, that will only be 4 or 5, which means, well, the reason for giving you this hierarchy is you need to understand what we are focusing on, what you should focus on, and what is just like a garbage that is present. Like internet, you talked about internet or a web also only has around 10% or 20% of useful data. Rest 80% of internet is garbage. You can say that it's garbage, right? Which is not holding some useful data and not taking the use cases of internet in a progressive way. It's only 20% of internet that is used in a progressive way. In the same way, in a blockchain network, when I talked about 2000 different networks that are available, out of which 200 are known ones, and out of which only 15 are the ones who are actually working towards something great, trying to do something innovative. Okay, and out of that, only 4 or 5 are, as of now, are the ones who are capturing a maximum transactions that are happening in the blockchain network. So you can say 80% of the dApps that are created in the blockchain network, 80% of the dApps that are created in the blockchain network fall in these 4 or 5 blockchains only. Okay, rest around 18% you can say is captured by the other 10, and only about 2% remaining is captured by this market. Okay, so you can understand that this is mostly just killing the blockchain use cases. Okay, why if, the second question should be that if only fine this, okay, fine, someone can become successful and someone cannot become successful, that's absolutely fine. So that explains 4 or 5 projects being extra successful and very hyped, that's fine. But I would definitely agree that there are other 5 or 10 projects which are working in a great dimension and actually taking blockchain forward. And in the coming years, definitely they would be attracting a lot of transactions and dApps on their platform as well. That's fine. So we are not talking about this. But then your question should be that what about these 200 or 2000? What are they doing? So they are not doing anything. They are just copying the existing blockchain and just with the curiosity to create a new separate and own personal blockchain, they are creating their own personal blockchain. That's it. No innovation, no additional thing, nothing new, just the copy. Because most of these blockchain projects that you will find would be open source. When I say open source, it means anybody can use it and create their own version of that software. Okay, so this is what the whole blockchain ecosystem at this point of time is. But on the other hand, what we are focusing on as a part of this course is over here. Okay, so we will be focusing majorly on Ethereum and all the Ethereum compatible blockchains like Binance Smart Chain, Polygon Matic. We'll be covering those. So this was one thing. Now, another important thing to consider is that blockchain initially was created or was invented by Bitcoin. You all know that, right? So we have already discussed that blockchain was initially created or invented by Bitcoin. And then Bitcoin in today's world can only be used. This also, I guess, I've shared with all of you that Bitcoin in today's world can only be used for transactions or payments perspective, nothing more than that. Apart from transactions and payment perspective, you cannot actually leverage Bitcoin for some other use cases. And that's what led to the discovery of Ethereum. The Ethereum founder, Vitalik Buterin, thought that it's not that we can just use the cryptocurrencies and the blockchain. So basically, his vision was that blockchain as a technology should not only be used for crypto. Okay, which means cryptos should not, when I say crypto, it's not cryptography, it's basically cryptocurrency. Okay, just to clarify. So this cryptocurrency should not be the only use case of blockchain.
Rather, blockchain should have multiple use cases. Yes, of course, crypto would be an important and one of the most primary use case of blockchain. That definitely would be fine. But then the blockchain shouldn't be restricted only to cryptos being the use cases. And that's what Vitalik started, and that's what led to, you can say, the blockchain 2.0. So Vitalik Buterin was the initiator of the era of blockchain 2.0 with the launch of Ethereum. How it was different from Bitcoin? Bitcoin only, as I just mentioned, that Bitcoin you can only use for the purpose of payments and sending and receiving funds. That's it. But on the other hand, with the launch of Ethereum, you can not just only use Ethereum for the crypto, that is crypto assets. Rather, you can put your whole business on Ethereum blockchain. You can run your own business on the Ethereum blockchain. Okay, in a decentralized and a transparent way. How, why, and when we'll discuss going forward. But yes, at this point of time, you should understand the prime differentiator between the Bitcoin and the Ethereum. Bitcoin does not support computation. Bitcoin does not support programs to be deployed on its network. On the other hand, Ethereum do support the programs to be deployed on that network, and that's what in today's world we known as DApp, that is decentralized application. Okay, so what are decentralized applications? Decentralized applications are responsible for running end-to-end businesses onto the blockchain network of Ethereum. Okay, and multiple others, of course. But yeah, the pioneer for this was Ethereum. So in today's world, blockchain as a technology has progressed a lot. Which means when I say blockchain as a technology has progressed a lot, it clearly means that it has now blockchain is not only used or known for cryptos, but rather blockchain as a technology can be implemented in multiple domains and for multiple use cases. Hope this makes sense to all of you. So this is a prime differentiator between how the blockchain was before the birth of Ethereum and after the birth of Ethereem. What's a blockchain? Blockchain is a simple data structure where each block is linked to one another and is time stamped in a chronological manner. It is a distributed ledger, a distributed digital ledger of immutable public records of digital transactions. Every new record is validated across the distributed network before it is stored as a block. All information once stored in the ledger is verifiable and auditable, but not editable, of course. Each block is identified by its cryptographic signature, that is known as block hash. If you remember from the last session, the first block of the blockchain is known as Genesis block. So whatever is the, again we discussed this, that in the chain of blocks, the first block of any blockchain network would be known as Genesis block. This is block, the first block, the second block, and this continues with every block linked to its previous block with the help of previous block hash. This figure is basically responsible for explaining how blockchain is solving the problem of centralized banks or centralized behavior of banks. So basically, you can say, so of course, if all these would have been a customer of a bank, then they would have been dependent on this bank for all the things, right? So this over here is the bank, and of course, all these are just the customers. So if Steven or if James wants to transfer some funds to Kevin, what they will be doing is they would be using the bank as a service, and they would be saying, hey bank, I want that you should deduct some money from my account and transfer it to Kevin's account and update my ledger accordingly. Okay, that's what a bank will do for you. Okay, in the same way, whenever you want anybody else, whenever you want to transfer the funds to anybody else, again you can just say to, hey bank, can you please transfer the funds to from my account to the Lisa's account and update both of us ledgers, right? And the bank will do it for you. But of course, a bank cannot. At the end, it's a request that you are making to the bank, right? Bank will never do it for free, right? They will charge some money from you. So That's the first drawback. The second drawback is if the bank is not available for some reason, maybe for 3 or 4 hours, the bank is gone and maintain it. In that period, you cannot transfer the money to anybody, right? At that point of time, the bank has clearly notified that for these from this time to this time we are under maintenance and we cannot service your request. At that point of time, if you have to transfer the funds, you don't have any other options rather than waiting for the another 4 hours until it's again back up, right? So these are few drawbacks of using a centralized authority. The bank is just an example. It can be applied to any use case. Okay. But now, on the other hand, with the help of blockchain technology, let's discuss that how you can eliminate that. So I'll just eliminate bank. And now what happens is every user has the ledger and the asset, right? The asset, which means your money, and a ledger book, which maintains the record keeping. Now what happens is James wants to transfer some funds. So yeah, back to the thing. So let's suppose in this case, if James wants to transfer the funds to Kevin, so all of them maintains a copy of the ledger and the asset of course. Now, whenever any transaction happens between James and Kevin, that transaction T1 will not only be recorded in the James ledger and the Kevin's ledger, rather this transaction T1 would be recorded in every person's ledger. Okay, rather this transaction T1 would be recorded in everyone's ledger, in the ledger of James, in the ledger of Stephen, Rahul, Kevin, Paul, Robert, Lisa. This would ensure two things. The data is available with not only one person but everybody, which would create a lot of transparency and trust factor among each other. And they actually don't have to be dependent on anybody for the record keeping. Okay, they don't have to be dependent on anybody for the ledger updation. They can do it by themselves. The only thing is it should be an open network, and who is transferring to whom should always be visible to everybody without any layer of what do you say, privacy. Even if you add one layer of privacy, that would break all the trust, because if you can have one layer of privacy, you can have obviously you can have multiple layers of privacy as well. That is the reason in Ethereum blockchain everything is absolutely public, which means anybody can do any number of transactions and all the transactions would be visible to everybody. So as we can see over here, this is Etherscan, as I told that this is a block explorer wherein you can see each and everything that's happening in a particular blockchain network, and you can see each and every block that gets added over here. You will be able to open up and see all the information of that block, and not only the information, but you can also see what are the different transactions that are present within the block. You can go in those, like this block has 137 transactions. You can go in that transaction and even open up that particular transaction and see what's present within that, like who did this, to whom, for whom it was created. Okay, so this is what is the true meaning of a public blockchain. Now, with that all in mind, now let's come to this figure. Anybody has any idea what this figure is representing with all the terms that we have heard till now? Does anybody have any idea what this figure is representing? Anything that you can make out of this figure? Yeah, so coming back to this figure, so see, this figure represents the high level topology diagram of blockchain network. Okay, so this is what I was talking about, and this is what we had to cover. So as you can see over here, the ledger one represents a chain of blocks that are responsible for holding the data, right? The ledger one represents a chain of blocks, obviously, which are holding the transactions within themselves. Similarly, we have ledger 2, again having chain of blocks and multiple transactions. Ledger 3, 4, and 5. Now, what is node 1? Node is basically a machine, obviously being handled by a human. But what is node? Node is basically a machine which holds a copy of ledger. Okay, so node is basically a machine which holds the copy of a ledger. Can there be multiple nodes in the network? Of course, there has to be multiple nodes in the network, because if we just have one single node in the network, then it is a single point server only, isn't it? Just having one single node in the server will make it a centralized server only. The reason we have it as a distributed network and a distributed system, there should be multiple nodes that would be connected to each other, and all of them should be responsible for holding a copy of ledger. Okay, all of them should be responsible for holding a copy of ledger. Now, another important thing to understand over here is that these ledgers that you see over here, all these ledgers are exact replica of each other.
Let's have a quick quiz question, guys. And the question is, how are transactions added to a blockchain? And your options are through a central server, by a group of trusted intermediaries, or by solving complex mathematical puzzles or proof of work, or through peer to peer messaging. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
All these ledgers are exact replica of each other. Does it mean that all these ledgers are holding the same data, the same blocks, the same transactions? Each and everything is absolutely same in all these ledgers? That's absolutely correct. And that is what is represented over here. Ledger 1 is equal to ledger 2 is equal to 3, 4, 5, and of course multiple nodes would be there, and corresponding to that every node they will be holding a copy of ledger, and it will be having multiple ledgers as well. Isn't it increasing the data redundancy? Because having the same piece of data being stored at multiple places, isn't it just increasing the data redundancy? Yes, we can say that. We can say that it is increasing the data redundancy. But what's more important to understand it is that this is the basic principle of blockchain technology to ensure trust, transparency, and technology, right? So to bring in trust, transparency, and security, it even if it is replicating the data, or even if it is the data redundancy is happening, that's not a big deal, right? The storage is not very costly in today's world, at least now, right? Back to when what it was 10 years or 15 years back. Okay, so coming back again over here, we have multiple nodes connected to each other, all holding the same piece of data. Till here, I think we should be good. Now, in a real-time world, how many nodes are there in a blockchain network? Is it just 3, 4, 5, or 10? No, there are thousands and thousands of nodes that are connected to each other. In a real time and a good blockchain network, there will be thousands and thousands of nodes that would be connected to each other. Now, why do I use the term good blockchain network? Does it mean that more the number of nodes, better is the security of blockchain? Yes, of course. Okay, so the number of nodes and the security of blockchain is directly proportional to each other. More the number of nodes, more would be the more secured the blockchain network would be. Okay, so with this in mind, I can say that this explains a high level view of the blockchain network wherein multiple nodes are connected to each other, having the same copy of ledgers stored among each other. And then, of course, what happens if a new transaction comes up? So, obviously, a new transaction alone will never come up. A bunch of transactions, that is, a new block will come up always. Okay, it's always a block, a new block will come up, and that new block will have bunch of new transactions. So what will happen to this block? Is it like this that it goes to one and that ledger updates every other node? Is it like that? Of course, it is not like that. Because if it is like that, then again everything is dependent on this node, now, right? So everything would be dependent on this node because might be that this node got some block A and it propagated block B to everyone. So that is not the case. It is basically a boot node. There's a concept of boot node. So this is this boot node. So this boot node is responsible for syncing the blocks directly from the network to all these independent nodes. And this boot node is not controlled by anybody. It is pre-programmed as a part of consensus algorithm. Oh, great. One more new term, consensus algorithm. We will learn about that in detail. So at this point of time, we need to understand that there is a concept of boot node, which is responsible for taking in the new block and syncing it in all available existing nodes. Great. Till now, everything is clear. But what if, what if one of the node is down? Maybe it is facing some technical issue, or there is no internet, or there is no power, or there is the space of that particular node is filled up and it does not have any more space to accommodate new upcoming transactions and blocks. What will happen in that case? Of course, in this case, the syncing would stop for that particular node and would be automatically resumed as soon as it is restarted. Okay, so automatically it would be resumed as soon as the whatever technical issue that particular node was facing. When as soon as that technical issue is resolved, the syncing of the transactions and the syncing of the the nodes by the boot nodes would be automatically started. So now this guys that we are seeing over here is basically a multiple nodes having multiple ledgers, having multiple transactions. That's fine. Now this again, one important thing to understand over here is that this brings in lot of trust, transparency, and security. Okay. So before we move to that part, I would like to understand from all of you is whatever we have discussed till now, is that clear to all of you? First thing. Second thing, I would want you guys to tell me with this network in place, how you can say that this brings in utmost level of trust, transparency, and security. Can anybody guess that? And before guessing, make sure you don't have any questions. If you have that, then that would be prioritized first. The use of boot node is to make sure that all the nodes are in sync with each other. Okay, the only use of this boot node is to ensure that all the other nodes are in sync with each other. You might think, right, that see or find that all these blocks are connected to each other, right? That is fine, but how are they always in sync with each other? Who is ensuring the synchronization of these blocks? It is that boot node. Okay, so the boot node is responsible for getting any new block and updating that block in all the nodes that are active, of course, and ensuring that all the nodes are in sync with each other. Hope that makes sense. So now another important thing is how does it brings in utmost level of trust, transparency, and security. So for that, a clear thing, as you can see over here, we have, uh, of course, it brings in a lot of trust and transparency. A clear reason for that is the same piece of data is being stored at multiple nodes, right? Same piece of data is being stored at multiple nodes, and all these data are immutable. All these data are immutable, which means nobody can tamper these data, nobody can edit, modify, or delete these data. Okay, So that is the reason it brings in utmost level of trust and transparency. Now, next important thing is how does it brings in lot of security? How does it brings in utmost level of security? A clear reason for that is whenever we talk about a blockchain network, then a blockchain network, as we say that we have multiple nodes, it is equally difficult to actually tamper the data as well. So when we talk about security, what does it mean? Security means tampering the data. It's not stealing the data, right? It's tampering the data. So whenever it is about tampering this data, it is very, very difficult. The reason for that is, yeah, Bhavani. So there's no one in charge of boot node. It is automated process that is defined within what do you say? That is defined within the consensus algorithm itself. We'll discuss about consensus in detail as we move ahead. Okay, so coming back to this diagram, so we have multiple nodes having multiple ledgers, and how is security ensured about all these nodes and ledgers? A clear way to understand this is that as over here you can see, let's suppose if node 1 alone wants to tamper some data within its blockchain. So node 1 wants to replace this block over here with a new block of its own. Want to replace this block with a new block of its own. Even if node 1 does it in their own system, right? Obviously, if I'm having my own system, I can do anything in that system, right? So of course, node 1 can do that. But is that enough for this block to be updated and everybody should be synchronized? No, because you are not the source of data creator, right? You are just the one who can ensure that the data is always in sync. Okay, you are the one who receives the data, not give the data to the network. So even if you try to change or tamper one of the blocks from existing block, the other nodes would not agree to you. The other nodes would not agree to you. And when I say that the other nodes would not agree to you, it means that at least it means that if you want this block actually to be tampered, if you want this block actually to be changed in that blockchain network, you will not only have to change it in your node, but at least in 51% of the nodes. Okay, you will not only have to change it in your node, but at least in 51% of the nodes. If for some reason and if at all you were successfully able to tamper it in 51% of the nodes, then of course this data can be tampered, which means if 5 blocks are there, what would be 51% or more than 51%? It would be 3 nodes, right? Out of 5 nodes, you have to modulate this data in 3 nodes, which means one two you can do easily in your, which means in other two you will have to do it, which means only in other 2 nodes, if you are able to do it, you'll be able to say that you have hacked the blockchain network. And now you would understand that why did I say that more the number of nodes, more secured the network is. Now just think, in place of 5 nodes, what if there are 50,000 nodes? In place of 5 nodes, there are 50,000 nodes. And now if any single node want to malfunction and change the block from any other block, and now how many blocks this node will have to change? At least 25,000 more blocks, right? At least 25,000 more blocks have to be tampered. Then only you can say that you have hacked the blockchain network, right? So more the number of nodes, more secured the network. Because there is no such rule, that is the reason lot of the networks out there are just running their own blockchain with just 1 or 2 nodes, which is practically not even blockchain, right? That is the reason 2000 different blockchain networks are running, which are just waste of data and automatically taken care by the blockchain owner who creates the blockchain. Today, if I want to create my own blockchain network, I'll create it with one or two or three nodes. And then, of course, it depends on me how many more nodes I want to add. So now I think this clearly explains how blockchain brings in utmost level of trust, transparency, and security. When I say that blockchain brings in transparency, trust, and security, it doesn't mean that the current applications and current technology is not trustworthy, is not transparent, or it's not secure. No, it's not like that. They are, of course, they are. But the level of trust, the level of transparency and security that blockchain is providing, that is absolutely unmatched with any other technology, right? Because this is the maximum that you can go for having a secured or having a transparent network, right? I am having one data, same data you are also having, without any third party in between. This is the utmost level of transparency you can maintain, right? So that's the reason it's bringing in utmost level of trust, transparency, and security. Did blockchain take more space to manage data in all nodes? Yes, of course, because its data redundancy is happening now. So of course, it will take a lot of extra space in comparison to a centralized single point centralized server. Of course, as many number of nodes, that many times extra space it will take. Let's suppose if you want to keep 1 GB data on a single point server, it will just take 1 GB data. But if you want to take, or if you want to keep 1 GB data on a blockchain network with 100 nodes, it will take 100 GB data, which is 100 times more than what it could have taken on a single point server. As many number of nodes, that many times the data storage capacity increases. So this was an important part, and now you should be fundamentally clear, at least with what is blockchain and how it works. Response time of ledgers. So see, for getting the data, it's not like you can get it the way you generally query a DB. Okay, in case if you want to just get the data, but of course, if you want to post a data and you want that transaction should be submitted and successfully updated onto the blockchain network, that would definitely take some time, and it depends on different blockchain networks. To be honest, in Ethereum, it takes around 30 to 40 seconds for a transaction to be updated, whereas on a Bitcoin network, it takes about 1 hour for a transaction to be updated. And there are a lot of fast blockchains also that have came up, like we have BSC and Matic and Solana. They are very, very fast, and their transaction can be processed just within 1 or 2 seconds. So now another important part of our discussion would be consensus algorithm. Now let's try to understand what exactly is a consensus algorithm. So whenever we talk about consensus algorithm, it is the heart of any blockchain network. What does it mean that it's the heart of any blockchain network? So consensus algorithm can be related to operating system. Okay. So let me tell you a small layman example for this, and you'll be able to relate it better. So the way in all our machine that we are using right now, maybe it is a tablet or a mobile phone or a laptop or a desktop, whatever it is, there will be some specified operating system that are installed within your device, right? Unless and until or without that specific operating system, your device just becomes a piece of hardware, which technically is of no use, isn't it? So your device just becomes a piece of hardware which is of no use. So it is the operating system which actually gives life to your device. Okay, it is the operating system that takes care of lot of things like kernel, the input-output management, the process management, the time management, the time scheduling, the memory management, the disk space management, and multiple other things that are not visible to you, right? They are not applications. It is happening. It is internally processing those things and ensuring that you have a smooth functioning or you have a smooth functioning with your hardware, right? So it is all being done by the operating system in the background. In the same way, consensus algorithm also is like that only, which is running in the background. It's like a pre-programmed software which is running in the background of the blockchain network, You cannot see it or feel it actually, but then it is responsible for all the transaction management, the transaction lifecycle management, the nodes management, how the transaction would be updated, how the nodes would be in sync, how the blocks would be created, who will create the blocks, whose block would be the final one. Everything like this is decided by consensus algorithm. And when I say it's decided by consensus algorithm, it's not a person who is deciding it, but it's something that is basically a protocol, and on the basis of those protocol things are being defined automatically. Okay, so the consensus is the key or the heart of any blockchain network. The way, another important thing is there are two different types of uh, developers in the world. Okay, the one who work on the operating system and the one who develop applications that are built or to target a specific operating system. I hope you would agree to this as well. Like there would be someone who has created or who is working on the maintenance of the operating system like Android, iOS, Mac OS. Of course we have Windows, and there are a lot of, every time a new version of Windows comes up, right? So there are a lot of developers who are working on the core operating system programming. And then there are people, a majority of people, you can say a majority of developers are the one who are developing applications that should target a particular operating system. Like someone is proficient in developing Android application, someone is proficient in developing iOS application. So they are not actually doing anything on the operating system level, but they are creating the applications that can target a particular operating system. Right? If I develop an Android application and if I try to run it on a Windows or a iOS operating system, it won't be working over there, right? So that in the same way, if I talk about the blockchain network, again, the decentralized applications are built to target specific blockchain. The decentralized application that we will be developing would be built to target a specific consensus or a specific, what do you say, blockchain only. It's not that the dApps that we create can be deployed on any blockchain network. No. The way how specific application developers creates application that are targeted by a specific operating system, in the same way the decentralized application developers creates decentralized application, aka dApps, that are only specified or limited to run on a particular blockchain network. Is this concept of consensus algorithm clear to all of you, what it is and how can it be related in our day-to-day life? Perfect. So I hope now it's clear to all of you. Now that we have understood the consensus algorithm, we'll try to see what are different types of consensus algorithm that are available in the market. So we have proof of work, we have proof of stake, we have proof of POET, proof of elapsed time, POA, proof of authority, proof of staked authority, proof of POE, that is proof of equity, and a lot of others are there. Proof of energy, a lot of other are there. But if I have to talk about the majorly used ones, it is this: proof of work, proof of stake, and proof of elapsed time, sometimes also known as RAP. But anyway, let's stick to proof of elapsed time. So, proof of work. With the name only, you can understand. Proof of work means you do some work, you prove that you have done some work, and take the reward, right? So, proof of work is just like you will do some work first, then you'll have to submit a proof that yes, you are the only one who has done that work. And once you submit the proof that yes, you are the one who has done that work, then post that you will be rewarded. That's proof of work. Bitcoin and Ethereum till September 2022. Okay, Bitcoin still and Ethereum till September 2022 was using proof of work, and proof of work was one of the major consensus algorithm that was being used. Okay, but post September 2022, Ethereum 2.0 was launched. Ethereum 2.0 was launched. Now, what is this Ethereum 2.0 and everything? We'll discuss about that. Not as of now. But yes, important thing to consider is after September 2022, Ethereum changed or migrated completely from proof of work to proof of stake. Now, what is proof of stake? Can anybody guess anything like what a proof of stake can be? So yeah, when we talk about proof of stake is basically a way to ensure that you know the chance is given only to the people, or the reward is given only to the people who have more stake in the network. Obviously there might be a confusion in all of your mind that what this reward is that I'm talking about. What does it mean, that who gets rewarded, what reward do they get? Obviously that's one thing, and let it be a mystery for now. We will understand that thing moving ahead. But as of now, the important thing is to understand what is proof of stake. So proof of stake is basically a kind of consensus algorithm wherein you have to stake some of your own asset in the network. You have to stake some of your own asset in the network. And more is your stake in the network, more would be your staking power. Okay, more is your stake in the network, more would be the staking power. And the more is the staking power, the more is the staking power, the more are the chances that you would be getting for validation, and accordingly the rewards that would be generated would be more. Okay, so everything is dependent on your stake in the network. The more is your stake, the more are the chances that you would be getting, and because you will be getting more chances, more are the rewards that you would be generating. Okay, so this is what happens in a proof of stake consensus algorithm. It's not that if you have more stake in the network, you can outpower the consensus algorithm. No, all the networks and the regulations still have to be followed by you. Either only in crypto or in native assets like Ethereum, that completely depends on that particular blockchain platform, what they are allowing for the currencies to be staked. If they're allowing multiple currencies to be staked, you can do that. Or if they're only allowing Ethereum to be staked, then of course you will have to do it only using Ethereum. So now we'll actually move ahead and try to understand what's POET. At last, we have POET, that is proof of elapsed time. So proof of elapsed time is only applicable to private blockchain. And what happens in POET, that is proof of elapsed time, is that the blocks are automatically created after every certain interval of time, which means over here, there is no concept of rewards. You can just understand it like this. There is no concept of rewards in proof of elapsed time. Rather, everything is pre-programmed and it happens automatically. You can understand it like this. Okay, so like over here you have someone has to do the work. Over here also someone has to do the work, but not on the basis of how capable they are, but on the basis of how much stake they have put in. And over here no one has to do any work. Okay, so it's like automatically a program has been written which will automatically create block after every few certain amount of time. That is proof of elapsed time. So as soon as some of the time will elapse, automatically a new block will be created. As of now, you just have to listen and learn about the definition part. You don't have to deeply understand it. The reason for that is it will be more clear to you when we will be actually discussing about their respective use case scenarios. Then it will be more clear and more relatable for all of you. But as of now, you should just understand, okay, proof of work is where you have to do some work, prove it and get the reward. Proof of stake is where you have to put some stake. Higher is your stake, more the work you'll be getting, and more the work you'll be getting, more the reward you'll be getting. In proof of elapsed time, there is no concept of reward only. Everything happens after every certain interval of time is elapsed. So yeah, more importantly, we can say that the transactions are initiated by users, and of course through the wallets. Okay, so wallets, if you remember, are important ways of initiating the transaction by signing it, right? So whenever you have a wallet, if you remember, wallets are responsible for connecting you to the Web3 world. So whenever you are initiating a transaction, of course, you are initiating that transaction for the Web3 world only, right? So if you want your transaction to go and hit the Web3 world, there should be a communication channel through which you can actually connect to the Web3 world. And that's where the wallet helps you,
right? That's where wallets helps you. Wallets helps you to connect to the Web3 world easily so that you can initiate the transaction. How they are propagated in the network, we'll see how the transaction goes inside a block and how the block goes and becomes part of the ledger. All those things will be discussed over here. Now, let's just have a quick look of this diagram. You don't need to explain it, you don't need to understand it, but just have a quick look of this diagram. Just go through this diagram and then I'll explain it to all of you. Now let's try to understand it. So see, what's happening over here is we have the transactions that are being initiated. Okay, of course, the transactions that are being initiated would be initiated by peers and people. Once the transactions are initiated, where they go, that place is known as mempool. Now, what is this mempool? Mempool is like a local node copy of all unvalidated and unconfirmed transactions. Sounds complicated, I know. What does it mean? Let's try to understand. So what happens is every miner will have a dedicated space. Every miner will have a dedicated space that will only be reserved for unconfirmed and unvalidated transactions. It's like a pool where all the unconfirmed and unvalidated transactions will come and reside. Now, when all the unconfirmed and unvalidated transaction comes over there, it comes and sits over there ideally. Now, what happens is, okay, another important thing is, does it mean that all the transactions that are initiated, they go to each and every miner's individual mempool? Yes. Every transaction that is initiated goes to each and every miner's individual mempool. It's not like there's a common area which is shared commonly by all the miners. No, every miner specifically individually have their dedicated area that's known as mempool. Now with this mempool, when anybody comes and takes it, the transaction comes and reside in the mempool. And when the transaction resides in the mempool, then after that, a miner can choose any transaction that they want to validate. Okay. Now what miner does is, first and foremost, miner creates a candidate block. Please understand this very carefully because this is the transaction life cycle of Ethereum blockchain. Okay. So you need to Ethereum or any public blockchain, like even for Bitcoin. So you need to understand this very carefully. Okay. So now what miner does is miner creates a candidate block. Okay, miner creates a candidate block. So when I say that miner creates a candidate block, is it the actual block that we have been talking about till now? No, this is not that actual block. Rather, this is just a candidate block, or you can say a unconfirmed block. Okay, so every miner will create their own candidate block. Once every miner creates their own candidate block, then what will happen is all of them will start validating the transactions from the mempool and will start putting it in the candidate block. All the miners will start picking up the transactions from the mempool one by one as per their choice and will start validating it and then will start putting it in the candidate block. Once these transactions are moved to the candidate block, then of course, what happens is consensus launches a puzzle. Okay, consensus algorithm launches a puzzle, and this puzzle has to be solved by the miners. So consensus algorithm will come and launch a puzzle in the block in the whole network. So there will be a puzzle that will be launched by the consensus algorithm, and the intention to launch this puzzle is to ensure that who is able to solve this puzzle and include the header of the puzzle, I mean the solution of the puzzle in the header of the block. Now, important thing to understand over here is this is what proof of work means. What is proof of work? It is the solving of puzzle that is work that has to be done. What is the work? Like whenever we talk about proof of work, then you have to do some work and you have to prove that yes, you have done it. And once you have done it, then you'll be rewarded, right? If we break down into 3 or 4 parts, then do the work, prove the work, and get the reward, right? So what is do the work? Do the work is solving this puzzle. Okay, doing the work is nothing but solving this puzzle. Fine. So let's suppose miner M1 solved this puzzle. There will be a solution of the puzzle. How does this mine next part is prove the work. So how does anybody prove the work? By putting or showing the solution that that particular person has found out. If I have solved some puzzle, how can I prove that I have solved it? I'll show the solution that I have got to everybody. Let's see, guys, I have solved this puzzle and this is the solution that I have got, right? So what this miner does is he will include the solution of the puzzle in the header of the block. You remember header of the block? Header of the block has 5 or 6 different fields, and then below is the transaction list, which contains all the transaction. In the header of the block, as I told, like there are 5, 6 different fields, but till now we were only familiar with one parameter, that is previous block hash. But just now we got familiarity with yet another parameter that is known as nonce. Nonce, nonce. What is nonce? Nonce is the solution of the puzzle that has been solved by the consensus algorithm. I mean, by the miner, which was launched by the consensus algorithm. So nonce is nothing but solution of the puzzle which has been solved by this miner. So doing the work is solving the puzzle. Proving the work is including the solution of the puzzle in the header of the block. And at last, if you actually were able to solve the puzzle before any other one, okay, if you were only able to solve the puzzle before any other one, then only your block will go and become the part of the main blockchain ledger. Only your block will go and become the part of the main blockchain ledger. Does it mean all other miners block would go waste? No, not exactly go waste, but it's like, yeah, obviously they failed and they will again have to wait for another puzzle. They can keep the same block which they have created, but they'll have to wait for another puzzle, again give a try to solve it before anybody else does. And if they are able to do that, then only they'll be rewarded. So the last part, okay, do the work is solving the puzzle, prove the work is including the solution of the puzzle in the header of the block, and getting the reward is when your block will be updated on the main blockchain ledger, or it will go and become the part of main blockchain ledger. This is the ledger, right? So when your block goes and becomes the part of main blockchain ledger, then you will be rewarded. Then miner one will be rewarded. So all in all, we can say that a transaction is initiated, it goes to the main pool of each and every miner. Every miner will have a common pool of unvalidated and unconfirmed transaction. The miners will pick it up on their with their choice, will validate the transaction, will put it in their candidate block, will pick up another transaction, again put it in the candidate block, another transaction, again put it in the candidate block, till they will keep on picking the transaction and validating it and putting it in the candidate block till the consensus launches a puzzle. As soon as the consensus launches a puzzle, they will just stop doing all the other activity and just focus on the puzzle to be solved. Whichever miner solves the puzzle first, all those his particular block with all the independent transactions will go and become a part of the main blockchain ledger, and accordingly that miner will be rewarded. So this is how a transaction from a user goes to main pool, then goes to candidate block, and then goes and becomes the part of the main blockchain ledger. So it's like, see, the puzzle basically is simple. Okay. So it's a basic mathematical puzzle. It's nothing like, something that can be exemplified over here. It's a highly computed mathematical puzzle, which is solved by the machine, created by the machine, for the machine, and solved by the machine. Okay. So it's just a highly complex or complicated mathematical puzzle. That's how you can understand it. Why it is created, how it is created, we'll discuss once we go to the mining section. See, mempool has unvalidated data, but candidate block, of course, has validated transactions, right? Miner picks it from mempool, validates it, and then put it in the candidate block. So that case is known as double spending. Okay, so it's always ensured that the transaction that you have initiated first will be validated first, and then only the second transaction would be validated. So if you have 10 rupee, and if you have already initiated a transaction of 10 rupee, before it gets validated, you initiated one more transaction of 10 rupee. So unless and until your first transaction gets validated, the second one won't be validated. And as soon as your first transaction gets validated, automatically the second one will fail. The state of instances are always maintained. Okay, so irrespective of which transaction gets confirmed, if two transactions are initiated from one account, it is always ensured that one transaction gets validated and then only the other transaction will be validated. Two transactions can never be processed parallelly. That's what. So if the first transaction gets validated, the second one would fail. If the second transaction gets validated, the first one would fail. The miners are not employed. Okay, it's just that they are working on an incentive model. So they want to earn. Even you can become a miner. If you want to earn, you can become one of the miners and start earning. So it's not an employment, it's just associating with a blockchain for earning purpose. So when we talk about the properties of a distributed digital ledger, what are a few properties of a distributed ledger? So we have, first and foremost, it's distributed, of course, which means all the participants in the network have full copy of ledger for full transparency. And then, of course, they are anonymous, which means the identity of the participants is either pseudonymous or anonymous. Then all the transactions that are happening on a distributed ledger is always timestamped. Each and every transaction is timestamped. Then unanimous behavior is maintained for all the participants of the network. All the transactions that are written onto the blockchain is immutable. Oh, sorry, not blockchain, but distributed digital ledger. It's all immutable. Any validated record are irreversible and cannot be changed. All of them are secured, and of course, they are programmable. So these are the basic properties of any distributed ledger. And you would say that isn't it the same? The same thing applies for the properties of blockchain as well. Yes, exactly. And that is the reason we say that under the hood, blockchain uses DLT. Under the hood, blockchain uses DLT, that is distributed ledger technology, which means under the hood, blockchain is completely dependent on DLT for the user management, the data management, and everything. So the one of the most important line is mentioned over here that all blockchains by default are distributed ledgers, but not all distributed ledgers are blockchain. Okay, what it means is it clearly means that distributed ledgers are superset of blockchain, right? Distributed ledgers are superset of blockchain. If this is DLT, then this is blockchain, which means all blockchain will obviously fall in part of DLT, but necessarily it is not important that all DLT has to be blockchain because DLT is superset of blockchain, right? So that's very important. I hope this makes sense to all of you. We have Git. If you are familiar with GitHub, that's again a distributed ledger, and we maintain the data in a distributed manner, and that's not a blockchain. Okay, so then we talk about comparing the popular blockchain. And for this, you can just ignore our recorder for now, and you can just have a understanding of Ethereum and Hyperledger with a perspective of Ethereum being a public blockchain and Hyperledger Fabric being a private blockchain. Again, this is just a pictorial representation of how a centralized and a distributed ledger looks. Centralized ledger, clearly you can see that there's a centralized clearing house which is responsible for taking all the decisions and ensuring that everything is cleared by the centralized authority. And on the other hand, when we have a distributed ledger, all the different banks are connected to each other in a distributed manner. All of them maintain a copy of the ledger exactly like, okay, I removed that image. exactly like the one that we already saw in the previous image. Remember, each and every person were maintaining their own ledger. In the same way, over here in a distributed ledger, each and every bank is maintaining the copy of ledger, and the transactions that they are doing would be represented and would be acknowledged in each of their own ledger. So yeah, now we'll be moving ahead and starting a new topic of blockchain structure. So block structure means now we're going to study and learn about the header of the block more importantly. So let me just draw a diagram. So the top part is block header and this is transaction list. Okay. So right over here, obviously this is all nothing but a list of all the transactions that we have within our blockchain, right? I mean, this particular block. When we come to block header, what are the fields that we have already discussed and we are aware about? Previous block hash, nuns. Obviously, we just know, as of now, we just know these two. So that's fine. So now another important thing is that now that we are familiar with previous block hash and nuns, I hope everybody knows what's previous block hash and nuns, right? Anybody who has any doubt in this? We have already discussed this. Okay. So I hope this makes sense to all of you. Now, another parameter that we'll be moving ahead and learning about is timestamp. Timestamp basically represents the time when the block was created. Timestamp basically represents the time when this particular block was created. So we have covered, okay, we have covered nonce, we have covered previous block hash, we have covered timestamp. Another important thing is version number. So let's try to understand what's a version number. Now moving on to the version number. So when we talk about version number, of course, version number basically represents the version of a particular block. So see the way how the operating system keeps on upgrading itself, right? The operating system also after every few interval of time or after every certain interval of time, you'll see that the new versions of operating system comes up, right? So when these new versions of operating system comes up, then of course even the consensus algorithm, like operating system, even consensus algorithm keeps on upgrading from time to time. So to track the change in the version number of the consensus, okay, to track the change in the version number of the consensus, we have this concept of version number. Okay, so in each and every block, we store the current version number of a block with in sync with the blockchain network. So whatever is the current block number and whatever is the current version of the blockchain, it will be stored in the current block so that we can actually figure it out that from which block the version changed. Okay, so we can say that from block number 1135802 to 1135803, as soon as it moved from 1135802 to 1135803, the version of the consensus changed. Okay, so to track the change in the version of the consensus, we have this version number and we maintain it. Okay, that's great. So now we'll move on to the last parameter, that is an important one, that is known as Merkle root hash. And to understand this, we'll actually have to understand the concept of, let me just pull up a diagram for Merkle root hash, and then we'll understand what it is. So let's suppose I have to search for a particular transaction. For some reason, I have to search a particular transaction. Now, if I have to search a particular transaction, the hash of that transaction is this. This is the hash of the transaction. Now, typically, one important thing to explain all of you, it's a fun fact, that's it, nothing else. Size of one Bitcoin block is 1 MB. Yeah, size of one Bitcoin block is 1 MB. And the maximum number of transactions that can be accommodated in a Bitcoin block is 4,000. maximum number of transactions that can be accommodated in a Bitcoin block is 4,000. Does it mean that every block will have 4,000 transactions? No, of course not. It is the maximum number of transactions that can be accommodated within one Bitcoin block. What is the maximum size or what's the capacity of one Bitcoin block? It's 1 MB. Let's suppose if I send you a notepad file with 3 lines and I send you a notepad file with 300 lines. Although both are notepad files only, just .txt file, but both will have a different size, right? In the same way, whatever data is flowing with a transaction will define the size of that transaction. A maximum of 1 MB. It's not the block size is 1 MB. See, my hard disk size is 1 TB. Okay. Does it mean that every time my hard disk will be completely filled with 1 TB? No, right? That depends on how much data I'm storing. But the maximum size of data that I can store in my hard disk is 1 TB. In the same way, the maximum size of data that can be accommodated within one block of Bitcoin is 1 MB. It's not important that every time we will be storing 1 MB. Maximum number of transactions that can be accommodated within a Bitcoin block is 4,000 transactions. But again, it does not require that every block will have 4,000 transactions.
Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
So we'll try to deep dive and understand what exactly is a Merkle root hash. So to understand Merkle root hash, let me pull up another image. So let's suppose first of all, we'll understand the need of Merkle root hash or anything like that. And then we'll try to understand what it is and how does it work. So let's suppose over here, we have obviously in a block, we have multiple transactions, right? A maximum of 1 MB of transactions, especially in Bitcoin, a maximum of 1 MB of transaction or 4,000 transactions can be stored within a block of Bitcoin. But as I already told to all of you in the last session, that it's not important that every time we have all this 4,000 transactions or 1 MB of transaction always completely filled in a block, right? So to actually accommodate this, we might have sometime we have 3,200 transactions, sometime we just have lower number of transactions. So any number of transactions can be present inside a block, and there is no such restriction or any condition put on that. So now let's suppose in a block, we have 3,200 transactions and we have to search for a particular transaction. Let's suppose within a block, we have 3,200 transactions and we have to search for a particular transaction with this transaction hash. What would be our common approach to actually search for this transaction? Obviously, we have multiple blocks that are available, right? So firstly, we'll go in this particular block and we'll go through all the 3,200 transactions, independently match this transaction hash with all independent 3,200 transactions. And then whatever matches, if we have a match within this, well and good, else we'll move to the next block. Then we'll start searching this hash, this transaction hash will start matching with all the transactions present in this block, right? Which means we'll do 3,200 searches in this block, 300 searches in this block, 2,400 searches in this block, and this will continue to happen and happen till we find this transaction in a particular block, right? Till we find this transaction in a particular block. So this obviously is a very time consuming process and it will definitely take a lot of time, right? So what we do to encounter this problem, or what do we do to ensure that it actually does not take so much of time? Okay, what we do is we'll create a unique hash that represents all the 3200 transactions present inside a block. Okay, so if from a generalized perspective, we can say that we'll create a unique hash that represents all the transactions that are present within a block. Okay, all the transactions that are present within a block would be represented by one single unique hash, and that one single unique hash would be known as Merkle root hash or root hash or Merkle tree hash, whatever, there are multiple names. Okay, so at least now you understand what is the need of this hash. The need of this hash is simple. Rather than doing 3200 searches just in one block, if we just have one single hash that represents this whole 3200 transaction, okay, then obviously then this hash would just be matched with that Merkle root hash that is representing all the 3200 transaction of this block. And if it matches, well and good. If it does not match, then we'll simply go to the next block. So rather than doing 3200 searches within a block, we just did one search within a block. That is, we mapped through some algorithm, we just checked if this hash is a part of this Merkle root hash or not. And with the help of that, we just saved 3200 transaction searches. Similarly, when we go to the next block, again, we'll just compare this hash with the Merkle root hash of second block. If we found, well and good. If we do not find that particular hash, we'll go to the next block. Again, just compare this transaction hash to the Merkle root hash of the third block. So in this way, what exactly is happening? So let's suppose an average of 2000 transactions are present in a block. So just assume that there are around 2000 transactions present in per block. So how many searches we'll have to do? If we find the transaction in the nth block, we'll have to do n times 2000 searches, right? N times 2000 searches. But with this Merkle root hash, this 2000 gets eliminated and we just have to do n searches. So if our block is found in 1500 block, we just have to do 1500 searches. But if we do not use this Merkle root hash, then if our block is found in 1500th block, then we'll have to do around 3 million searches, right? 1500 multiplied by 2000. That will be 3 million searches, right? We'll have to do 3 million searches. So you can just see the figure difference, 3 million searches and just 1500 searches. That's a huge difference, right? So this is the benefit of Merkle root hash, and it was created so that the search algorithm can work better and faster. Okay, although we directly as a developer, we don't use it in our day-to-day life, because this is something that is taken care by the consensus algorithm for searching a particular transaction that you see. Okay, so whenever you search, whenever you make a query to the blockchain, and whenever you make a query to the blockchain, the blockchain will return you the data by actually following this Merkle root hash within the block. Okay, so I hope this makes sense to all of you. Merkle root hash is created with a perspective to ensure that our transaction counts that are present within the transaction hashes are very less, and we have to do less number of searches within a particular block of transactions. And this helps us in ensuring that the transaction response time is very faster in comparison to the one that we do without the Merkle root hash. It's not a unique identity of a particular transaction, but it's a unique identity of all the transactions that are present within a block. Not exactly duplicate, but it would be something that would be created from all these 3200 transactions. So it would have the
the ingredient, you can say that these 3200 transactions would act as ingredients for creating that one single unique hash that is known as Merkle root hash. And because that Merkle root hash is created using these 3200 transactions, so it will have the traces of all these 3200 transactions. And for that, we can easily find out that if a transaction hash belongs to a Merkle root hash or not. So although this we were going to cover, so how let's first understand that how this Merkle root hash is created. Maybe that would clarify it little more. So let's suppose this is one transaction, this is another transaction. Let's suppose a block just has 8 transactions. Okay, a block just has 8 transactions. How this Merkle root hash is created is we concatenate the first two transaction hashes and then hash it. So this gives us one unique hash. Again, we concatenate these two, means we add these two hashes and hash it, gets another hash. Concatenate hash gets another hash, concatenate hash get another hash. Now we have 4. So concatenate hash get another hash, concatenate hash get another hash. Again concatenate hash get another hash. So this one single hash that remains at the end becomes the Merkle root hash. How this Merkle root hash is created? From all these independent transactions that were present inside a block. So because all these transactions are the one who have been responsible for creation of this Merkle root hash, we can find out whether the hash that we are searching for is a part of this whole transaction list or not using this Merkle root hash.
Let's have a quick quiz question, guys. And the question is, what is a smart contract in the context of a blockchain? And your options are an agreement between blockchain users, a computer program that automatically executes contract terms when conditions are met, or a type of cryptocurrency wallet, or a security protocol used for encryption. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. Repeat. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
Yeah, like as I told, there is a specific algorithm that is separately written within a consensus for the matching of this transaction hash with the Merkle root hash. Okay, so although in our day-to-day life we don't do this, this is just the internal functioning of how the transaction searches happens within the blockchain. This is just for our understanding, although as a part of our blockchain developer lifecycle, we'll never be actually using it or implementing it. So yeah, Merkle root hash or Merkle tree hash, all are the same thing. They just represent this top hash that is defined over here. So if we go down and see what's Merkle root hash, so as you can see, it's also known as binary tree hash, a data structure used for summarizing and verifying the integrity of large sets of data. It contains cryptographic hashes. So L1, L2, L3, L4 that you see over here, these are nothing but the independent transactions. And then you hash these transactions and combine it, again hash it and combine it. You keep on doing it until you get one single top hash. Once you get this one single top hash, then what happens is, once you get this one single top hash, then this hash is known as Merkle root of a Merkle tree. Okay. So a block of one or more records is collected. Such records are hashed. Then these hashes are paired, again hashed, again paired, again hashed, again paired, until a single hash remains. And this single hash is known as Merkle root of a Merkle tree. For that, there's a separate algorithm which is followed by consensus itself.
Yeah, some kind of decryptographic hash algorithm that they use for just finding the salt of a particular hash within. Salt is basically the one that is used for generating the hash from a cryptographic algorithm. So they use some kind of salt to just to trace that if the presence of a data is present within a particular hash or not. So it will not exactly decrypt or it will not exactly dehash a particular value, because dehashing is something that is not at all possible. So once the data is hashed, we can never, it's always unidirectional, it's never bidirectional, but at least we can get to know that whether a piece of data is available within a cryptographic hash or not. So using those kind of algorithms, they try to find whether the availability of a particular hash of transaction is available within a Merkle root hash or not. See, developer will develop a decentralized application that will initiate a transaction. The transaction will go and sit inside a block. So the developer is only responsible for sending that transaction and receiving that transaction. Now, how the transaction is getting searched within a block, a developer, a DApp developer or an application developer directly does not control that. Maybe a protocol developer will have to look into that, but not an application developer. This is not a transaction. What you see over here is not a transaction. These are independent blocks. Okay, 0, 1, 2, 3, 4, 5, 6. They're all blocks. This whole thing is a representation of this seventh block. Okay. So what seventh block header will contain? It will contain the previous block hash of sixth block. It will contain combined value of ABCD that is coming from here. It will contain timestamp. It will contain nonce, everything that we have seen in the header of the block. So it is that. So yeah, once again, like this representation will just clarify everything that we have discussed so far with respect to the block structure. So what are the different things that are placed in the header of the block? And this specific, the combined value of ABCD will give the clarity about the Merkle root hash. And yes, adding to that, of course, this is only for the even number of transactions. Let's suppose if we have A, B, C, D, and of course, as you asked, so what will happen if in case we'll have the odd number of transaction like 0, if assuming that this was transaction, then 0, 1, 3, 4, 5, 6 will form a pair among each other. But what will happen with the seventh transaction? So for that, this is the case. So it's let's assume that we have odd number of transaction. So over here we have 7 transactions. So 0, 1 gets paired, 2, 3 gets paired, 4, 5 gets paired, 6 will be hashed with itself. And then again we'll have 0, 1, 2, 3, 4, 5, 6. And again, this process of hashing and pairing will continue until we get one single top hash. So see, what happens is in a block, there might be multiple number of transaction. And if I have to search for a particular transaction, I'll have to go in each respective block and search for all the transactions that are present within that block, right? So overall, let's suppose if my transaction, if I'm finding my transaction in the nth block, and if every block has 2000 transaction, roughly I'll have to do n into 2000 transactions. So if I have found the block in 1500th transaction, so roughly I'll have to do around 3 million transactions, 3 million transaction searches. But using this Merkle root hash, which is nothing but the representation of all the transactions present within a block, for one block, I'll just have to do one search. For another block, I'll just have to do one search. And because for every block, I'll have to do one search, this n into 2000 get reduces to n, which means rather than doing 3 million searches, I'll just have to do 1500 searches. So this is how this helps. The level of hashing depends on how many transactions are there. Let's suppose if we have just 6 transactions, so only 3 levels will be there, right? But if we have 300 transactions, obviously more levels will be there. But the thing is, at the block level, you'll always have to search the transaction through transaction hashes. Of course, if we go in Etherscan, then in Etherscan, we can search using any way, right? Etherscan is a block explorer of Ethereum blockchain, wherein you'll see each and every transaction status, block status, and everything that happens on the blockchain gets updated over here. So here you can search by address, transaction hash, block number, transaction token, domain, anything you can search for here. But on the but in the block level searching, you'll have to use Merkle root hash only. And another important thing is this is not something that we use on a daily basis, or this is not something that developers generally use. You won't have to do, or you won't have to use this. This is something that's an internal algorithm search process that is used by blockchain for searching and giving you the transaction details. So yeah, I think with this, we have covered the structure of a block, and now we have got complete clarity on what are the different things that are present within a header of the block and how the block overall looks like. So now we'll be moving on the blockchain ecosystem. What are the component? What are the main components of a blockchain ecosystem? We have a node application, we have a distributed ledger, and we have a consensus algorithm. And although we have already discussed about all these different things independently, and we are well aware about these three things that are available, anybody who would like to give one liner or two liner about these three components of a blockchain? What's a node application? What's a distributed ledger? And what's a consensus algorithm? When we talk about node application, a node application is the one that is used by the nodes to maintain consensus and to manage the consensus among all the nodes. And this is how the consensus is achieved. So mainly the work of the node application is to ensure that they are always in synchronization with all other nodes. Okay, so if we have node 1, node 2, node 3, node 4, so all these nodes have to be in consensus and in synchronization with each other, right? They all should follow the consensus and be in sync with each other. So the responsibility of a node application is to ensure that they are always following the correct path ahead. They're always in sync with each other, and they are following the consensus for storing and managing the data. Okay. Then we have distributed ledger. Distributed ledger is the one where the data is stored, right? So distributed ledger is basically, it represents the topology of how the data is stored and managed among the nodes. Okay. So distributed ledger is nothing but a way of storing and managing the data. It clearly defines that how the data will be stored, how it will be managed, and how it will be updated from time to time. That's what is defined and explained by distributed ledger. The consensus algorithm, as we have already discussed, is responsible for defining the rules and the regulations and all the protocols that has to be followed by all the nodes, okay, in order to maintain the synchronization and in order to maintain the system hierarchy. So okay, so all the things that are with respect to the administration of the network, all the thing that has to do with the rules and regulations and the protocols of the network is defined by the consensus algorithm. How the blocks will be created, how the transactions will be validated, who will validate the transactions, everything is decided and defined within a consensus algorithm. So all these three independent things that you're seeing is managed and together responsible for successful delivery of a blockchain application. Okay, so all these things are independently involved. Whenever you deploy any application onto the blockchain network, it will indirectly be dealing with all these three different systems. Okay, it will be indirectly, it will be dealing with all these three systems. So more importantly, we can say that this is what is responsible for creation of a blockchain network. It's the distributed ledger, the node application, and the consensus algorithm. So node application is responsible for ensuring that the nodes are always in sync with each other, and all the nodes are following the rules defined by the consensus. Okay, so node application is, again, you can say, is always linked with the consensus. It is a representation of the consensus at the nodes machines end, and it always ensure that all the nodes are in sync with each other and they are following the consensus. So this is just an encryption algorithm that is used by blockchain technology. Although RSA algorithm is not the only encryption algorithm, of course, there are multiple other ways how you can encrypt a data. But yes, RSA algorithm is one of the most widely used encryption algorithm that is used for encrypting the data in blockchain at least. So yeah, as we already discussed that for any transaction that is initiated by the sender, always have to be encrypted. So for encryption, the sender will ask for the receiver's public key that you can see over here. And this public key of receiver will act as an encryption key. So using this, the data will be encrypted. The encrypted data will be sent over the communication channel that is known as ciphertext. This is known as plain text. The plain text is the unencrypted data and the ciphertext is the encrypted data. This ciphertext, once it reaches the receiver, then using RSA decipher, the private key of the receiver would be used to decrypt this data and get the plain text back, what was sent by the sender. So as you can clearly see, this is a clear example of asymmetric cryptography. Using asymmetry, if you remember, we discussed that in asymmetric cryptography we have um, a different key which is used for encryption, and we have a different key which is used for decryption, right? So you can see a different key being used for encryption, a different key being used for decryption, and successfully we are able to transfer the data from the sender to the receiver. So this is just an explanation of what we have already discussed. Hope this makes sense to all of you. We have discussed about consensus algorithm as well. So consensus is the heart of blockchain. And we have discussed what are the different parameters that are required for the consensus. So most importantly, we have PBFT, that is practical Byzantine fault tolerance, proof of stake, proof of work versus proof of stake. So you can just have a quick look at this diagram. This would help you to understand how proof of work and proof of stake differs from each other. Just quickly have a look and then we'll move ahead. The reason why we are looking at this differentiation is because these two are the most widely used consensus algorithm. Maximum blockchain networks that you will be seeing that these maximum of these blockchain networks uses these as the consensus algorithm. So basically what happened, just like it's like a story, but it's important to understand. So Byzantine army has been completely encircled by the city, and the army has many divisions. Each division has a general. Okay, the generals communicate between each other as well as between all the lieutenants within the division and only through the messengers, which means I hope you understand, like every general has a messenger. So the general will convey the information to that messenger, and then messenger will go to the other general to convey the message that has been given by one general, right? So all the commanders have agreed upon one of the two plans of action, which means there are two plans of action that can be taken. So all the commanders have to agree on one of the two plans of action. Okay. So we have a plan A and we have a plan B. It's not that some of them can go with plan A and some of them can go with plan B. So they have to communicate among each other. And this is not the era when we have phone, right? This is the era when the telephone was not existing. So they were dependent only on their messenger to discuss and finalize which plan of action, whether plan A or plan B will be moving ahead and taking. So exact time to attack all at once, or if faced by the fears of resistance at the time to retreat all at once. Okay, the army cannot hold on forever. Okay, the two plan of action was either to attack at the same time or to time to retreat at the same time. The army cannot hold forever. If attack or retreat without full strength, it means the only one thing, that is unacceptable brutal defeat. Now this is the important part. If all generals and or messengers were trustworthy, then this is a very simple solution, which means if everybody is trustworthy, then it's a simple solution. We don't have to doubt at all and everybody can be on the same page. But if some of the messenger and even a few generals or commanders are traitors, then you can never understand. Let's suppose I say I'm a traitor commander and I say that I'm planning to attack or I'm supporting the plan of attacking, but actually I'm not attacking and I'm retreating, right? So how will you handle that? Some way or the other, this will create a chaos. This is Byzantine general problem. So how do we achieve a fault tolerant mechanism that will encounter this Byzantine general problem? Or even if not a commander, even if a messenger is a traitor, then commander said something else and he will convey something else. So in this way, no solution exists if less than or equal to two-thirds of the generals are loyal. Okay. So this is what was encountered by solution to the Byzantine general problem is the practical Byzantine fault tolerance algorithm, PBFT, which is used to establish the consensus in the blockchain system, is the only and one of those potential solution. So it ensures that whatever way we are following, it has to be a counter of the Byzantine's general problem. And how is that achieved? Using this algorithm, PBFT, practical Byzantine fault tolerance algorithm. And using this PBFT only, so whatever algorithms or whatever consensus algorithm you see, whether it is proof of stake or whether it is proof of work, all of them are equipped with practical Byzantine fault tolerant algorithm, which means they are equipped with PBFT. They are in sync with PBFT. Okay, hope this all makes sense to all of you. Proof of elapsed time, we have discussed this as well. Now we'll come to types of blockchain. So generally we have, on a very broad level, we define two different types of blockchain, public and private. You can skip consortium for now because anyway it is a part of private blockchain only. There was a time, there was an era when people used to think that private blockchain is different from consortium blockchain, but a lot of people disagreed on that. And now we have, on a broad level, we have two different types of blockchain, public and private. Although when you deep dive, you can understand, when you deep dive, you can understand that these many different blockchains are there. That is permissionless public, permissioned public, permissionless private, and permission private. Okay. So if I have to give example of them, then I can say that permissionless public, clearly it is Bitcoin, Ethereum, and multiple other network. They fall in the category of permissionless public. Then we have permissioned public. Then we have Ethereum. Using Ethereum, you can also create permissioned public blockchain. Permission means, can anybody come and become a part of your network? No. If it is permission, no. Permissionless means anybody can come and become a part of your network. Yes. Public means whatever data, whatever transactions you are doing, are they publicly available? Yes. So if it is public, it means it is publicly available. Then we have permissionless private. This is a very less known area, and this is a very less used sector as well. Okay, none of the blockchains or none of the projects actually prefer to use it permissionless private because they are quite contrary to each other. On one side, we have it as a private blockchain, which means the data is private, but then anybody can come and become a part of that network. That completely contradicts each other, right? So you would say that permission public is also a contradictory thing, not as much. The reason for that is, even if it is even if the data is available on a public ledger, anybody can come and see it, but you want to ensure that only certain people shall be able to do the transaction. So that's how you control permission public. Only a group of people can become a part, or everybody can see what is happening, but only a group of people can actually come and become a part of your project, whom you allow to be a part of your project. That is permission public, and that is widely accepted. But permission less private is something that's quite contrary to each other, and that is the reason it's rarely used. At last, we have permissioned private. This is clearly an example of Hyperledger or any other private blockchain. Okay, so we have Hyperledger Fabric, Iroha, Sawtooth, Burrow, and a lot of other blockchains networks are there that are private blockchain. So these two have most of the examples and use cases. This also has certain number of use cases, but not in line with these two. And this is the rarely used one. Okay, permissionless public, permissionless private, and permission private. This clearly explains that how the thing varies. So in permissionless, you have less trust in validators. In permission, obviously, you have most trust in validators. When we talk about public and private, the anonymity of validators is more in public, the anonymity of validators is less in private. Coming back to this once again, just have a look at this. Yeah, so permission public, like as I told, permission public is Ethereum private blockchain. So using Ethereum, you can also create a private blockchain, and that falls in the category of permission public. Okay, so there are a lot of clients of Ethereum. One of the popular clients of Ethereum is Geth. We will learn about that in greater detail as we move to the Ethereum topic. But for now, you can understand that Geth is one of the important clients of Ethereum, and using that client, Geth as the client, you can create private blockchains or permission blockchain in Ethereum as well. So that falls in the category of permission public. Okay, that's great. So I hope this makes sense to all of you. Now we'll talk about side chains. Now, what are side chains? So side chains are separate blockchain which is connected to other blockchain through a use of two-way peg, which allows the transfer of digital coins or assets between blockchains at a fixed or otherwise deterministic exchange rate. Quite complicated to hear. Let's try to understand this in detail and in a layman's language what the side chains are. So what happens is, let's suppose we have two different types of blockchain. Okay, so we have BTC and we have Ethereum. Both have their own network, both have their own consensus, both have their own distributed ledger, and they do not understand each other at all. Right? They do not understand each other at all. So obviously the two cannot if the two cannot communicate with each other directly, it means that the two cannot exchange data between each other directly or indirectly. They cannot exchange data among each other, right? So to ensure that they should be able to exchange data among each other, we have side chains. Now what are side chains? Side chains are separate blockchain which sits in the intermediary of these two blockchains. So the purpose of this blockchain is not to selflessly handle transactions or data. Please understand this very carefully. Although they are separate blockchain, but they are not. The purpose of sidechain is not to handle transactions and data independently, the way how BTC and Ethereum handle transactions and data independently, right? Sidechain is not responsible for doing that. Rather, sidechain is responsible for ensuring that the data can be transferred from one blockchain to another and vice versa using the use of these two-way pegs. Okay, so we have these sidechains have two-way pegs which can allow you to transfer the assets like BTC from Bitcoin blockchain to be transferred to ETC of Ethereum blockchain, ETH of Ethereum blockchain. Similarly, ETH of Ethereum blockchain can be transferred to side chains which can further transfer it to BTC of Bitcoin blockchain at a certain predeterministic exchange rate. Okay, it means that it will be a predeterministic exchange rate at which the transfer of these assets can take place. Now, the most important question is, why is this even important and why side chains were even created? The whole purpose of creation of side chain was to solve the problem of solve the problem of interoperability. Okay, the whole purpose of having a side chain was to solve the problem of interoperability. Was it solved? Rarely. Okay, was it solved? Actually, not at all. It wasn't actually solved, but the thing is, at least it gave a new direction to, but at least it gave a specific direction to move ahead, right? Later, the issue of this interoperability thing was greatly solved by polka dots. So this problem of interoperability was later solved by polka dots. How it is solved and all, maybe if time permits, we'll see it later on. But yeah, majorly the side chains were responsible so that the two blockchains can communicate in each other although it didn't help in communication of data, but at least it helped in communication of what do you say? At least it helped in communication of assets, the digital assets from one blockchain to another. Once again, side chains are now again, if we try to read the same thing, maybe now this will make sense to us. Side chains are separate blockchains which is connected to other blockchains through a use of two-way peg, which allows transfer of digital coins or assets between the blockchain at a fixed or otherwise deterministic exchange rate. All majorly these blockchains are trying to solve the problem of interoperability, but the problem that I have felt over the year is that what they are trying to do is they are trying to create a new solution. All of them are trying to create a new solution, which again is not actually solving the problem of interoperability but is actually complicating it. Now Polkadot did the same thing. Polkadot created a whole unified ecosystem which was completely different from Ethereum and all other blockchains that are available. So if you are doing that, you're not actually solving it, you are complicating it. So if you want to solve the problem of interoperability, and if you want to have some interoperability solution, then you should only create something which is pluggable and can be plugged to any of the existing available networks. And for that, one of the great solution is DAML. If time permits, you can just have a look at this, what DAML is. So DAML is basically a programming language. It is not a blockchain. It is not a distributed ledger. It is not a protocol, or it's not a consensus algorithm. It is nothing. It is just a programming language through which you can write smart contracts and deploy it on any of the blockchain network. It's known as DAPL. It's created by Digital Asset team, and you can just have a look if you want to see or research more on the interoperability solutions. Okay, what's the two-way peg? So two-way pegs is nothing but just a term that has been, it is just a term that has been called by sidechains. It is just a kind of a window through which the data can be transferred from one blockchain to another. You can, in a layman's term, you can assume it like this. Okay, so two-way pegs are just responsible for transmission of data from one blockchain to another and vice versa. So what are the various platforms for implementing blockchain? So we have Ethereum, we have multi-chain, Hydrochain, Hyperledger, and not only this, OpenChain, IBM Bluemix Chain, IOTA, and lot of other blockchain networks have came up. Okay, so this is just a few ones that are listed over here. But apart from this, lot of new blockchain networks have came up. So the side chains are not important, to be precise. The side chains are not important, but the concept of interoperability is something that you must explore if in case you want to deep dive and become definitely a good blockchain developer. You must be aware about what is interoperability and how exactly you can solve the issues of interoperability and a few things about that. Okay, that's great. So now let's move ahead with our last topic of fundamentals of blockchain, that is mining. So we'll move ahead and we'll try to understand what exactly is the concept of mining and how it gets implemented. So the only way to learn about them is to independently understand, each and every blockchain, what it is doing. But yeah, to be honest, like there are, as I've already explained this before, that there are more than 2000 blockchain networks, out of which it's only just 3 or 4 that are actually important, and rest are mostly just doing something, but they're not getting so much of hype and they're not being adopted by developers. So it's not, there's not a unique thing in just creating a blockchain network, but it should actually solve some real purpose, and the developers have to adopt it. Unless and until the developers adopt a particular blockchain network, it wouldn't be a very good use case to be used for. Okay, so with this, we'll try to understand what exactly is mining. So mining is all about two tasks. Okay, so mining is all about two tasks. The first is creating the blocks, and the second is validating the transactions. Okay, When I say creating the blocks, what does it mean? Creating a block means, of course, you'll have to create blocks where you can store the transactions. As we all know, whatever transactions are created and validated, they have to be stored in a block, right? So miners creates the block that they known as candidate block, which we have already seen in this figure. You remember this figure? So miner will pick up the transaction from the main pool. From main pool, the transactions will be picked up by the miner. They will validate the transaction and will put it in their candidate block. So who forms this candidate block? Obviously, the independent miner only will be forming their candidate block, right? So two tasks. First, validation of transaction, and second, creation of blocks. These are the two things that are done by the miner: creating of blocks and validating of transactions. For both of these things, the miner gets rewarded. Both of these things, the miner gets rewarded, of course. So for creation of blocks, the miner is rewarded with block reward, and for validating the transactions, the miner is rewarded with transaction fee. Okay, for creation of block, a miner is rewarded with block reward, and for creation of validation of transaction, a miner is rewarded with transaction fees. Okay, now these are the two different things that are majorly involved in mining. Now, if I ask, what are two different types of mining? What are two different types of mining? So for this, we have two different types of mining: is solo mining and pool mining. When we say a solo mining, then it's basically a lone setup of all the infrastructure that is needed to mine. So big systems, highly efficient and computational power generative machines, of course, huge amount of electricity as well. Whereas pool mining is a concept where a group of people or organization collaborate to do mining. Okay, so with this mining topic, we'll move ahead with some other few descriptions about this, and then we'll move to how exactly with the concept of orphan block. So if you remember, in while we were discussing this, someone asked like, what will happen if two miners solve the puzzle at the same time and their respective blocks are generated? So what will happen? Which block will be updated and everything with respect to that? What will happen if two miners? Obviously, over here, everything is about solving the puzzle, right? Solving the puzzle ahead of the other person. So what will happen if the other person, or if two people or two miners or more than two miners solves the puzzle at the same time? So that's the only topic that is pending. But before we move to that, let's just quickly see into this slide. Types of Bitcoin mining: we have solo mining and the pool mining. In solo mining, the miners endeavors to produce new blocks all alone, with a return from the rewards and the transaction expenses going altogether to himself, enabling miner to receive extensive payments with a higher variance, longer time between payments, of course. Whereas pool mining, miner pools the assets with different mine workers to discover the blocks, although more regularly, with returns being shared among the pool miners through the correlation to the measure of the hashing power what they have contributed. And obviously this has a shorter payment cycle. So there are 4 steps involved: autonomous check of every transaction, proof of work algorithm, the confirmation, and the independent aggregation. All of this leads to mining or consensus. It is just explained what happens independently, which we have already discussed, like how the block is created, how the transactions are validated, and everything with respect to that. So with this, we can say that we have covered what exactly is mining, and we'll discuss about how exactly this mining is done with the help of the concept of orphan block. So we'll try to understand with the concept of orphan block that how they are done. So with this, we talk about the distributed ledger. The distributed ledger is generally of 2 types: the public ledger, the permissionless ledger, and the private ledger and the permission ledger. We have already discussed about this, but just a quick point that there is no central authority that is managing the access to the ledger. That type of ledger is known as public ledger or permissionless ledger. But on the other hand, when there is a central authority that is managing the access to the ledger, that type of ledger is known as private ledger or permission ledger. So, when there is a central authority managing the access to the ledger, does that mean that this basically a private blockchain is centralized? Does that mean that a private blockchain is centralized? Anybody? Because it clearly says that in a private blockchain or is in a permission ledger, there is a central authority that is managing the access to the ledger. Okay, let's try to understand what it is and how it is. So yes, if this is our permissioned ledger or private blockchain, if this is our permissioned ledger or private blockchain, then yes, there is a central authority, and these are general people who want to become a part of the network or want to do transaction. So what happens is that it's not that the availability of a central authority makes the whole blockchain centralized. No, rather they are away from this network and they only are responsible. This group of central authority is responsible for choosing who should be the part of this network and who shouldn't be. So everybody who becomes the part of this network has to go through the central authority, which will decide if that person is a valid person to be admitted to the network or not. If that person is approved, they will be admitted. If that person is rejected, then they won't be able to access anything from here on the private blockchain or the permission blockchain. So yes, there is a central authority, but the role of the central authority is just to manage the access to the ledger. Okay, the responsibility of the central authority is just to manage the access to the ledger and not the whole and not actually centralizing the whole process of blockchain. Hope that makes sense to all of you. And this, with the help of this, we are actually controlling that who should be able to, who should become a part of the blockchain network and who shouldn't be able to become a part of the blockchain network. So this is about private blockchain. That's what is trying to be done over here, that when there is a central authority that's managing the access to the ledger is called as private ledger or a permission ledger. So this is just a basic explanation of, that the ledger. So till now on all the figures that you see over here, the ledger is depicted like a file type icon, right? A ledger is depicted like a file type icon, as you can clearly see. So with this, they are just trying to tell that ledger is not importantly a file type icon, rather it is a chain of blocks. And that's how we have studied it, and that's how we have learned it till now, right? That what's a ledger? A ledger is nothing but a chain of blocks connected to each other, right? So this is what a ledger is, a chain of blocks that are connected to each other. But over here, if we see, the ledger representation looks little different. Over here, if we see this is the same diagram that I have got from here. Okay, so over here the ledger image looks little different, isn't it? So over here till here we have been learning that ledger is nothing but a chain of blocks. That is fine. Chain of blocks is fine. But then why are these branches coming out of this chain of blocks? It should always be a linear chain of blocks, right? Because that's how we have always thought, that a blockchain ledger is nothing but a series of blocks connected to each other, which should be linear in nature, right? But as I can see over here, that there are branches coming out of it from here and there, right? So what are these branches representing? And even before that, why exactly, why these branches are created? Okay, what is the reason behind creation of these branches? So first we'll understand that, and then we'll of course understand what it is representing. Let's try to understand this. So more importantly, we can say that these branches are representing different types of blocks that are being added. These branches are representing different types of blocks that are being added. Now, first and foremost thing is When we talk about these branches getting added and these branches getting created, let's first understand what actually happens. So we have a miner 1, we have miner 2. So we have main pool of miner 1, of course, from where they pick up the transaction, put it in the candidate block and make up the candidate block. And again, the miner 2 also does the same thing. Now a puzzle is launched to both of them, right? A puzzle is launched, not only to both of them, obviously there are multiple other miners, all get the puzzle to be solved. Now, assuming that both of them solves the puzzle at the same time. So what happens? This is the 0th block, also known as Genesis block.
Let's have a quick quiz question, guys. And the question is, what is the key feature of a public blockchain? And your options are accessible only by a single organization, requires permission to join the network, allows anyone to participate and view the blockchain data, or operates without the needs for miners. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
This is the first block. After that, the second block would have came over here if any one miner would have solved the puzzle. That particular miner's candidate block would have came over here and sit over here like this. But let's assume that both the miners solves the puzzle at the same time. Both the miner solves the puzzle at the same time. So what will happen? Now consensus algorithm plays a very important role over here. The consensus algorithm says that you can create the consensus algorithm says that both the miners should be allowed to go ahead and add their block in the respective blockchain network. Because both of them have solved the puzzle at the same time, both of them have done equal amount of work. So both of them should be allowed to add their blocks to the network. That is the reason you see this branch that are created. That is the reason these branches are created. And now because these branches are created, now it becomes very difficult for the next block to decide where it will go and get attached to, right? Because see, if it is a linear chain, then everybody knows that I just have to come and get attached to my previous block. But because this over here, because there are two options available for this next block, that is block number 3, it decides where it has to get attached to. Now, another important thing is, can both of these blocks be present? No, right? The both of these blocks can never be present. At the end, it just has to be one block. Okay. And it always has to be a linear chain only. Even if the branches are created, we have to ensure that it always is a linear chain. So now what happens is the consensus algorithm says that everything will be dependent on the miner of the third block. Everything will be dependent on the miner of the third block. So to whichever block the third block gets attached, to whichever block, the upper block or the lower block, to whichever block the third block gets attached, okay, that block becomes the main chain, and the other block which is left out, sorry, the other block which is left out becomes the orphaned block. The other block which is left out becomes the orphaned block. Now what happens with this orphaned block? So this orphaned block is left out in the blockchain network as if it is a dead data. Does it mean that this orphaned block has got no significance, no value, no importance in the network? That's absolutely correct. This orphan block has got absolutely no significance, value, or importance in the blockchain network. But does it mean that all the value of hard work that was done by the miner in order to solve the puzzle and in order to validate the transactions that are present inside these blocks have gone waste? Yes, even that is correct. So all the hard work that was involved in solving this puzzle or in solving the transactions, validating the transactions, are of no use if it becomes an orphaned block. Okay, so which means, and how does, so the last question that can come to your mind is, how does the upcoming block decides that to which block it wants to get attached to? How does it, this block decides that whether should I be attached to the upper block or the lower block? So that is completely random. What happens is the node application is programmed in such a way, the node application is programmed in such a way that it is a random behavior of the upcoming block to get attached to either of the two blocks only if the upcoming block and the previous block does not belong to the same miner. If the upcoming block, that is the third block, and the second block both belongs to miner 2, then obviously the third block and the upcoming block will get attached to their own block, right? They'll get attached to their own block because both will be benefited. I mean, the miner 2 will get the benefit of both of blocks. But if this upcoming block 3 is coming from miner 3, which does not belong to miner 1 or 2, then in that case, randomly it can be attached to either of the blocks, totally on luck. If it gets attached to the lower block, the upper block gets orphaned. If it gets attached to the upper block, the lower block gets orphaned. So the two things we discussed initially: why orphan blocks are created. They are created only when two miners solve the puzzle at the same time. What is the significance of the orphan block in the network was the second thing. So these orphan blocks have got absolutely no significance in the blockchain network. They are just like a dead data that is present in the network. The only reason why we cannot remove it or delete it is because blockchain ledgers are immutable. We can never delete, tamper, edit, or modify any data that's present within the blockchain, right? For that reason, they are not modified, they are not tampered. Otherwise, they have got absolutely no significance in the network. Now, the last question should be, you would be thinking, how does consensus algorithm ensures that this concept of orphan block does not repeat very, very instantly or does not repeat often? Because somewhere it is the loss of, you can say that somewhere or the other it is the loss of a particular person only, right? Because they have already done equal amount of work as amount of work was done by miner 2 also, but miner 2 got success and miner 1 efforts was a waste, right? So what does consensus algorithm does to ensure that this scenario does not repeat very instantly? For that, there is a concept of difficulty. If you remember in the Etherscan, there's a concept, and now it is not there, of course, because this whole concept of mining, proof of work, and everything that we have discussed about mining is of no use now in Ethereum. Okay, maybe in Bitcoin we can still see that. Yeah, so you see that there's a concept of difficulty as well. Okay, and this is the nonce value, that's the solution of the puzzle that's present in the header of the block. Okay, but more importantly, we are more interested in this difficulty thing. So this difficulty increases or decreases with time. So the reason for this is, let's see a thing. So this block that I have searched for right now, 1,12,342 block, is 12 years old, which means quite a time old block it is. Okay, And the difficulty level of this block is this. Let me copy it. So this is again a block explorer, guys. Don't get confused what this is. This is a block explorer. This is a common block explorer for Ethereum and Bitcoin both. But as of now, we are more interested in Bitcoin because Bitcoin, the reason why I've opened Bitcoin is because Bitcoin still follows proof of work, whereas Ethereum has now completely migrated to proof of stake. That is the reason. So this is a 3-year-old block, guys. Not very recent, but at least some time back. And there's a purpose. There's a special purpose why I'm actually comparing it, and we'll see what it means. The difficulty, of course, has significantly increased. So this is a pretty much recent block. Maybe I'll just try to find a little more recent. Just a minute. Yeah, just 7 days old. This is a pretty recent block. So now you have 3 data in front of you. Okay, let's see. So yeah, basically you can say that all these blocks are morely importantly reflecting that the difficulty has significantly increased over the time. Okay, so you can see they are the difficulty has increased exponentially. Okay, the difficulty has increased exponentially. As you can see, the difficulty level of this and this. So now, what is the reason behind this? The reason behind this you have already seen in the video that I shared for the, you remember the mining video that I just shared and you all had a look. Where did you see, where you saw that, you know, how the difficulty level has been increasing by the consensus algorithm just to ensure that all the miners does not solve the puzzle at the same time. So for this, I'll give you a very basic example. And with that, you can clearly understand, okay, so this is the algorithm why consensus increases the difficulty and how it gets to know who has solved the puzzle first. So let's suppose there are 5 people. This is a layman example, but it will help you in understand. You'll understand this very carefully. I mean, you'll understand this very easily, and this is what will help you understand how exactly consensus functions at the core level. Let's suppose there are 5 or 6 people, okay, and I'm the quiz master, and if I give a puzzle to 6 of you, and I just want to know who answered first. Okay, I just want to know who answered first. I might give a puzzle like 5 into 25 into 5 or into 2, right? I might give a puzzle like this. And anybody who answers first, I would be able, because there are only 6 people, I would be able to know that who answered first. Even if 2 people almost at the same time they answered, yet I'll be able to make out who answered first, because there are only 6 people. I can visually and orally verify that who has answered first. But let's suppose if I repeat the same scenario, but in place of 5 people, rather you have 50,000 people. In place of the 6 people, rather you have 50,000 different people who are participating in that quiz. Will I be able to give any sort of question like this? No, right? Because most of the people can answer it at the same time, and I would not be able to know who has actually answered it first. So for that, what will I do? I'll simply increase the difficulty of my puzzle. I'll say 255, I mean 25,555 multiplied by 25, 255 multiplied by 25 multiplied by 5. Some just kind of puzzle I'll give. So what I have done, as the number of participants, or I would say as the number of competitors increased, I have increased the difficulty level of my puzzle so that only a few people are able to solve it, and those who are able to solve it, among those I can easily figure out who solved it first. Okay, it's not just about solving, but solving it first. So first and foremost, it will be so complicated that only a few people are able to solve it. And secondly, even if you are able to solve it, you might be the second or third, and then you won't be counted. So the same algorithm is applied by the consensus, in order to find out, in order to select one miner as the winner. So as the number of active miners increases in the network, the difficulty level will also increase. And is there a possibility that the difficulty level can also decrease? Yes, definitely. There is a possibility. There might be a chance that you are a miner, but right now you are not active. Your system is shut down or you have a power issue or something, anything. You are a miner, but right now you are not active, which means there are total of 50,000 registered miners, but at this point of time, let's suppose only 5,000 are active. Let's suppose only 5,000 are active. So again, the consensus will decrease the complexity of this puzzle. It will be somewhere in between these two types. Okay, so the difficulty level of the puzzle increases and decreases time to time, totally dependent on the number of active miners in the network. On the basis of number of active miners, we can easily decide that what should be the difficulty level of the puzzle. And this is what is done by the consensus algorithm to ensure that the scenarios of orphan block does not repeat every now and then. So guys, is the concept of orphan block clear to all of you? Everything with respect to the orphan block, the need, the necessity, the consequences, and the ways to counter it.
Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
Public address. So whenever you send the funds to me, you'll see that the from address of that fund, I might go to Etherscan. I might just open up that transaction that you'll send me, saying that, see, hey, Saurabh, I have transferred you this many Ether, and this is the transaction hash for that. So in that transaction hash, once I'll search that transaction hash or I'll open up the transaction hash, I'll see that there'll be a from address and I'll see that there'll be a to address, right? So if you are sending funds to me, the to address would be mine and the from address would be yours. Okay, so the only way how I can recognize you is through this address. Okay, so I have to know priorly what your address is and from which address you are sending me the funds. Through that, I'll recognize you. Talking about the authentication part, that how do I ensure that because you are sending the funds to me, how do you ensure that I don't have any other access to your account other than getting to know that, yes, you have transferred the funds to me? And how this is ensured is through the cryptographic signature of transactions. So if you remember, we discussed that whenever a transaction is encrypted, it is encrypted using the public key of the receiver. Remember, so if you want to send the funds to me, you'll take my public key and you will encrypt the transaction using my public key, so that once it comes to me, I can use my own private key to decrypt that transaction back and get the Ether credited to my account. Now, in all this process, one thing that you see importantly is we are just getting to know each other's public key. Okay, we are just getting to know each other's public key. We do not have access, and neither do we need the access to the private key of each other participant. Okay, I don't need your private key, neither do you need my private key. And because our private key is safe, I can just look through your account, I can get all the details of your account, but I cannot process a transaction on your behalf. until I get your private key, let's suppose this is the from address and this is your address, just assuming that this is your address, I can get to see everything that's happening in your account. What is your balance? You have 100 ether, you have 179 million value of ether, you have around 15 tokens. I can see all the transactions that you have done. But what I can't do is I cannot initiate a transaction on your behalf because I don't have the private key. So this is how it is ensured that the authentication takes place successfully. So if in case, definitely that is, but I would not say it's a violation of privacy, because we all know that it's a public blockchain and yet you have choose to be a part of that public blockchain, right? So it's, if you see from that perspective, it's you who decided to be a part of it. So because Ethereum is a public blockchain, which means everything is publicly available over here. And yet if you choose to be a part of it, which means you want to, you are acceptable and you are accepting the fact that your transactions would be broadcasted to everybody. Yet if in case you want to maintain the privacy, okay, so although blockchain is public, but it is also anonymous. We need to understand that although blockchain is public, although Ethereum is public blockchain, but yet it is anonymous or pseudonymous. When I say it's anonymous and pseudonymous, what does that mean? What it means is we can never get to know who is the person behind this address. I am able to see what this address is having, what transaction it is doing, but do I know who is the actual person behind this address? Does anybody know who is the actual person behind this address? Or does even Vitalik Buterin know that who is the person behind this address? No. Even Ethereum as an organization does not know who's the person behind this address. So definitely, if you want to preserve your identity, if you want to be anonymous in the network, you are open to do that. So only when you share this address to other people saying that, yes, this is my address, only then you will be disclosed in the network. Else, you might not be disclosed to anybody that who this address belongs to. Definitely, private blockchain offers a higher level of privacy, but again, within the network, you will be known to other people. Okay, maybe outside that network, nobody will get to see all the information and all these transactions. But within a network, within a particular group of people or a group of organization, it will be known. So because it is a public blockchain, everything has to be public. See, the whole fundamental of this blockchain thing, if we go back to that diagram, I'll have to search where the diagram was. But if you remember, we discussed about a diagram wherein we had multiple people, right? So we had people like James, Kevin, Paul, Lisa, Robert, remember? And one people was doing transaction to other. So either you could have one thing, like you could have a bank at a centralized place. You could have a bank who can manage this ledger, who can manage the transaction and the ledger of each individual person. Or if you want to eliminate this bank, you should have a ledger being maintained at your end, so that everybody can, if this is a transaction happening from Lisa to Robert, then everybody should be able to record this transaction in their ledger. And this is the true meaning of blockchain. Okay. So we have to keep it public to make utmost level of transparency. It's simple. It's not that you are able to see someone's data. Okay, if I open up a particular transaction, then for every transaction you'll see that there's some amount of data also that is involved. So you'll not be able to see that data anyway. So when it comes to privacy, it's about privacy of data, and when it comes to privacy of asset that you are holding, so obviously you can you can split your funds in multiple accounts, and obviously you can maintain your anonymous behavior in the network. So definitely, yeah, those are the things. But because it's a public blockchain, everything is publicly available on the ledger. So now we are going to cover these four major parts of Ethereum. So we have currency issuance, smart contracts, smart property, and decentralized autonomous organization. So these are four different things that we are going to cover. And we can also say that these are the four innovation areas that Ethereum has brought to the blockchain world. Okay, so before Ethereum, there was no provision to actually issue your own currency using the blockchain network, to actually develop and deploy smart contracts, to actually have something like smart property, and there was no concept of decentralized autonomous organization. So obviously, before we move ahead and learn about what do they offer and how do they improvise the blockchain realm, but before that, let's move ahead and understand what do these independently, what do these do? Okay, what do they mean? Okay, so the first one is currency issuance. Okay, that's correct. So when we talk about currency, definitely till now we have known that currency in the blockchain world are BTC, ETH, SOL, Matic, BSC, and multiple other Tron, and multiple other currencies we have known or we know. But we need to understand that these are known as native currencies, native currency of a blockchain network. When I say native currency of a blockchain network, what does that mean? It means that these currencies were created with a purpose to solve or to be a native asset of a particular blockchain network. Like BTC is a native currency of Bitcoin network. Ethereum is a native currency of Ethereum blockchain. Solana is a native currency of Solana blockchain. Matic is a native currency of Polygon Matic blockchain. BSC is a native currency of Binance Smart Chain blockchain, and Tron is a native currency of Tron blockchain, right? So it would be better if I represent everything by symbol only, TRX. So BTC is Bitcoin, ETH is Ether, SOL is Sol, Matic, BSC, and Tron. So like these are the native currencies of blockchain network. So you'll say that then if this is the case, then what did Ethereum do? A wondrous thing, because even Bitcoin has BTC, isn't it? Even Bitcoin has BTC, so Ethereum has Ether. So what's so wondrous in this? The thing is, Bitcoin has BTC, that's a fact, but can we create, the question is, can we create our own currency which is practically known as token? Can we create our own currency or token on top of this blockchain? The question is this, or it's also known as currency as a service. So does Bitcoin offer currency as a service or token as a service feature? The answer is no. So the thing is, if you want to create your own cryptocurrency till the Bitcoin world, you would have to create a whole new blockchain network similar to Ethereum or Bitcoin or Solana or Matic or BSC or Tron, whatever it is. A lot of blockchain networks are there. But yes, the agenda is, was it possible in the Bitcoin world or during the Bitcoin era, was it possible for us to create our own currency or token on top of Bitcoin as a blockchain, which means Bitcoin will be there, and on the top layer of Bitcoin, we can create our own currency or we can deploy our own token. Was that possible in the era of Bitcoin? No, it wasn't possible. But this was a major breakthrough, and Ethereum allowed users to launch their own tokens with minimum changes or with minimum or with some fixed set protocol, would be better thing to say, with some fixed protocol which was obviously very, very less complicated than actually creating or setting up your own blockchain network, right? So there were certain protocols that were defined by Ethereum, and using those protocols, users can launch their own tokens, which was obviously very, very less complicated than technically complicated, very less technically complicated than actually setting up your own blockchain network like BTC or like Ether or like Solana. So this is where blockchain 2.0 came into picture. So people call it blockchain 2.0 because with the help of Ethereum as a blockchain network, you can launch your own tokens. You can deploy something known as smart contract. What they are, we'll learn about that as well. But all in all, you can say that you can create your own ecosystem on top of an existing blockchain network. Okay, you can create your own ecosystem on top of your existing blockchain network. And this was not only for easeability, it was not only just for easeability, but it was also one of the major success in terms of interoperability, right? Why? Because till now, if I just give you a rough number, I can say around 50 billion projects, around 50 billion projects are running on the blockchain of Ethereum. Okay, around 50 billion projects are running on top of Ethereum blockchain. Now just think, even if 1/100th of these projects would have choose to launch their own blockchain, okay, even if 1/100th of these projects would have choose to launch their own blockchain, means 1 out of 100 projects also would have choose to launch their own blockchain. Just think how many blockchain networks we would have had till now. So as of now, I just gave you a figure of 20,000 blockchain networks, right? And now just think, if I divide 50 billion by 100 or by 1,000, or even if we half it, then just think that how many such blockchain networks would have existed. And Ethereum saved them all, right? Because it gave a platform saying that you don't need to get complicated, you don't need to be involved in the complication of setting up your own blockchain network. Rather, use our platform as a service in order to launch your project onto the blockchain network. So this was a really major breakthrough that Ethereum gave to its users. Obviously, after that also a lot of networks came up, but most of the networks that are popular, you'll see, are again EVM compatible, which means the whole tech stack and everything remains same. We'll talk about EVM compatibility at a later point of time. Like Matic is EVM compatible, means similar to Ethereum. BSC is again EVM compatible. TRX is not exactly EVM compatible, but again the tech stack remains same, which means developer does not has to learn new things every new day. Okay, so it's very important actually. Okay, we'll discuss about those things later. At this point of time, I don't want to complicate it too much, but yeah, all in all, this was a major breakthrough that Ethereum gave, which allowed its users to launch their own tokens with some fixed set protocol. Okay, so I hope this makes sense to all of you that when we talk about currency issuance over here, what does it mean? It means is currency issuance. With the help of this feature, Ethereum allowed its users or clients to actually launch their own currency or their own ecosystem for their blockchain project. So although there are a lot of other protocols, but today we'll be discussing about these three, which are most widely used. And even in these three, the two that are most popular are ERC20 and 721. Okay. So these two are the most popular one, but this is something that has been trending for a few days now. So we'll cover this as well. So now, anybody knows what's a fungible token? What is fungible? Anybody knows what is the meaning of fungible? Or when I say a token is a fungible token, what does it mean? So basically, whenever we talk about fungible or non-fungible, So fungible is something that can be easily exchanged with anything. Okay, non-fungible is something that is very unique in itself and cannot actually be changed or cannot actually easily be exchanged with anybody. But for this, let's try to understand when I say that what's the actual meaning of when we talk about fungible and non-fungible. Let's discuss about this. So you can say that a fungible token is like let's suppose we have a $1 note or we have a 100 rupee note. Okay, if I have a $1 or a 100 rupee note, and if you also have a $100 or a 100 rupee note, and maybe my note is very freshly printed just few months back, and your note is quite old, but yet it holds the same value, okay, and is accepted in the market. And if we exchange our notes with each other, if I say you that you take my $1 note and you give me your $1 note, will there be any impact on our asset holding? No, right? Similarly, not only notes, but let's suppose I have a $1 note and you have a $1 coin. Just assume that it exists. And let's suppose I have a $1 note and you have a $1 coin. And again, if I give my note to you and you give me your coin, do we have any impact on our asset holding? No, right? So there will be no difference in our asset holding. Even though if we exchange it, there will be no difference in our asset holding. Those types of assets are known as fungible assets. Fungible because they are not unique. So again, when I say not unique, do not take it in the other direction, saying that every note is unique because it has a special number. We don't deal in that bit. But overall, in general, I have a $1 note, you have a $1 note. It's not unique specifically. We can exchange it. When I talk about uniqueness, it's about the asset uniqueness, not the specific that note uniqueness. Obviously, that is unique. But overall, it's not something unique, and it's not something for which the price and the characteristics can vary over the period of time. Now, let's consider another example. Let's suppose I and you, okay, both of us bought the same car with same model, with same specifications at the exact same point of time for exact same amount of money paid. Okay, every specification of the car, the model of the car, the built year, the manufacturer, the everything is same. Even the price that we paid right now, the color and everything, the price that we paid right now is exactly same. Okay, just assume it like this. And now, after 5 years, okay, we meet again. So after 5 years, let's suppose we meet back once again. And at that point of time, if we ask to exchange our cars with each other, will there be any impact on our asset holding? So of course, there will be an impact on the asset holding, because the car on the other, unlike $1 note or $1 coin, the car on the other hand is something that is very unique. And again, from a high level perspective, at the time of purchase, there might be a chance that, we both purchased exact same car, and at that point of time the price still remains same. Just after purchasing the car, if we exchange it with each other, the asset holding might not differ, because we just purchased it right out of the showroom and we exchanged it. So there is no difference in the asset holding. But over the period of time, okay, it totally depends how you have driven your car, how I have driven my car, what is the condition of the car, how I have maintained my car over the period of time, and how you have maintained your car over the period of time. And there are a lot of other external factors that would come into picture, and that would define the price of your car after exact 5 years. And again, these conditions would define the price of my car after exact 5 years, which might be same or might not be same. But there are very less possibility that it is exactly same, and high possibility is there that there would be a difference. low or high difference, that completely depends, but there would be a substantial amount of difference in the prices of our car. So this type of asset, which is very unique in itself and cannot be exchanged at any point of time with some specific commodity, those types of assets are known as non-fungible assets. Okay. So now coming back to Ether, Bitcoin, and all these currencies that we discussed over here, where did it go? Yeah. So coming back to this, all this BTC, Ether, Matic, BSC, TRX, what are all these? Are these fungible assets or are these non-fungible assets? Yeah, so they are fungible assets. The reason for that is simple. Again, just think it from that perspective. I have one Ether, you have one Ether. If I transfer my one Ether to you and you transfer your one Ether to me, will there be any impact on our asset holding? No, there won't be any impact. After 5 years, again, if I transfer my one Ether to you and your one Ether to me, will there be any impact on our asset holding? Again, there won't be any impact on the asset holding, right? So clearly they are fungible assets. But again, so when we create certain types, so over Ethereum blockchain, we have we have multiple options to create different types of assets. So Ethereum allows ERC20 as one protocol, ERC721 as another protocol, and ERC1155 as another protocol. So ERC20 is used for creation of fungible tokens on top of Ethereum blockchain. Similarly, ERC721 is used for creation of non-fungible tokens on top of Ethereum blockchain. And at last, we have ERC1155, which is responsible for creation of semi-fungible token on top of Ethereum blockchain. So what are semi-fungible tokens? Semi-fungible tokens are those types of tokens which has the property of fungible as well as non-fungible tokens. Okay, so semi-fungible tokens are the tokens which has the property of fungible as well as non-fungible tokens. So for understanding semi-fungible token, we'll be considering an example of plots or lands. Okay, so now let's suppose this is a plot which is owned by a farmer. Fungible or a non-fungible asset? It's a non-fungible token or a non-fungible asset, of course. And one more important thing that I missed to tell about fungible and non-fungible assets, and that is very important to know before we move with this understanding. It is that fungible tokens are always splittable.
Let's have a quick quiz question, guys. And the question is, which consensus mechanism does Bitcoin blockchain primarily use? And your options are proof of stake, delegated proof of stake, proof of authority, or proof of work. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
Fungible tokens are always splittable, which means we can split fungible tokens as many parts as we want to. And non-fungible tokens are never splittable. We can never split a non-fungible token. And again, for this, I'll just take the same example. I have $1 note, and if I want to split $1 note to maybe 10 cents of 10 coin, I can go to any shopkeeper and I can say that, hey, can you please take this $1 note and give me 10 cents of 10 coin? 10 coins of 10 cents. He wouldn't hesitate. If he has, he wouldn't hesitate to do that, right? But if I have a piece of car and I go to some shopkeeper, hey, can you split this car in 2 parts? Obviously, that's a very strange thing, right? So it's not only about cars. I'm taking the example. You take any fungible asset, be it a painting, be it a digital painting, be it a house, be it a TV, a fridge, anything that is non-fungible, you consider it and you will never be able to split it, right? Obviously. So another important property of fungible asset and non-fungible asset is fungible assets are splittable, and you can break down those assets in multiple parts, whereas non-fungible assets are not splittable and you cannot break down those non-fungible assets in some parts, right? So with this property, when we talk about lands, obviously land seems like a non-fungible token or non-fungible asset. But let's suppose if this big portion of land is owned by a farmer, and the farmer is quite modern and they want to sell out their land, but they don't want to sell out the whole piece of land in one chunk. Rather, they want to actually create they want to colonize it, and they want to create some roads in between, and they want to actually split this whole plot in maybe 6 or 8 different plots, and they want to sell it not as a one road but as 8 different plots. Maybe this is plot number 1, this is plot number 2, this is plot number 3, this is plot number 4, this is plot number 5, and accordingly we have 6, 7 and 8, and these that you see over here are nothing but roads. Okay, so I hope this makes sense to all of you, that obviously if the farmer would have if it would have been created as a fungible asset. Okay, let's suppose we want to launch this whole land thing on the blockchain network, and we want to ensure. So Bala, a token is basically like a currency only. Okay, it's just that there are two different things: a native asset that is known as currency, and the tokens which are created on top of a blockchain, they are known as token. It's simple. There are only two words. First is currency or a cryptocurrency, whatever you say. First is cryptocurrency and second is token. Okay, so cryptocurrency are all these native assets. Okay, all the native assets are referred to as cryptocurrency, and the assets which are created on top of a blockchain network, assets which are created on top of a blockchain network, they are referred as tokens. Hope that explains. Okay, so see, we have two different terminologies. First is cryptocurrency, second is token, right? So cryptocurrencies are the native currencies of blockchain, like BTC, Ether, Pragmatic, BSC, TRS. These are the native currencies of their respective blockchain, right? So they are known as cryptocurrency. Whereas the assets that are created on top of a blockchain network, like on top of Ethereum, we can create tokens, right? And they can be created using these protocols, ERC20, ERC721, ERC1155. So the tokens, that the assets that you create using these protocols, what would those assets be known as? They would be known as tokens. Although lands are non-fungible, but yet there should be a provision to split the lands in the multiple parts, as what we are discussing over here. And if in case you want to do that, you should not launch, or you should not create the assets of lands as a non-fungible token, because if you do so, then obviously you cannot split it like this. How this farmer wants to split, they cannot do that if it is a non-fungible asset. So in order to make sure that this farmer is able to do this, whatever we have discussed right now, like splitting a big portion of non-fungible token into smaller non-fungible tokens, this is what SFT does. Okay, so semi-fungible tokens are responsible for ensuring that a non-fungible token can be split into further non-fungible tokens. This is what a NFT does. Okay, and it's not only about lands, but you can also similarly consider golds. Okay, so a piece of gold again is a non-fungible token. but that gold again should be able to be divided into multiple parts and can be split into multiple parts. So for that, it should be created as a SFT. So all in all, you can consider this as one of the lands as one of the examples for semi-fungible token. And when we come back to this, then we can say that ERC1155 is the protocol that is responsible for generation or creation of semi-fungible tokens. And semi-fungible tokens are nothing but the ones that has the benefit of fungible token as well as non-fungible tokens. And the reason for that is simple. Like as I explained, that suppose I have 1 ether, I can easily transfer my 1 ether to you and you can transfer your 1 ether to me. And this 1 ether is not unique in itself, right? So because of these reasons, firstly, because it is easily exchangeable, secondly, it is not unique, and thirdly, it can be split into multiple parts, right? If I give you 1 ether and I say you that, hey, can you please transfer me 0.2 ether 5 times, that again becomes 1 ether. So for these reasons, they are fungible in nature. Okay, so with this, we can say that we have understood about the currency issuance from this diagram, and we have considered smart property as well. So smart property is nothing but the non-fungible token. Okay, so smart property represents any asset that can be converted to a digital form is a smart asset, right? It's the same way any property can be converted to a digital form and it becomes a smart property. So smart property is nothing but the NFTs, non-fungible tokens. It can be, let's suppose some of the artists wants to launch their own songs in the form of NFTs. Okay, so they can launch their songs in the form of NFT. Some of the artists want to create digital art, and this has been the most popular thing till now in the world of NFTs, that is digital art. Okay, so when I say digital art, let's actually see what does it mean. So we can head to OpenSea. So OpenSea is one of the biggest NFT marketplace. And when we head over there, we'll see most of the NFTs that are listed on OpenSea are digital art by different designers or by different digital creators. And you can easily purchase those digital arts in the form of NFTs. So as you can see, these are different arts that has been created by different artists, and you can easily purchase it, sell it, trade it, and whatever you want to do. Okay. So most of the NFTs that you would see today being traded would be digital piece of arts only. Okay. So as you can see, these are the actual pieces of arts, and you can see the price of this art is 1.66 ether. That's quite a lot. And if you ask what actually it is, and if I purchase it, what will I get? You'll just get this piece of image and nothing else for 1.66 ethers. That's roughly around $3,000. Okay, so yeah, this is what you get, and you can also see that how over the period of time, how who has purchased it, who was its previous owner. And in this way, this is very important part of blockchain, because you get to see whether a asset is a valid asset or an actual original asset or not. Okay, let's suppose if I'm the Picasso, just assume if I'm Picasso and I have made lot of paintings. If I'm Picasso and I have made a lot of paintings, okay, and I'm selling it, and someone has purchased, number one person has purchased, sell it to number two person, who has further sold it to number three person. If number three person is further going to sell it to number four person, and number four person wants to validate if this is the original painting or not. Is this an original painting? How they can validate this? They can see the complete history of this painting, and they'll see the first time when this painting was minted, or when the first time the painting was sold to this person. One, it was sold by me, that is Picasso itself, right? So this not only ensures that things being traded digitally, but it also ensure, because of the immutable behavior of blockchain, nothing can be tampered, edited, modified, or deleted, right? Because of this feature of blockchain, everything can be traced with utmost transparency in the network. And now, just because of this feature, you see why public blockchain plays a very major role. Okay, if this person would have, if there would have been an option that I don't want to show whom I purchased or what asset I hold, then again it would be very difficult to trace back and see from where it is coming. That is the reason in public blockchain everything is public, so that anybody can go and verify anything about any asset that is available, right? So the person 4 who wants to purchase and who's skeptical about person 3, that whether this painting is original or not, he just has to go and see this trading history part, and he can go and see, here it is. So the price history and the trading here also, you'll also find the trading history, which gives the complete information about, or maybe you can, yeah, simply go and open it on the website, and then from there you can go on the Etherscan, and on the Etherscan for this particular asset you can see it completely, that who has purchased this asset and at what time and from whom, right? So most of the time people, what they do is, for the authenticity, they also validate, they put a name. So like you see, this is not an address, this is a Lido execution layer. So they have notified their address. This is known as DNS, and this is also known as ENS, Ethereum Name Service. So for this address, they have replaced their name with their actual name. Okay, so along with this address, you can also see what is the name of this. So it is the name of this is the public name tag is Lido execution layer rewards vault, is the name given to this address. So in the same way, if I'm the Picasso, I'll use ENS, Ethereum Name Service, like the way you have DNS, right? Domain name services. What is DNS? DNS is nothing but a name that you give to a particular IP, right? You map a particular IP to a particular domain, and that becomes yours, right? In the same way, ENS supports that a particular addresses can be mapped to a particular name, just for authenticity and transparency. So we'll not discuss much about ENS, that you can read about separately. But yeah, with the help of this, you can add an extra layer of transparency in it. So this is what I wanted to show all of you, that the maximum amount of NFTs that are traded today are mostly the digital piece of art, although there are a lot of other things as well, like the gaming things, the memberships, the PFPs, and of course the photography. So you can purchase all these things, but yeah, these are the most important things that are being traded today in the digital world, specifically about photography. So with this, we have covered two different aspects that we wanted to cover. The first is currency issuance, and the second one is smart property. I mean, that's one of the metadata. So if you read about NFTs separately, there are a lot of factors in an NFT. So that image is basically a metadata, and you have to deploy that image on a piece of decentralized server. Like we have a lot of decentralized server. One of them is IPFS. If in case you want to read it in detail, you can just note down this term. It is interplanetary file system. So this is a distributed storage. Okay. So like this, today we have Google Drive, right? In Google Drive, you can store multiple things, multiple files, videos, audios, and multiple things. But that's a centralized server. Google Drive is a centralized server which is being managed and maintained by Google as an organization, right? But on the other hand, you have decentralized servers as well. That is IPFS, Interplanetary File System. How they function is they function in quite a different way. Okay, they function using reference by the key. Here it is referenced by the key, and here it is referenced by the path where the file is present. You can read about that separately. And on that server, you'll be first storing your image. Then this server will give you a unique URL. Okay, a unique URL will be given by the server stating where your asset is placed. Okay, the image that you have uploaded, where it is placed. And once you get that URL will be passed as a metadata of your NFT that you are creating. So the NFT that you are creating on the Ethereum blockchain, in that there'll be a concept of metadata, and this URL will be passed over there. Okay, so I don't want to complicate it too much, but for now you can just understand it like this, that let's suppose if I want to share something to you, if I want to share a huge file with you, maybe a recording with you, what are the options I have? I might just upload it on Google Drive. Google Drive will give me a link, and that link I'll share it with you, right? So that you can access that. Same happens with NFTs as well. So when you want to create an NFT, rather than going on Google Drive, you will upload an image on IPFS. IPFS will give you a link, and that link you will put it in that NFT that you are minting. Why is putting this link in this NFT important? Because this will ensure that you are the one who have minted that, who have put that image on IPFS. And because the blockchain is immutable, untamperable, uneditable, whatever NFT metadata you put, whatever link you put in this NFT, that is always going to be present in that, and nobody can tamper that. So it proves that yes, you are the actual owner of that image that you have published on IPFS. I hope this makes sense. Lot of new terms involved over here, but you can read about them separately. IPFS is an interesting thing. If you want, you can definitely read about that. Obviously, the pioneer in this case is Ethereum, because Ethereum was the one who bought this era where NFTs can be created. But now there are a lot of blockchains that are supporting the minting of NFTs. So yeah, smart property, as I discussed, smart property is nothing but a smart asset. You have a piece of painting, you digitalize it, or you create an NFT of that painting, that becomes a smart property. You have a house, you create an NFT of that house, that becomes a smart property. You have a land, you create an NFT of that land, that becomes a smart property. Great. So now we'll come back to the smart contract part. So we have already understood about the smart property and the currency issuance. So now what we are going to cover is the smart contract. So see, more importantly, when we talk about smart contracts, they're simple, right? Contracts turn digital becomes smart contract, right? Contracts turn digital becomes smart contract. So they are digitally programmed agreements between two or more parties that only executes when certain conditions are met. Okay, you can clearly understand this, that these are the digitally programmed agreements between two or more parties that only executes when certain conditions are met, and they are capable of handling any type of business logic and executing it over the Ethereum blockchain. Repeating again, they are capable of handling any type of business logic and executing it over the Ethereum blockchain. Can smart contracts self-execute? This is very important. So smart contracts cannot self-execute, and EOA has to trigger the smart contract, then only it can execute when certain conditions are met. Now, two new terms over here, smart contract and EOA. So if you remember, we discussed about types of accounts in Ethereum blockchain. So we have two different types of accounts in Ethereum blockchain, right? So one type of account is something that we have already seen. If you remember, one type of account is the one that we just created, using the public and the private key. And we will even see this practically, how to actually create a externally owned account. That's fine. And another type of account is the contractual account. So externally owned accounts are created using any of the wallets. Okay, externally owned accounts are created using any of the wallets, and they have a public key and a private key. The public key used for encryption, the private key used for decryption. On the other hand, we have a contractual account. So contractual account is nothing but when you deploy a smart contract onto the blockchain network, it generates a unique contract address.
Okay, it generates a unique contract address specifically with that represents that smart contract. Okay, so whenever you develop a smart contract, obviously you will deploy it. When you deploy the smart contract on a blockchain network, it will generate a unique contract address, and this contract address that is uniquely generated is uh, a unique representation of this smart contract. Okay, and with the help of this, you can get to know that how the smart contract accounts are maintained. So smart contracts are nothing but the contractual accounts are nothing but a smart contract deployed on a blockchain network. That's it. Whereas externally owned account are the main account on the Ethereum blockchain, and they have a public key and a private key. So with reference to this, we have written over here that the smart contract can never execute by itself. It's always that an EOA, that is externally owned account, has to trigger the smart contract, then only it executes when certain conditions are met. Okay, so this is about the smart contract. They are nothing but a digital piece of program that is nothing but acting as an agreement between two or more parties and will execute when certain conditions are met. This is exactly what contracts are, right? When I talk about legal contracts, or when I talk about agreements or agreement contract between two parties, what is it? They are nothing but certain agreements between two or more organizations or people or country or whatever it is, right? And they are responsible for being triggered when certain conditions are met, right? In the same way, the smart contracts are nothing but a digitally programmed agreements. They are paper agreements, the contracts are paper agreement, and the smart contract is a digitally programmed agreement. The only difference between the two, now that's very important. What's the difference between the two? So for that, let me pull up another image which explains what are the advantages of a smart contract. And before even this, I'll have to, let me just close. A lot of images are open. So what's a legal contract? A legal contract will have certain terms and conditions that are defined in that piece of paper. And maybe this legal contract is signed between party one, that is nothing but organization one, and the party two, that is nothing but the organization two. So these both the organizations have signed a legal contract among themselves, and certain number of terms and conditions are defined within this legal contract. And if in case at any point of time, any of these legal contracts are not met, right? If in case at any point of time, if any of these legal contract, I mean, any of these terms and conditions are not met, then what will happen? They'll reach out to the legal authorities or the legal regulatory bodies of that country where that contract is applicable, and they'll request them to sort out the issues between them, right? Let's suppose if terms and condition one that is mentioned, there's one condition that is mentioned that was to be followed by party one, but party one has not followed it. So party two can reach out to the legal authority or regulatory body and would request to please make sure that a proper settlement is done between them. But of course, this process is time consuming, resource consuming, and money is also spent over here, right? So time, resource, and money, all things are spent just to ensure that all the terms and conditions are met over here. So a replacement of this can be a smart contract, wherein again you have party one and party two, which are responsible for doing a trade-off agreement between them. So rather than creating a contract, or maybe along with creating a contract, they also create a smart contract so that they actually don't have to spend a lot of time. If in case anyone breaks any of the terms, they don't have to spend a lot of time, resource, and money by reaching out to the legal authority or legal regulatory bodies. So party one and party two both create or develop a smart contract which has certain terms defined. Along with the terms, if it is not followed by either of the parties, what would be the consequences? Even that is defined. And this is then signed off by both of them. Okay, this is then signed off by both the organization using their private key, or somehow they are signed by both of the organization.
After a few years, maybe after 5 years, the party 1 is not following the term 3 and term 4. Okay. After a few years, the party 1 is not following term 3 and term 4. So what will happen? Automatically, consequence 3, 7, and 4 will be invoked. Automatically, consequence 3, 7, and 4 will be invoked. So the same consequence would have been requested by party 2 from a legal authority to be rolled out for them. But now this piece of program only is handling that. So as and now and when term 3 and term 4 are being followed by party 1, automatically consequence 3, 4, and 7 will be invoked, and accordingly the compensation can be provided to party 2 or whatever it is. It might not be a compensation, it can be anything. Okay, so this is what a smart contract is. Now you can say, or now you can think that at the end it is just a piece of program, right? So why can't we develop it in any, in any other programming language? Even in JavaScript or even in Java or in Python, we can write a program like this. Why to give a unique name like smart contract or something? It's at the end, it's just a piece of program, right? So I can program this in any other native programming language, and I can deploy it in the form of application, and I can get it running. That's absolutely right. But why it is smart contract and why blockchain is very important for this is because of its immutable behavior. Maybe you deployed a piece of program that does the same work, but what are the chances that anybody cannot come and tamper that piece of program, or anybody cannot come and tamper the terms and the consequences that are present in the piece of program? A hacker can come and tamper those, right? But because of the blockchain and the distributed ledger technology, the smart contract, once which is deployed, can never be tampered, edited, and modified by anyone in this world, right? Unless both the party agrees to get it tampered or get it modified or create a new version, launch a new version or an upgraded version of the smart contract. And that will happen, of course, only with both the parties signing that once again. So basically, the smart contracts are developed in Solidity programming language, and that is what we are going to start and learn from scratch. So if you learn that well, and if you do a lot of practice in that, definitely you'll be able to write the smart contracts. Okay, so the good thing is the smart contract, I mean the programming language that is used for development of smart contract is Solidity, and we are going to learn it from scratch till and we'll cover it completely. Blockchain world is full of smart contracts. Okay, so let's suppose I want to let's suppose the same example I'll take, the land one. Okay, so I want to create a way how I want to ensure that I want to sell, I'm a farmer and I want to sell these pieces of land to somebody, and that person, let's suppose someone purchased the land one, he further can break down his land in two parts and can sell it to respective owner of one dot A and one dot B. Similarly, two can split their lands in two parts. So all these things, how they are managed, they are managed using the smart contract. So there will be a smart contract which will be programmed to manage all this thing, and how anybody can come and purchase, how anybody can sell, how anybody can split their lands, and everything. So everything that happens on the blockchain world happens with the help of a smart contract only. Let's suppose I want to create a loan application. When I say a loan application, let's suppose I want to create an application, a peer-to-peer application where one person can come and give the loan and one person can come and take the loan. Okay, and I don't want to, I mean, I'll just charge a very nominal fees of 0.01%, which in case of banks varies from 2 to 10%, right? So if some, what do banks do? Banks takes monies from someone and gives it as loan to other person, and in between they make huge margin. So the person who deposit the money get fewer rate of interest, and high rate of interest is charged from the person who takes the money. In between, whatever is the margin, that is taken by bank. So if I want to utilize blockchain as a platform for this, and because everything is immutable and everything is untamperable over here, so I might just charge small fees, maybe just 1% fees. So this 10 can be reduced to 1, and I can give 5% benefit to this person, asking him just to pay 10%, and I can give 4% benefit to this person, saying that you will get 9% interest, and I'll just charge 1%. So how all this thing, how will it be managed? Using smart contracts. So every business that run on the blockchain network is managed through smart contracts. Okay, that's great. So with this, guys, we can say that we have covered the currency issuance. We have covered the smart contract, we have covered the smart property, and now we'll discuss about decentralized autonomous organization. So what's a DAO? What's a decentralized autonomous organization? So you can say that everybody who belongs to the smart contract, all the people who are involved in the smart contract may form a DAO among themselves. What does it mean that they may form a DAO among themselves? DAO is a decentralized autonomous organization which is responsible for ensuring the decision making in the network, the decision making within that network. What does it mean, decision making? What I mean to say is, let's suppose tomorrow, after 5 years, few more terms have to be added in the network. Okay, few more terms have to be added in the network, or few consequences have to be added in the network, or a few consequences have to be removed from the network. So how can this happen, right? So for that, a DAO is created. A DAO will contain members from party 1 as well as party 2 who can vote for certain things. Okay, let's suppose here we have 5 members, and here we have 5 members who are part of this DAO, and they can vote for a certain consequence. Let's suppose everybody wants, or one of them, just not everybody, just one of them out of this 5%, just one of them is proposing that we should have a term 6 in this smart contract. After 5 years, one of these 5 members of party 1 is proposing that we should have a term 6 also with such and such clause and consequence in the smart contract. Now he can propose it as a request in the network, and rest everybody can vote on it. Okay, let's suppose if he gains the majority, means 4 people vote from here and 3 people vote from here, which means total 8 out of 10 people are in favor of this term 6 getting added in the smart contract. So this will be upgraded to version 2, which will have this term 6 as well. So how this decision making and how this change in the smart contract can happen? It can happen with the help of a DAO. So a DAO is a decentralized autonomous organization. It's nothing but a group of people who are responsible for the decision making in the network. Smart contracts are nothing but the building blocks of program written in Ethereum platform called smart contracts. And smart contract is a computerized transaction protocol that executes the terms of a contract. When running on blockchain, smart contract becomes like a self-operating computer program that automatically executes when specific conditions are met. So as we can see, there are different ways of executing and how it can maintain the smart contract among each other. So what's the cryptocurrency that is used in Ethereum? The cryptocurrency that is used in Ethereum is Ether. And what exactly is Ether? We just discussed that Ether is one of the, Ether is one of the native currency of Ethereum blockchain. So the Steam token of Ethereum blockchain is known as Ether. It is recorded under the code ETH and is exchanged on digital currency trades. It is also used to pay for the transaction fees and the computational services on the Ethereum network. And this transaction fees is known as gas. Okay, so every time a contract is executed, Ethereum consumes a token which is termed as gas to run the computation. And when we talk about this gas, it is nothing but token itself. Okay, so this is just a denomination table of Ether, that how the denomination table of Ether varies over the period of time. over the period of unit. So the smallest unit of ether is V. Okay, the smallest unit of ether is V. So the smallest unit of ether is V. So we can clearly see that V is 1V, then we have kilo V, then we have mega V, which is nothing but 1 million V. Kilo V is 1000 times V. Giga V is 1 billion times V. Micro ether is again 1 into 10 to the power of 12. Milli ether is 1 into 10 to the power of 15 V. And finally, ether is equal to 10 to the power of 18 V. And that is the reason we also have 18 decimals in the Ethereum. We have 18 decimals in ether. So yeah, this is not, you don't have to remember it. Okay. But yeah, just one relation you should remember is 1 ether is equal to 10 to the power of 18 V. This is very important to understand. Yeah, so as we can see over here that for any transaction that happens between a sender and the receiver, okay, let's suppose this is the sender of the transaction who wants to transfer 1 ether to the receiver. So what will happen? Is it like this that he sends 1 ether and the receiver will receive some less amount? No, it's not like that. Is it like this that the receiver also has to pay some transaction fees? No, it's not like that. It's simple. Whatever the transaction sender will send, the complete amount will be received by the receiver. But along with the transfer that is made by the transaction sender, some extra fees has to be paid by the transaction sender, also known as gas. Okay. This fees is the transaction fees that, if you remember, that we discussed during the mining topic, that miner receives the reward of the transactions, right? So the miner receives the reward of the transaction. Whatever reward the transaction, whatever reward the miner receives of the transaction, these are independent transaction fees that are paid by the transaction originator. Okay, so let's suppose if the miner is validating 10 transactions, all the individual 10 transactions will be having some fees associated with it. All those fees would be given to the miner who has validated that particular transaction. Okay, so now this fees is fine, but more importantly, we need to understand that the concept of gas. So gas is just a terminology, but at the end, what is this gas? It is ether only. Okay, at the end, a gas is nothing but a ether only. But it is termed as, a terminology of gas has been given to it because the way, the way gas is used to drive a car, or the gas is used to make sure a car is running. In the same way, a gas in the Ethereum blockchain is needed and is used to ensure that the blockchain is running continuously and in a smooth manner. So this is the gas. A gas is nothing but some fees in the form of ether, which is paid by the transaction sender in the form of an incentive, which is given to the miner. Are we clear about what is gas in Ethereum blockchain? Okay, so gas is basically, as I just explained, gas is basically some fees in the form of ether, which is paid by the transaction sender for doing a transaction as an incentive, which is given to the miner, which is credited to the miner's account. Repeating again, gas is basically nothing but some amount of ether as fees, which is paid by transaction sender as an incentive to the miner. So now we'll move ahead. What is a transaction fees? On what parameters a transaction fees is dependent? And we'll try to understand what exactly defines the transaction fees, how we can modulate the transaction fees, and how will it impact the transaction speed. Okay, we'll discuss about those things. So a fees is paid for the transaction to be included in the miners. The more the fees, the higher the chances that transaction will be picked up by the miners and included in the block. So what does this mean? This is a very complicated and a very important statement. The more the fees, the higher are the chances that the transaction will be picked up by the miner for inclusion in the block. Okay, so on an average, I'll just remove it and I'll put up few facts. Okay, I think I already have an image for that. On an average, a transaction of Ethereum an Ethereum transaction takes about 30 to 50 seconds to be confirmed. Okay, on an average, an Ethereum transaction takes about 30 to 50 seconds to be confirmed. So, which is fine. But is there a way that I can make this transaction processing faster? Like, is there a way that I can make sure that, the miners picks up my transaction first? The miners picks up my transaction first from the main pool, of course. If you remember, I clearly told to all of you that miners will pick the transaction from the main pool, validate it, and put it in their candidate block, right? So yeah, as of now, we are discussing with respect to the proof of work that was existing earlier. Obviously, in proof of stake, it is decided and it is divided by the consensus itself. So the one who has got more stake will be getting this opportunity to take up that transaction first, right? But even in that case, the validator will have, let's suppose a particular block is given to be validated by a particular miner or a validator. So they will have an option, they will have a chance to pick up the transaction from the main pool first that they want to pick up, right? So the scenario still remains same over there itself. But yeah, over here we are talking with respect to the miners. So yeah, so is there a chance that miner will pick up my transaction first from the main pool? So yes, there is a chance. How? By increasing the transaction fees. Okay, so if we increase the transaction fees, that will attract the miner or the validator. In case of proof of stake, it will attract the miner or the validator to pick up my transaction first, validate it, and put it in their own respective block, right? So when they do so, obviously they'll get more fees for the transaction. So every miner will choose to pick those transactions which have got more transaction fees. So that is the reason 2 points come over here. So more the fees, the higher the chances that the transactions will be picked up by the miner for the inclusion in the block, which completely makes sense now. And also providing too little gas will result in the failed transaction. What does this mean? This means that let's suppose there is a nominal fee that is set by the network. Nominal fee set by the network. When I say network, obviously it's the consensus which defines and decides all this. So now you have two options. Either you can increase the fees more than the nominal fee, which will result to faster confirming of transaction. And the other option is you will decrease the fees even below nominal fee. And that might lead to no miner or validator picking your transaction. And this eventually will lead to non-confirmation of transaction forever. Okay, so there's a nominal fee that is set by the network, and obviously this nominal fee keeps on varying. It's not a hard and fast or a fixed cost or a fixed fee. It keeps on varying depending on multiple factors like network congestion, miner availability, transaction frequency, and multiple other. But yeah, if you increase the cost beyond the nominal fees, which means it will attract the miner and it will result in attract miner and would eventually result in faster confirming of transactions. That's correct. But on the other hand, if you decrease the fees even below the nominal fee, which will result in no miner or validator picking your transaction, which means it will be just present in the main pool, which eventually will lead to non-confirmation of the transaction forever. So which means you have two options. Either you increase the fees, that is completely optional. If you are in a hurry, you do that. But if not, then at least send the nominal fee which is set by the network. If you lower the fees even beyond the nominal fee, that would eventually result in non-confirmation of the transaction. This is exactly what is trying to be depicted over here. Providing too little gas will result in a failed transaction. Hope this makes sense to all of you. Now, another important thing that comes up over here is, fine. So till now we have discussed about increasing the transaction fees, decreasing the transaction fees, or letting the transaction fees be as it is or whatever it is, right? But we haven't understood till now how this transaction fees is actually calculated. When I say transaction fees, what it is, how is it calculated? Okay, how is it decided that how much fees I have to pay for a particular transaction? Is it like a fixed cost that I have to pay for each and every transaction? Or is it something that varies from transaction to transaction? How many of you think that it might be a fixed cost that I have to pay for every transaction? And how many of you think that it can vary from transaction to transaction? So of course it will vary, but before that I'll just answer the question asked by Anurag. So Anurag, the reason for lowering the transaction fees can be that you want to save some cost. Obviously, if you send lower transaction fees, so the overall transaction cost would be reduced, right? Let's suppose if you wanted to send 1 ether, where's the diagram? I think it's gone. Yeah, no, not okay. Anyway, so if you wanted to send 1 ether, along with this 1 ether, you'll have to pay some fees, right? So the lower that fees is, that much amount of money you are saving, right? So everybody would like to say save more and more money, so they'll like to pass lowest possible fees that is possible. Okay, so obviously this is the reason why you would like to lower the transaction fees. But while lowering it, you should always ensure that you do not lower it beyond the nominal fee that is going as of now, that is running as of now.
Clear, sir. Thank you, sir.
Okay, coming back to this. So yeah, the transaction fees, of course, can vary over the period of time. And it varies on two things. So the transaction fees is calculated by the formula. Okay, I think that's already there. So the concept of gas is having two things, the gas price and the number of gas. Okay. So the transaction fees is calculated on the basis of the cost of transaction, or also known as transaction fees, whatever you say, is calculated with using the formula gas price and the number of gas. Now the question is, what is gas price and what is number of gas? So for that we'll come over here and here. Gas price is cost per gas. Gas price is cost per gas, which means what is cost of one gas, and then second is number of gas, how many gas your transaction is using. So how do you calculate number of gas price? Is simple, right? Gas price is a fixed cost per gas, simple. But then there is another thing that is known as number of gas. Number of gas is the total opcodes that is being used in your program or the function of the smart contract. Okay, number of gas is the total opcodes being used in your program or the function of the smart contract. So when you say that number of gas is nothing but the total opcodes being used in the program.
Let's have a quick quiz question, guys. And the question is, what is a 51% attack in the context of a blockchain? And your options are a type of cryptographic algorithm used for securing transaction, a cyber attack where 51% of the computers are infected with malware, or when a majority of network participants control a blockchain, potentially leading to manipulation, or a method to increase the efficiency of blockchain mining. Please mention your answers in the comment section below. Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. Repeat. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
Okay. So yeah, basically opcode is defining what exact operation has to be performed. Okay. So in computer programming, or in the world of computers, opcodes is basically what instruction has to be executed either by the hardware or by any other piece of software. Similarly, in smart contracts as well, opcodes are the operations that has to be performed, like sum, mul, div. These are operations, like sum is summation, mul is multiplication, div is division. So these are different opcodes that are performed or that are present within the smart contract. So sum occupies or consumes 2 gas. Similarly, mul consumes 4 gas. Similarly, div consumes 4 gas. So like this, every opcode has got a specific number of gas that is consumed by it. So let's suppose if you want to execute a function like this, which has 1, 2, 3, and 4 multiplication. So 4 multiplication consuming 4 gas each means 16, plus 1, 2, 3 summation. 3 summation having 2 gas each means 6. So total of 22 gas. So which means if you are executing a function like this, it will be consuming 22 gas. Exactly 22 gas. So repeating once again, opcodes are nothing but the operations that has to be performed by the smart contract. These operations can be exemplified with sum, mul, div, and multiple other operations are there. And then each operation is actually defined to consume a specific number of gas. Like sum is consuming 2 gas, mul can consume 4 gas, like this. So this is just an example again. So in the same way, if you are executing this function, it will execute and it will consider a specific amount of gas, that is 22 gas. Okay. So I hope now you understand the gas price is the cost per gas. How do you get this? This is not something which is in our hand. And to get what is the cost per gas right now, we can just go on Etherscan and we can see what is the cost per gas. So you can see medium gas price is 19 and it is now 24. It keeps on varying. Okay, so medium gas price as of now is 24 gigaV, which means cost of one gas in the current market is 24 gigaV. Okay, and it keeps on varying every minute and every second, depending on a lot of factors like availability of miners, transaction frequency, availability of nodes, and all other things. So now you can see it's 26. Earlier it was 24, now it's 26. It keeps on varying. Okay, so this is what is the gas price. Is changing gas price in our hand? I mean, can we change it? No, of course we cannot change it. This is something that is totally decided by the network, that what gas price should be there as of now. Okay, it is decided by the consensus itself. So you see now it is 25. So it keeps on varying. The thing that I want to show you is it keeps on varying. So now coming back once again over here, coming back once again over here, the cost of transaction is dependent on the gas price and the number of gas. We understand what is gas price. It is nothing but the cost per gas, and the number of gas is nothing but the total amount of opcodes that our smart contract is using, and on the basis of that, the total amount of gas that would be needed would be calculated. It is simply like, if you want to take your car out And if you want to run or drive your car for another 100 kilometer, you must know and estimate that how much liters of fuel would be needed, right? How much liters of the fuel would be needed. So accordingly, you'll fill up the tank with that many liters of fuel. In the same way, for a particular transaction to be executed, how much gas would be required, that would be dependent on how many number of opcodes are being executed. On the basis of that, you can calculate what is the number of gas would be required. Is the concept of gas with respect to gas price and number of gas clear to all of you? How the cost of a transaction is calculated? This concept is applicable for proof of work as well as for proof of stake. Gas, right? I hope this makes sense to all of you now. That the transaction fees is calculated by the formula of gas price multiplied by number of gas. That's fine. But I just discussed that you can increase the transaction fees beyond a nominal fee, right? You can increase the transaction fees beyond a nominal fee to attract a miner. And that would result in faster confirmation of the transaction. Can anybody tell, when I want to increase the transaction fees, shall I increase the gas price or the number of gas or both? What shall be increased? Because it is multiplication, right? If I increase any one thing out of it, the transaction fees will be increased. So do I have to increase one thing, that is gas price, or one thing that's number of gas, or both? And it would be good if you can give reasons. All of you should think about this. Very important. Okay, let's try to understand. So see, obviously the number of gas is something that is dependent on what is the piece of program you are executing, right? Number of gas is not something in our hand. Even if you increase or decrease the number, I mean, obviously you cannot decrease the number of gas, but even if you increase the number of gas, it would not impact the network. It would not impact the miner. For this, you can just understand this using a very simple example. Okay. So let's suppose there is shortage of sugar in the market. Let's suppose there is a scarcity of sugar in the market and you go to the market to buy 10 kg of sugar. So how the price of 10 kg of sugar would be calculated? Obviously, the quantity of sugar you want to purchase and the price per kg of sugar, right? Quantity of sugar that you want to purchase and price per kg of sugar. So because there is a scarcity of sugar in the market, if you go to the shopkeeper and you want the shopkeeper to give the sugar, I mean, he should prioritize you as a customer and not anybody else. So what would you increase? The quantity of the sugar you would increase or the price per kg of sugar you would increase? Obviously, yeah, obviously the price per kg, right? Because if you increase the quantity of sugar, that would rather complicate the situation even more, right? Because at the end you are asking for 10 kg, now you're even asking for more, keeping the same price per kg of sugar. So the shopkeeper is not getting benefit out of it, right? But when you increase for the same quantity, when you increase the price per kg that is being offered by everybody else, so if everybody is offering 40 rupees for 1 kg of sugar, and if you say that I'll be offering 50 rupees for 1 kg of sugar, so obviously the shopkeeper will prioritize you as a customer, right? Same thing happens over here as well. So what you have to increase is the price per gas and not the number of gas. Number of gas is fixed. Like you went to buy 10 kg of sugar, that is fixed, right? Similarly, the number of gas that would be executed would be fixed. What you should increase is the price of gas, the gas price. So if the median gas price in the current market is, if the median gas price in the current market is 25 gigaV, and if you offer more, that is if you offer 30 or 35 gigaV, so the validator or the miner would be more interested in your transaction than anyone else, right? So this is the whole concept of gas fees, transaction cost, and everything. So yeah, you can see the low is 25 gigaV, average is 25 gigaV, and high is 27 gigaV. So which means if you are offering this much, then obviously you will be given high priority. And you can see here that if you are having 28, now it has changed. So 20, if you offer 28 gigabyte, your transaction will be validated in approx 3 minutes. But if you offer 31 gigabyte, the transaction would be, the transaction would be validated in about 30 seconds, right? So this is how it varies overall. Hope this makes sense to all of you. Yeah, if you decrease it beyond the nominal fee, then obviously for that time being, it won't be validated. So let's suppose it happens like this. Let me give you an example for that. So let's suppose, see, right now it was 31, right? Right now it was 31. So, okay, assuming that right now it is 26 and you sent 24 or 23. Okay, so obviously it is 26 right now and you have offered just 24 or 23. So what will happen? Obviously, as of now, none of the miner will pick up your transaction, right? Because you have even offered less than what everybody else is offering. So rather than offering more, you have even offered less. So that is very critical situation. None of the miner or the validator will pick your transaction. So what will happen? Your transaction will keep on, your transaction will just be present in the main pool. Until when? The question is this, until when? Till when it will be present in the main pool? Until this values decreases and comes to 23. As soon as this value decreases and comes to 23, then obviously your fees that you have offered will become a nominal fees that everybody else is also offering, and then only your transaction will be validated. But if you offer too little gas, let's suppose 2 or 3 gas, which is practically impossible, that less it will never come, right? So your transaction will be failed. Types of accounts we have already understood. Two different types of accounts: externally owned accounts and contractual accounts. Miners, mining rewards, consensus, we have covered it all. Okay, so another important thing is web3.js. Now, what is web3.js? This is quite a complicated diagram. I would like to explain it with a simplistic approach of what is web3.js. So guys, what happens is, this is our smart contract. Yeah, so you can say it like this. Okay, so if you have to understand DApp, so it's nothing but most of the time you must have heard DApp. So that's the reason I wanted to understand. I wanted to spend a few minutes on this. That see, DApp is like a superset of smart contract. Okay, so decentralized application is the one that includes the front end, that is UI UX, the middleware, as well as the Solidity smart contract. Okay, so a DApp includes all three, and that is basically a DApp, decentralized application. Okay, the one that includes the UI UX, the one that includes the middleware, and the one that includes the Solidity smart contract. All together, it forms a DApp. So now let's individually understand what's a front end of a web application, what's a middleware, and what's a smart contract. So DApp is nothing but a complete architecture, or a complete, what do you say? The complete specification of a particular application. So it includes the UI, the middleware, and the backend. Although you can have a separate blockchain as well, but yeah, typically in a DApp architecture, this is a backend. Along with this, you can have your own choice of backend as well if your application needs it. Okay, so dApps technically are Web3 applications. They're also known as Web3 application. But whenever we say Web3 application, obviously everything is not residing in the Web3. Please understand this very carefully. So what is a dApp? dApp is a Web3 application that runs on the blockchain technology. A decentralized application runs on a distributed network of computers, and that is the reason it is known as Web3 application. Okay, Web 3.0 application. And because of Web 3.0 application, we need to understand that everything is not available on Web3 only, right? So we still code the UI in some basic languages like HTML, CSS, JavaScript, or any of the frameworks of JavaScript, or whatever, in whichever language we code, that still is a part of Web 2.0 only, right? That still is a part of Web 2.0 only. It does not belong to Web 3.0. So only this part is Web 3.0. That is the smart contract and the blockchain world. Now, we need something that connects the two worlds, right? We need something that connects the Web 2.0, where our UI UX is residing, and Web 3.0, where our backend smart contract is residing. So what connects both of them is web3.js. This is basically a library which helps to connect the web 2 world and the web 3 world. Okay, it's basically a library only which helps to connect the web 2 world and the web 3 world. So there are three different types of libraries that are available. Okay. There are three different types of libraries that are available. Okay, so these libraries are web3.js, which is nothing but a JavaScript library. This is web3.py, which is of course a Python library. And this is of course web3.j, which is a Java library. Okay, so you can choose any one of them as per your own expertise in any of the programming languages. But yeah, one of them is needed in order to actually integrate or connect the web 2 world to the web 3 world. Okay, so let's suppose, how does this happen? So let's suppose you have a function called as buy in smart contract, and when you want someone to buy something, you want this function to be executed. So you'll have to create a UI interface such that buy token will be there. Here the users can enter the amount of token that they want to buy and hit the buy button. As soon as they hit the buy button, automatically this method will be invoked and this function would be called, right? And then this function would be executed. But how this on the click of this buy button, how this function would be invoked? So this would be invoked using web3.js. So web3.js has two things: methods and events. Methods are responsible for invoking the functions, and events are responsible for sending or emitting the values from the smart contract to the UI. Okay, methods are responsible for invoking the functions of smart contract, and events are responsible for emitting the event values from the smart contract to the UI. Okay, so this is the overall dApp architecture that is right in front of you. It has a front-end web application which can be coded in any of the Web 2.0 technological stack available. We have web3.js or web3.py, and then we have on the backend side, we have the Solidity smart contract, which resides in the Web3 world. So to connect this Web 2 and the Web3 world, we have a middleware library that is web3.js. It's available in three different libraries format. We have web3.js, web3.py, or web3.j. We even have some more libraries, like we have ether.js. But yeah, as of now, I want to keep it simple. There are a couple of libraries. In generalized manner, we can say there are a couple of libraries which are responsible for connecting the two worlds, that is the Web 2 world with the Web 3 world. And with the help of these libraries, we can incall certain functions of our smart contract from the UI of our application. So methods are the ones which are responsible for invoking the function from the smart contract. Okay, and events are the one which are responsible for emitting the event values from the smart contract to the UI. Okay, let's suppose I purchased 1,000 token. Okay, so I'll enter 1,000 over here, and this will call the buy function of the smart contract, right? This will call the buy function of the smart contract. This is done using methods. But on the other hand, we have events. So once this buy function is executed successfully, it has to return true, so that our UI can get to know that yes, this function has been executed successfully, right? So what will happen? This function will emit an event saying true, and this will be passed using events. This will be passed to our UI, and then UI will get to hear or get to see or listen to this event and say, yes, that function of buy was successfully executed and you have successfully purchased 1,000 tokens. Right? So for invoking of a function from smart contract, methods are used, and for emitting of event values, we use events. I mean, the only difference is that Web 2.0 applications are residing in a centralized ledger and in a centralized server, whereas Web 3.0 applications are residing in a distributed system of computers, right? Distributed ledgers. That's the major difference between a Web 2.0 application and a Web 3.0 application. The only way, see, programming languages are not the one that decides the whether it's a Web 2 or Web 3. The same programming languages can be applied and are used in Web 2 as well as in Web 3, but it is the uses, or it is the use case of that application, the way how that application is stored and managed and processed, that decides whether it's a part of Web 2.0 or Web 3.0. Like a clear and a major difference between a Web 2 and a Web 3 application is a Web 2 application resides on a centralized server like AWS or Google Cloud or any of the centralized server, maybe your own private server. But on the other hand, a Web 3 application, typically a smart contract, is residing on a distributed system of computers. So that's one of the major differences between the two. So if you remember, we discussed that there are a lot of Ethereum clients. A few of the Ethereum clients are available right in front of you on the system. So these are the list of Ethereum clients. We have Get, that is one of the most popular clients of Ethereum, which is developed in Go programming language, developed by Ethereum Foundation itself. Okay, and then there are a couple of other clients of Ethereum as well, just to increase the availability of the scalability and the availability of Ethereum to multiple blockchain developers. So we have Parity, which is coded in Rust, and the developers are ETHCore. CPP Ethereum developed in C++, PyThab developed in Python, Ethereum JS library developed by JavaScript, Ethereum J in Java, Ruby Ethereum in Ruby, and Ethereum H in Haskell by Block Apps. So these are the different clients of Ethereum, which means if you want to fork Ethereum and create your own blockchain, you'll have to use one of the versions or one of the clients of these different available types. And the one that is mostly used is the Go Ethereum, that is Get. Okay, so Get is one of the most popular and widely used clients of Ethereum, and most of the blockchain projects, I mean, most of the forked versions of Ethereum that you will see out there, like we have Polygon, we have BSC, these are forked from Ethereum only, and even Tron as a blockchain is forked from Ethereum. So they have been forked from the Get client of Ethereum, and they are developed on top of that only. Okay. But there are a couple of other clients as well, which you might be interested in only if you are a protocol blockchain developer, not a decentralized application developer. Only when you go in the protocol layer, then you might be using or needing any of these. Okay, so these are just a few features, nothing much to discuss over here. The Swarm is for messaging, Whisper is for messaging, Swarm is for data storage, and a client is basically for interaction with the blockchain. Okay, so just three things are the major features of Go Ethereum.
Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
Okay, so let's suppose if I'm the person who is creating the blockchain network, let's suppose I'm the founder of Ethereum. Okay, so to be honest, if you are a creator of a blockchain network, there are multiple ways how you can make money. Okay, the first, of course, way is through network effect. What does it mean when I say network effect? Network effect is a simple phenomenon when more and more people come and use your platform. It's also known as PaaS. Okay, platform as a service. So what you're doing is you're giving platform as a service to the other organizations who can come up and utilize your platform in order to do their business, which will increase the network effect because more and more people will come and use your platform. When more and more people come and use your platform, obviously when I'll deploy my smart contract
for every transaction that I do from my smart contract in future, for all of those transactions, I'll be paying some transaction fees, right? I'll be paying some transaction fees. So this is how I, being the owner of Ethereum, would be making money. So from each and every transaction that my user is doing through the network effect, I'll be making money from transaction fees. Obviously, a majority of this transaction fees goes to the miner, but just like around 1% or 2% is also given to the blockchain owner. Okay, and then more importantly, this will it's the cryptocurrency world is all about demand and supply. If the demand increases and the supply decreases, obviously that will increase the price of the token. And if the demand decreases but supply increases, obviously that will decrease the price of the token. So with increase in network effect, obviously the demand will increase, right? With increase in network effect, obviously the demand will increase. The more is the network effect, the more will be the demand, and because of that, the more would be the price of ether. It will keep on increasing, right? The price of ether will keep on increasing. So obviously, a majority of stake of ether will be held by Ethereum as well, right? Ethereum owner. If I'm the Ethereum owner, then I'll have majority of ethers available with me. So the value of my net asset of ether is increasing day by day as more and more people are adopting it. And then, of course, the last way is, through advertisement and multiple other ways. Like, if I have Etherscan, so if you go on Etherscan, you'll see that, they're advertising all the new tokens and everything. So through that, through branding and through advertisement also, you can make a lot of money. But again, all this you can only do when you are actually increasing the network effect. If you're not increasing the network effect, that would be little difficult. So as you can see over here, they are running an ad, and obviously because I'm using ad blocker, so that's the reason I'll not be able to see it. But if you open etherscan.io, then you'll be able to see this ad, whatever they're running over here. And this would mostly be with respect to, because everybody who comes on etherscan.io is a web3 user, right? Is a web3 user. So mostly they'll be running ads through of web3 projects and blockchain projects. They'll be running ads, so they'll be charging heavily. So yeah, that's how basically you can make money if you are running your own blockchain network. But does it mean that everybody earns like Ethereum? Of course not. Only you'll be able to make so much money only when you have a great network effect on your blockchain network. So coming back, we'll discuss about DAO. So DAOs are the organization that exist entirely on the blockchain and are governed by its protocol. It's a unison of many long-term smart contracts between many people. DAOs are designed to hold onto the asset and use a kind of voting system to manage the distribution. Two or more entities in DAO can interact with each other in a fully decentralized and automated fashion. DAOs comprise of the global network of nodes and members that all work together. So with this, in general words, if I have to explain that, I guess we already know what DAOs are. So DAOs are nothing but a group of people who are responsible for taking decisions on a blockchain platform. Okay, so let's suppose if I'm creating a DAO for a specific purpose. Okay, so let's suppose tomorrow how the waste management should work. Okay, how the waste management in our city or in our state or in our country should be done. For that, I'm forming a DAO. So I'll deploy a smart contract. Through that, a group of people who are selected to be a part of that DAO can interact with the network members and decide and define their way of thinking. What do they think of how this DAO can be improvised, or how they can vote for a particular way of sorting the waste and managing the waste. So for this, we have got one example as well. I would request all of you to have a look at this diagram and see if you are able to understand it. It would also be great if one of you can explain it. Obviously, I'll be explaining it in detail, but let's just give a try by yourself, see if anybody can understand it and explain this, how this is functioning. Okay, so let's try to understand what exactly is happening over here. So we have a country that is holding election, and then so let's suppose the country wants to hold the election in a decentralized way, and they want to prevent the voter fraud. So for that, what they do is they form a DAO. of course. But the thing is, the best part about this DAO is you can say this is also an example that would give you an idea that how big a DAO can be. So when I say a DAO, it sounds like a decentralized autonomous organization where it seems like only a limited number of people or only a group or a set of people can be a part of it. But it's actually not like that. This example will also set an example of how big a DAO can be. So in this case, as you can see, this DAO is basically created by all the people of the country who are eligible to vote, right? So we create a smart contract. Let's suppose I create a smart. Let's suppose we do it for India, okay, and we are trying to do it for India, and we are trying to create. Let's suppose there are around maybe I'll say 60 crore people. I'm not sure, my figures might be wrong, but let's assume that there are 60 crore people who are eligible to vote. Okay. So if there are 60 crore people who are eligible to vote, and then we might also say that we'll create a smart contract, we'll create a fungible token, and we'll give one token to all those 60 crore people who are eligible to vote for for having a national election. So once we distribute it, how, obviously there'll be a lot of complexities that how do we ensure that, it's not transferred to more than one time, and transactions and limitations and all those things, security things will take care of that. But post that, obviously everybody is given one token, and right from anywhere they're present in, they don't have to actually be present in their hometown and where they have to cast their vote. They can actually be present anywhere in India, and yet they can cast their vote through this one token that is offered to them. So let's suppose there are multiple parties who have participated in the election, and then of course let's suppose we have party A, party B, party C, party D, party E, party F, multiple parties. So everybody, all the people, all these of course, sorry, 60 crore people who are having the eligibility to vote, each and every individual can transfer their token to either of the parties. Of course, they can just transfer it once, and they can just transfer it to one of these seven parties. Okay, so once they have transferred it, at the end we can see that who has got the majority of votes, and if there is no majority, then maybe two people or three people can combine to form the majority, and then we can decide that who is the winner of the election. So this will be one of the most safest and one of the most transparent way of conducting elections, because the data once stored in the ledger can never be tampered or deleted or edited or modified. And of course, because it's a DAO that we are following over here, so anybody can vote, anybody being at any part of the world. So this is exactly what is being explained in this DAO, and this the conceptual idea of this example is not only to explain what a DAO is, but also to explain how big a DAO can be. That when I say DAO, it is not always only a group or a limited number of people, but in this case, a DAO is nothing but all the members of the country who are eligible to vote, all the people or the civilians of the country who are eligible to vote are the member of DAO. Okay, they all are member of DAO. And the smart contract, which is of course the business logic behind the DAO. So DAO is the nothing but a collaboration of multiple people on a platform. That's fine. But what's the memory of this business functionality? That is the smart contract. So the smart contract would be programmed in such a way that it will issue one token each to all the 60 crore people of the country India, and then respectively those 60 crore people can transfer one token which they have received, they can transfer it to either of the parties. So guys, with this we can say that we are done with Ethereum theoretical part. So now before we move to Solidity, if you remember last, so Solidity is a contract-oriented high-level programming language whose syntax is similar to that of JavaScript. It is designed to target Ethereum virtual machine, that's also known as EVM. Okay, so sidechains, Anurag, if you remember, sidechains were responsible for connecting two different blockchains. Okay, so let's suppose if I have a Bitcoin and if I have Ethereum. So if I want to transfer some assets from Bitcoin to Ethereum directly, it won't be possible because the two consensus algorithms are different and they don't understand each other. But then we can introduce something that is known as side chains, which are nothing but separate blockchain only. But the intention of this blockchain is not to actually handle independent transaction, but the intention of this blockchain is actually to just connect two different blockchains like Bitcoin and Ethereum. So with the help of sidechains, we can transfer the assets at some predefined deterministic exchange rate from one blockchain to another. That can be just types of payments and crypto transactions can be handled by sidechains. Great. So coming back to Solidity, so yeah, it is designed to target EVM. EVM is nothing but Ethereum virtual machine. And Ethereum virtual machine is basically a machine that actually runs the consensus of Ethereum and actually the one that is responsible for connecting to all the different nodes and peers and clients, of course. So it is designed to target EVM. Solidity is a statically typed, supports inheritance libraries and complex user-defined types among other features. In contrast to being an object-oriented language, it's basically a contract-oriented language. Although there is no much difference between object-oriented and contract-oriented, but it's just a fancy name that people have given. But yes, of course, Solidity follows all the principles of object-oriented oops as well. Okay, so Solidity follows almost all the principles like inheritance, encapsulation, polymorphism. It mostly follows all the principles of oops. It compiles the instructions into a bytecode so that they can be read by the network. So obviously, we always understand, right, that high-level languages, high-level code are converted to the low-level code, and then add that into the machine-level code so that they can actually be understood by the machine, right? Because machines just understand zeros and ones. So in the same way, Solidity as well is a compiled language, and when it compiles whatever piece of program you have written, it compiles them and converts them to the bytecode. And these bytecodes are the ones that are understood by the network and that can be taken care by the network. How's the layout of Solidity and how does Solidity looks like? So we have Pragma, Solidity, and the version number. So we have Pragma Solidity 0.4.0. This is the first line of any program that we write. No matter what program we are writing, the first line of any program that we write in Solidity will always be this. So what will it be? It will be Pragma Solidity and the one version number would be there. Now, what is this version number? So this version number is basically the version of the compiler that we have to compile this program with. Obviously, there are multiple versions of the compiler. Okay, so which version of compiler you want to use while compiling your program? Okay, that you have to define over here. So accordingly, only that version of the compiler would be selected while compiling the program. So what I mean is, when I talk about the compiler versions, there are these many compiler versions of the program, right? These many compiler versions that can be used to compile a program. When you are writing your piece of code, obviously you'll have to tell, right, that which out of this, which version of the compiler you want to use for compiling your piece of code, right? So that is how you define Pragma version, and then you give a number. That number corresponds to one of these compiler versions, and only specifically that compiler will be used to compile your program to the bytecode. Okay, so what does it mean? Pragma version and then this number, what does this whole line signify? This whole line signifies that you are selecting out of many compiler version, you are selecting one of the compiler version that would be requested to compile your program and convert to bytecode. Okay, so that is what is the meaning of Pragma Solidity with the version. Such a source file will not compile with a compiler earlier than version 0.4.0, and it will also not compile for the compiler starting from version 0.5, which means only exactly for 0.4.0 it will be compiling. Only for this specific compiler version it will be compiling. Although we will be seeing this in practical as well as we'll be moving ahead. Okay, so another very important aspect in Solidity. There are two different types of memory that can be handled within Solidity.
Okay, so there are two different types of memory that can be handled. One of these memory that I'm talking about, one of the type is memory itself. The name is memory, and the second name is storage. Okay, so there are two different ways of handling the variables and all the data in the blockchain, specifically using Solidity. One of the ways is memory, one of the ways is storage. Now, I would request all of you to actually go ahead and give a, just have a read of this and see if anybody who can explain me or relate it to something that you already know in from the computer language or from the computer world. So definitely, this can be compared to the RAM and ROM as we have in our computer systems. So the way RAM is random access memory, and it is only used for storing the temporary data until the system is turned off. As soon as you switch off or restart the system, everything, all the data that is stored within the RAM get lost, and it's again empty in order to store new data. On the other hand, we have ROM, like read-only memory, wherein you have all the data that is stored on a permanent basis and it does not get lost. And even if you restart the system, it will be there as it was before. The state of those data does not change. In the same way, we have two different types of variables in Solidity. The first type of variable is memory variable, wherein you have a specific type of data that gets stored within that, but only for a particular execution. As soon as that execution is completed, and when the next execution is started, the variable that is holding that data or a memory variable will again empty itself for holding new data. Okay, whereas on the other hand, we have storage variables. So storage variables can store the data forever within them unless and until they are manually unless and until they are manually changed. So that's how the storage and memory variables are defined within Solidity. So now from now onwards, we'll be using this file to actually learn Solidity in detail. And over here, so read. So this is the official link where you should prefer to read about Solidity in case of any new things that comes up, or if in case of any new documentation version that comes up. This is the only place you should refer to. In case of any confusion, in case of any doubt at any point of time, again, this is the official um, delivery platform of Solidity. So this is the official docs of Solidity. Obviously, this is quite a vast, explanation of Solidity. So obviously, we cannot learn it from here. But what we have done is we have created a compiled or concise version of this, which contains or which includes almost all, not almost, but it actually includes all the fundamental concepts that are included in Solidity, and this would be more than enough for you to kickstart and start writing or developing smart contracts and projects in Solidity. Okay, so let's move ahead with this. So this was the table of content that we were just seeing. Now we'll go to version pragma. So we have already discussed what's a version pragma, what it means. It means that this line defines which version of the compiler I'll be using in order to compile the piece of program that I have written. And we have import files, so we can import a particular file, and using this import keyword, whenever we want to actually import any other file which is deployed already, there might be three chances. That the first, it's already deployed onto the blockchain, we can import that as well, or there might be a chance that a particular contract address is available at some place on the web, so we can import it from there as well by importing the URL and the path to that smart contract. Or there might be a chance that locally within our development environment, locally the file is present. So from wheresoever we want to import a specific smart contract or a specific file, we can do that with the help of the keyword import. Okay. So there are three different syntax of this, depending on how you want to import and which methodology. I just explained and stated three different methodologies. So depending on whichever methodology you are following and from where you are importing, depending on that, you can use any of these
three syntaxes that are stated on the screen. Now we'll talk about data types. So yeah, whenever we talk about data types are responsible for explaining what types of data can be handled by a particular programming language. Okay, so if I have to explain it in a very layman's term, because data types are important, so you need to understand what those data types actually mean. So it's like there's a person, he can understand a few languages, right? A person cannot understand all the languages that are spoken in the world, right? So he can understand a few languages, maybe English, Mandarin, Spanish, Hindi, Telugu. So maybe he can speak all these three or four or five languages, right? But obviously there are multiple other languages that he cannot speak. So whatever languages a person can speak or read or talk, that can be said that these are the data types of this particular person. In the same way, a particular programming language can only handle a specific types of data, right? So every programming language cannot handle every type of data. There are a lot of different types of data, right? So every programming language can only handle some specific types of data. Like if I talk about JavaScript, it can handle null, it can handle numbers, it can handle string, it can handle characters, it can handle arrays. So these are the different data types that can be handled by JavaScript. So different types of data that can be handled by a programming language is known as data types that are supported by that programming language. Okay, repeating again, different types of data like numbers, string, characters, arrays. Obviously, there are the floating point numbers. So floating means decimal numbers. So different types of data that can be handled by a particular programming language is known as data types that are supported by that particular programming language. So if we talk about the data types of Solidity, the first type of data that can be handled by Solidity is Boolean. So when I talk Boolean, what is Boolean? So whenever we talk about Boolean, Boolean can handle two different values only. First is true or false. So whenever we are dealing with variables or whenever we are dealing with the type of data that is responsible for handling or that we have to assign either as true or false, for all such types of data, we can use Boolean as one of the data types. And we can easily store either true or false in those variables. One very important thing is whenever we talk about data type and variables and values, this is the relation. Okay, so we always have data type, give variable name, and then comes data that we want to store. Okay, so this is the relation. So whenever you want to declare, whenever you want to store a data, so for that, obviously you'll have to declare a variable. This variable would be the key for this data. Okay, so if I want to store my age, whatever it is, if I want to store my age, that age has to be stored in a variable. Anything you can give as a variable. Let's suppose I'll give the name of the variable as age only. That is absolutely fine. Okay, so this is the value, my actual age, which I am storing in a variable called as age. And of course, this is not enough. I have to tell this age is of what type of data type. I mean, what type of data this variable can hold within itself. Can it only hold numbers, or can it hold strings? Can it hold characters? Can it hold null? Can it hold floating number? What it can actually store. That is where data types comes into picture. So we have to define that it can hold integer type of values. Integer is which can take positive. We'll discuss about integer, but yeah, just for now you can understand that it is numbers. So firstly, we define the data type, then we give a name to the variable, and of course, then we can store the data. It's not important to store the data right at that point of time. There might be a chance that you just declare the variable and assign a value to that variable later on. Okay, so as of now, you can just declare the variable by just ending it with semicolon, and later on, you can, so I can also say it like this, that int age. I can just define a variable like this by giving the data type and the variable name. And later on, I can say age is equal to n. Okay. So writing this in these two different statements, 1 and 2, even that is fine. Or writing it directly in one statement saying int age is equal to n, even that is fine. as you want. So this is the relationship between the data type, variable name, and the actual data that we want to store. Now coming back to this, so if I want to store a Boolean value, how would I write? Just to give a quick example, and so that for a better understanding, I would say bool parse is equal. So this is how I would store a data of Boolean type. So I would say, so is passed any variable you can give, as I already told, any variable you can give over here. So is passed is a variable. So, and then of course, I want to store true in it. If I want to store true in it, then of course, I'll have to declare it as a Boolean type of data type. Okay, that's great. I hope this clearly makes sense to all of you. Okay, perfect. Let's move ahead, guys. So we have discussed about Boolean. We now will be discussing about integer. Anybody has any idea what is integer type of data type? Integers are basically responsible for holding numbers. Okay. Now, when it comes to numbers, numbers obviously are two different types of numbers, positive numbers as well as negative numbers. So similarly, integers have two different types within, I mean, you can say subtypes. So the first subtype of integer is unsigned integer, and the second subtype of integer is signed integer. So unsigned integers are responsible for holding only positive values, whereas signed integers are responsible for holding positive or negative values. It can even hold positive or it can even hold negative values. So yeah, I hope this makes sense to all of you. There are two different types of integers. Firstly, integers are responsible for storing numbers. And when it comes to numbers, there are two different types, positive and negative numbers. So accordingly, two different subtypes of integers are there. The first subtype is unsigned integer, which is responsible for handling only positive values. And then we have signed integers, which are responsible for holding positive or negative values. So the 8, 16, 32, this what you see over here is representing the type of data, basically the size of data that can be stored within this unsigned integer. So if it is 8-bit value, you can use uint 8. If it is a 16-bit value, you can use uint 16. If it is a 32-bit value, accordingly 64, 128, and 256 bits, whatever it is, you can accordingly use that specific type of unsigned integer. Is it important to always define it like this? No, it's not mandatory. You can use the default one, that is unsigned integer 256, or also you can just write uint, and when you write uint, it will correspond to uint 256, and this would be capable of holding uint 8, 16, 32, 64, and 128, all different types of unsigned integers. Same goes well with signed integers as well. Hope the integer type of data type is clear to all of you. Next type of data type is address. You must not be aware, right? The reason for not being aware is because there is no other programming language that supports address data type. And the reason for that is clearly simple, because address type of data type is only used in Solidity. The reason for using address data type in Solidity is just because of the reason, because in any other programming language we just don't require it, right? We just don't require it, because only within Ethereum we need to handle the addresses in a unique way, because everything originates from an address and everything is directed or pointed to an address, right? So whenever a transaction happens, it always happens between two different people or two different addresses. To be technical, it always happens between two different addresses, right? So if you can see over here, the one who is initiating this is also an address, and the one who is getting this, I mean, sorry, the one who is initiating this is also an address, and the one who is getting it is also an address. So addresses play a very important role in Solidity specifically. That is the reason they have been defined as a separate type of data type itself. So what does it mean whenever we define an address data type, what it is responsible for holding? It is responsible for holding a Ethereum address that is of 20 byte value. Okay, it is responsible for holding Ethereum address which is of course of 20 byte value. Now this address data type is also unique because it has some predefined methods that are available. Okay, the address data type, unlike other data types like Boolean integer or any other that we'll be seeing in future, unlike all of them, address data type is slightly unique because it has some predefined methods that are available. What are methods? Methods are like functions which are responsible for uh, executing a specific operation and giving you the result of it. Okay, so there are a few predefined methods that are available, which we can just call on top of any address. So one out of them, of course, there are multiple predefined methods that are available. One out of those multiple predefined methods that are available is balance. Okay, so anybody who can predict what this method would be doing by the name, can anyone predict? You can even read the explanation and see if you're able to understand it. What this method would be doing. So yeah, balance method that is available on this address type of data type is responsible for fetching and giving you the balance in terms of V. Always remember that when we talk about this balance, it's not a balance of a token.
Balance of an ERC, I mean, it's not a balance of an ERC20 token, rather, it's the balance of Ether. Okay, so whenever I talk about balance as a method available on an address, it is basically fetching and giving me the balance of that address in the form of V. So if I have 1 Ether, what would be the balance be returned as? It would be returned as 10 to the power of 18 V. That's the work of balance method. So then we have transfer and send. So this is again another type of methods that are available. So basically balance is first of all, balance is a predefined method that is available on address data type. So when I say address data type, of course, it means that if I want to store an address, I would store it like this. So let's suppose if I want to store my address, so I would say address and then my address is equal to some address that I can take from maybe MetaMask. So we can take this address and we can put it over here. So this becomes an address data type, of course, right? Now the thing is, there are some predefined methods that are available on this address. When I say predefined methods, what are methods? Methods are responsible for doing a particular operation and giving you the result. One of those methods is balance. So I can say balance, and then I can pass in. I'll copy the syntax from here. So I can say address dot balance u into 56, and this address can be replaced with an actual address, or it can even be replaced with a variable. Whatever is fine, anything is fine. So if I say this, my address dot balance, and it returns me a u into 56 value. What is u into 56? It's a positive integer value of 256 bits, right? So what this will return me is, it will return me my Ether balance in V, of course, because smart contract majorly deals only in V. It doesn't deal directly in Ether. What is V? V is nothing but the smallest form of Ether. 1 Ether is equal to 10 to the power of 18 Vs. So if it will return my Ether balance in V format. So if I have 1 Ether, what it will return? It will return me 10 to the power of 18 V. I'm not sure if it is actually 18 zeros, but considering that it is 18 zeros, it will return me this much amount of V, because that is what is equivalent to 1 Ether. Is it clear now? So in a general manner, you can say that this will fetch, let's suppose if I have a bank account, and in my bank account, there would be a balance, right? Which will be corresponding to my account number, right? So whenever you open your bank application and whenever you click on that button, show balance, what it actually does is it actually fetches the value that is stored corresponding to your account number. So over here, in our case, this is the account number and this is the balance, the account balance, right? So whenever we say my adder dot balance, my adder is nothing but, if to make it more simple, we can say it like this. So this address dot balance, which means whatever is the balance present on this address, fetch that balance and give me in the form of u into 56. So whatever balance will be available over here, it will fetch that balance and it will return me the output in the form of v. Like for our bank case, it will return us the amount in the form of, if I have 5,000 rupees in my bank, it will return us 5,000 INR, right? This is what will be returned if I have this much amount of balance in my bank account. In the same way, if I have this much amount of ethers in my account on this address, then it will return me this value. Exactly. Whatever balance you will see in your MetaMask, the same balance will be returned over here. And just to add it as a fact that even MetaMask uses dot balance method to show your actual balance. So when I go to MetaMask, for all the people who don't know what is MetaMask, don't worry. We will be discussing about this in detail. But for now, let's suppose if it is showing me this much amount of ether is there. Okay, so on this account, even MetaMask at their backend, in their backend code, they have written the same function, address dot balance. So on this address, they are using the dot balance method and they are fetching the value and they are showing it over here. Okay, hope this makes sense to all of you. Then we have transfer and send. So transfer is responsible for transferring some amount of V to a particular address. So whatever address we pass over here, on that address or to that address, this much amount of V would be transferred. Simple. So like again, if I have to relate it to our bank example, so using your bank application, you can transfer some funds to some other account, right? So in the same way, when you want to transfer some funds to some other address, you'll call this function, you'll call this method, and using this method, you can transfer certain amount of V to a particular address. So whatever address you want to transfer it to, you'll call it over here, and whatever amount you want to transfer to, that you'll define over here. The thing is, okay, fine. So we understood what is transfer, but then what is send? Send is also same. Send also will transfer certain amount of money to a particular address. That again is same. So if both transfer and send are doing the same thing, then what's the purpose of having two different functions? If both of them are doing the same thing, if transfer also is transferring tokens from one account to another, and if send also is transferring token to one account to another, then what's the purpose of having both? The reason why we have both is dot send will also let you know within the code itself that whether the operation was successful or not. Okay, whereas dot transfer would just execute but not let you know that whether it was successful or not. Okay, if I have to if I have to explain it, it won't be a most appropriate example, but yeah, to an extent it can be an appropriate example. So let's suppose there are two ways of transferring the money. First, using any UPI application, maybe PhonePe, any of the UPI application. Second, using your bank account, bank application. So when you're transferring through bank application, you send the money to some other person, but within the bank application, you don't get to know whether the same money has been credited to the other person or not, right? You just get to know that yes, the transaction was successful, the money has been debited from your account, but whether it has actually credited to the other person's account or not, you don't get to know that, right? So you can compare that to transfer. Something similar happens in transfer. You send it, but you don't know whether it was successful or unsuccessful. But on the other hand, when you send the money through any UPI application like PhonePe or Google Pay, you also get to know whether the money that you have sent, has it been credited to the other person's bank account or not, right? So which means it also tells you whether at the end it has been credited or not. Similarly, the send will let you know whether the transaction that you have done, whether it has failed or passed. If it has failed, then it will return false. And if it has passed, then it will return true within the code itself. Okay, so both are responsible for doing the same thing. The only difference is exactly as dog told, that the only difference between them is how they are reacting to failure. The first one is not at all reacting to failure, whereas the second one is reacting to the failure within the code itself and letting you know that the output of this result has been false because it is returning a Boolean value. So it can either be true or be false. If it is a failure, it will return false. If it is a success, it will return true. So the next one is, although there is no real-time explanation, let me tell you beforehand, there's no real-time explanation. I mean, there's no real-time example for explaining what is a call, delegate call, and call code. But yet we'll just understand it because this is not something that we use directly. Like, see, balance and transference, and we as a developer would be using directly. But call, call code, and delegate call is not something that we use directly. Okay. Rather, this is internally used by functions to make call to another function. So I would explain it like this. Let's suppose I have one function, that is function 1, and then I have another function, that is function 2. So if I am calling this function 2 within my function 1 body, okay, so I have function 1, within the body of function 1 I am doing multiple execution, right? One of those execution is calling function 2 here for doing some operation. So the way how this function 1 is able to call function 2 is call code. Okay, so as I told, we directly don't use it. It is something that is internally used by contracts and functions in order to make call to each other. Okay, call code and delegate call, these are the two approaches. Within call we have delegate call and call code. These are the two different approaches that we can use in order to make a call to any other function or any other contract. So exactly how the contracts and functions talk to each other, call each other, and execute each other, this is defined by delegate call and call code. Simple. Moving ahead, the next type of data type is array. Okay, let's try to understand what exactly is an array. So just now we discussed about variables, right? So what are variables responsible for? Variables are responsible for storing a particular data within a particular variable. Now, let me give you an example. So if I want to store age of a student from a class, I can store it like this, right? I can say uint age is equal to 5. So this is the age of a student from a class. Can anybody tell if I want to store age of 5 students from a class, can I write it like this? Uint age is equal to 5, 5, 4, 5, 6. Can I write it like this? Is this the correct way of storing 5 different ages of 5 students? And what we can do indeed is age 1 is equal to 5, uint age 2 is equal to 5, uint age 3 is equal to 4, and like this we can define. Okay, let's understand. So yeah, definitely this approach is correct, but obviously it's very lengthy approach, right? We can store, if I want to store age of 5 students, then this is definitely one of the ways I can store age of 5 students. I can give the name as age 1, or I can even give the name as student age 1, like this, whatever name of the variable I want to give. So this is of course one way. And this is of course not a correct way, because a variable can only hold one single value. If you are giving any other value, there, depending on different programming languages, in some programming languages it might throw error, or in some programming languages it might just ignore everything else and would just take the first value. Okay, mostly it will be giving error. But yeah, main thing is you can never store more than one value in a variable. So what we can do in order to ensure that we can store multiple values in a variable only, for that you'll have to convert the type of that variable to an array type. This is where array comes into picture. Array, with the name only you can understand, it's nothing but array is nothing but a list of values. So you can use the same variable age, but to make it an array you'll have to open and close a square braces. you'll have to open and close a square braces. Once you open and close a square braces, then now you can store multiple values in that. Now opening and closing the square braces signifies that now this particular variable is capable of handling and storing multiple values. Similarly, now array further is of two different types: fixed size array and variable size or dynamic size array. So the first one that I just wrote over here is a dynamic size array, because I haven't defined the size of array over here. The first one that you see over here, uint age with open and close braces, it hasn't got any size, right? It's a dynamic size array, which means it can store as many values as it wants to. But if I say age, open a close braces, enter 5 and close a close braces, then if I store 5, 5, 4, 6, 5, of course, then now this value can just, this variable can just store 5 values, because I have defined a size to it. It can just store 5 values. If I store more values, again, it might give error, or it might just ignore the other values. So if you are sure that your size of your array is gonna be of a specific length only, then you can use a fixed size array. This is known as fixed size array. But if you're not sure that what the size of your array is gonna be, then you can use this dynamic size array, like the one that is used over here, without defining any length of the array. And in this case, it can store as many values as it wants to. So we get to know that using indexes. So every array will have an index. So when I talk about index, it is the position of an element in the array. Okay, repeating again, what's an index of an array? Index of an array represents the position of an element in an array. So the index for first 5 would be 0, then 1, 2, 3, 4, like this. It increases sequentially. So whenever I know that, the first value that is stored in my array is the student one, first student's age. So whenever I want to retrieve the student one age, I can retrieve it like this. I can say, of course, one value would be a unsigned integer, and I can say student one age is equal to, and I can retrieve the value from the array using this. So I can pass in the index where it is present. So what is the index of the first student? It is 0. So when I pass in 0, this will actually fetch the first value of array age and will put it in the student one age variable. This is how we will be able to retrieve the value from an array. Similarly, if I want to retrieve the value of third student, let's suppose, so I'll say student age 3, I'll change the name of the variable. And what would be the third student's age? So it would be the age, the array third element of the array. And what would be the index of the third element? It will be 2. And this is how, yeah, exactly. And this is how we can fetch the third student's age from the list of the array. Okay, so coming to enum. So when we talk about enum, enums, like any other programming language, are nothing but ways of managing the state of a program, right? But right over here, what we can do in enum is, so enums in Solidity are responsible for tracking the phase of an asset or anything of value or anything of like asset. It is used to track the state of an asset. Let's suppose if I have to talk about, let's suppose I'm creating a bot. Okay, let's suppose the name of my bot is bot, and the bot can either move straight, or can turn right, or can turn left, or can stay still. Okay, these are the only 4 states in which my bot can be. These are the only 4 states in which my bot can be at any point of time. Okay, so over here, what is the asset? It's bot. Can this bot be anything? Yes, it can be a smart contract itself, or it can be a currency, or it can be of a business. It can be anything. For whatever thing you want to manage the states, you can use enum for that. So for this bot, it can either move straight, or can turn left, or can turn left, or can turn right, or can stay still. So how I can manage this? I can manage this using enum. So I'll define it using enum. The example is already available. So I'll say enum action choices, whatever name to this enum you want to give. The way how we can give any name to the variable, in the same way we can give any name to this enum as well. Over here, we prefer to give action choices, and then we gave 4 different states in which this bot can be: go left, go right, go straight, sit still. Okay, so at any point of time, this bot can only be present in one state. This is the benefit of when we are talking about state. At one point of time, a bot or anything like asset can only be present in one state. It's not that anything can be present in multiple. Let's talk about smart contract. A smart contract can have multiple states like deployed, initialized, completed, and then burnt. So these are the 4 states of a smart contract, the life cycle of a smart contract. Initially, when we have just deployed the smart contract on a blockchain network, it will be in deployed state. Then when we actually start using the smart contract, it will be in initiated state. Then once the purpose of that smart contract is fulfilled, and now the smart contract is no longer of any use to us, at that point of time, the state of the smart contract will be completed. And once when we actually kill the smart contract or make it inactive for future use, then we can say that it is in the state burnt. So again, at any point of time, the smart contract will just be present in any of the one state only, right? It's not that a smart contract can be present in deployed and initiated state both at once. The way how this bot cannot be turning right and turning left at the same time, in the same way, every asset at one point of time can only be present in one state. So to manage the state of an asset or a smart contract within Solidity, we use enums. Okay, so whenever we want to manage the state of any asset or smart contract or any piece of code within Solidity, we use enum. And how we can actually modify the values like this. So we can say enum action choices. This becomes a variable name. So you see if over here how it is looking like. This is the variable, this is the data type, and this is the actual value, right? So the variable is still a variable. You can give whatever you want. And the data type is replaced with a enum, because this enum itself becomes a data type. So rather than having some standard data types like uint, bool, char, num, or anything, you can define the data type as the enum. And then whatever value you want to assign it, you can assign it, like action choices dot go straight. So action choices dot with dot will be able to access all these 4. And then with dot will be able to access all these 4, and then go straight is one of the values present in action choices. So all in all, in simple words, enums are responsible for tracking and managing the states of any asset that is present within the Solidity. So next we move on to struct. Okay, so yeah, struct is nothing but creating your own custom data type. Now again, this is something that can be explained with an example. So let's understand this with an example, with the same example that we were discussing earlier actually. So we discussed about how we can store age of 5 students from a class, right? And this was solved using array. Now there is another important question, and how it was solved using array, it was solved like this. So uint age is equal to 5, 4, 5, 5, 6. Okay, this is how it was solved. But now there's yet another question. What if we want to store age, name, and phone number of 5 students of a class? How can this be solved now? Can it be solved something like this, wherein I can say uint student one details is equal to, of course, I'll make it an array 5, comma, Joseph, comma, phone number. Can it be said like this? Or maybe I'll keep it simple. This turns out to be a string. Can I store or can I manage the student details like this? So yeah, of course, we cannot store. The reason for that is, see, the how we discussed. Obviously, we can store multiple values in an array. That's absolutely correct. But there is one restriction that is available with array. The restriction is there can be multiple values, but all those values have to be of same type. Okay, there can be, of course, there can be multiple values that we can store within an array, more than one values we can store, but all those values have to be of same type, which means if one is integer, all should be integer, or whatever we are storing should be integer. If we have defined the variable, the array variable as unsigned integer, all values should be unsigned integer. Similarly, over here, we defined this array variable student1 details as unsigned integers, right? So first value was unsigned integer, that's fine. But is the second value unsigned integer? No, because it's a string. So we cannot store a string within a variable of uint data type. Okay, so can we change to string? Now should it work? Again, it will not work, because now this will be fine because you are defining a string and you are storing a string, but then this and this are not string, right? So they cannot be stored. So you have to, so technically, do I mean to say that we don't have any data type only that can actually store the value over here? Exactly. There is no such available data type that can store everything for you. So this is where struct comes into picture. This is where struct comes into picture, which is responsible for creating custom data types. Structs are responsible for creating custom data types. When I say custom data types, what does it mean? So for something similar example, we can say struct student details, and within this we can define uint age, string name, and of course uint phone number. So these are the different values that I would like to store within my struct, right? And then of course I can, whenever I want to store any detail, I can use this as a data type. So what I did over here, I created this as a unique data type. Okay, the student details now becomes a unique data type. So if I want to store details of first student, so student one dot age is equal to 5. So what has to be the data type of this? Simply the struct value. The struct value can act as a data type for this. So student1 dot age student details is equal to 5. So with this way, we can actually store the student details in a very organized manner by creating our own custom data type. So what are structs used for? Structs are used for creating user defined custom data types, so that the user can create any variable and define their own custom data type rather than using some of the existing ones. So accordingly, you can see we have created struct funder, And when we define a new variable funders, we can use, in place of the data type, we can use the data type as our struct value. So when it comes to mapping, mapping is nothing but, with the name only you can understand that you are mapping something to something. Map always happen between two things, right? So over here, that something and something is nothing but key and value. So basically, the syntax goes like this: mapping key type to value type, and then the map variable name. Okay. Let's keep it short. So mapped variable. Obviously, it's the name of the variable. So this is the official syntax of mapping. What it represents is that you are mapping a particular key type of data type to a particular value type of data type, which means you're mapping a key to a value. Simple. You're mapping a key to a value. But when I say key and value, obviously that will be a specific rigid value, right? So I can say name is equal to Saurabh. Please understand this very carefully, okay? So this becomes the key and this becomes the value. So if you query, if anybody tries to query name, then what value they will get? They will get Saurabh, which is absolutely fine. This is the work of mapping. But obviously we cannot create like if like me, there are 500 other people, I cannot go and creating 500 different types of mapping. Then what's the point of this? I can simply create a variable and store a value, right? So rather than actually having the actual key and the actual value, what we store is the key type and the value type, which means we map one data type to another data type. So the key type, if I want to store, that we'll discuss later, but the key type can be of any type of data type, uint, boolean, string, array, anything, address, anything. Value type again can be of any type of data type, or can be a new mapping as well. That's called as nested mapping. We'll discuss about that later on. But yeah, key type can be of any type of data type, whereas value type can be of any type of data type, as well as can be an array or a new mapping also. Okay. So now we'll discuss the reason for having a mapping. Why do we need a mapping? Let's discuss that part first. That why do we even need a mapping? Let's suppose I have an address and I want to get the balance of an ERC20 token from that address. How can I get that? Can anybody tell me? You shouldn't think that we can do address.balance, because do remember that address.balance is a predefined method that is available only to fetch the ether balance. So see this address.balance, you might think that we can simply do address.balance and it will give us the balance, simple. But do remember that this will give you ether balance, which means native currency balance. Okay, there are two different things, right? Native currency, also known as cryptocurrency, and then there's something called as token, which we create on top of a blockchain. Remember, so this token we create on top of an existing blockchain network, which can be of ERC20, ERC720, 1155, whatever it is. So assuming it's a fungible token of ERC20 type, and this balance I want to fetch, that this address, how much balance of this type of ERC20 token this address is having. How can I get that? Any guess from anybody? Can I get it like this? Uint, and I'll pass that address to this address, and this is the balance 0.0032 ether. Okay. So I'll say address is equal to this address, my address is equal to this, uint balance is equal to, how do I get this balance now? That's the question. like that 0.0032 ether, which of course will be converted to 32 to the power of 10 to the power of 18 V, of course. But how do I get that? Let's suppose write it in that way only, 32 along with 16 zeros and V, assuming that this is 16 zeros. How do I get this balance from this address? Or the more important question is, how do I even store it within my program? So you see under assets, I'll have some more tokens. So this is my value. This is my actual value. Okay. So this is the value that I'm holding, but these are the tokens, right? How do I get these values? This 1000 AMC token and how much 1 million CET token, this that I'm having, how do I get this value? That's the question. How do I get that balance? So obviously, so this is where, let's discuss this. So this is where mapping comes into picture. So mapping, with the help of mapping, I can map a key type to a value type. So in our case, what would be the key type? The address would be the key, right? Because on an address, you want to fetch a value, right? So address would be the key. And now because this address is going to be the key, so you'll pass in address as a key over here, and then they'll have a value. So that value would be nothing but uint, right? So remember that we had to pass the type over here, right? So any address you pass, you'll get a value corresponding to that, and we can name the variable as balance. Now what will happen? So if you want to fetch or if you want to update, whatever you want to do, you simply have to write balance and assign a value to it like 2000 or whatever. But will this work? No, you'll have to, because it's a mapped variable, this balance is not a normal variable. If you see, then this is a mapped variable, right? And because this is a mapped variable, you'll have to pass a key to it as well. So either you can pass the key as the whole address itself, or you can pass the key as the variable where you are storing that address. And this will now, what this statement will do, this statement will go and initialize your address with 20,000 tokens, CET or whatever token you have created, XYZ, whatever tokens you have created, it will assign these many tokens to your address. But this is about assigning, right? I was asking about how do I fetch the balance. So it's simple. So if you want to fetch the balance, you'll say uint my new balance is equal to, you will fetch it using balance, but then again, you'll have to pass a key to it. So that key will be this. So you pass a key to it, this will return you a value, that value you are storing in this variable. So mappings might be complicated, but if you're understanding it, this will become very simple for you. So it's very simple. The simple thing that you need to understand is mapping is responsible for mapping a key type to a value type. A specific, typical, very famous example for this is whenever you want to fetch or update the balance of token on an address, you have to use mapping. And using mapping, you can define address as the key type, because obviously whenever I want to fetch your balance or update your balance, what would be the key to that balance? Your address would be the key, right? Because your balance is stored on your address. It's not that your address is stored on your balance. So the address would be the key, and uint would be the data type of value, and balance would be the mapped variable.
Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.
So coming to the first question on this blockchain interview questions and answers said, it is compare blockchain with relational database. Well, whenever we think about comparing a blockchain with relational databases, 4 points are very important to be discussed. The first thing is the unit of data. In a blockchain, the data is stored in entities called as blocks, while in the relational database management system, it's stored in the form of tables. And then the second thing when we talk about is the point of failure. In a blockchain, there does not exist a single point of failure which might end up catastrophically. But then when you think about RDBMS, there are many points where if it fails, things can end up completely bad. Now, when we're talking about the third point, it's centralized control. In blockchain, there is no such thing as centralized control. The data is maintained in the form of ledgers, and then it's worked on based on that. And of course, when you're thinking, it says the centralized control admin basically working on the data. And then when you're thinking about editing and deleting data as per you wish, in the case of a blockchain, that is absolutely not possible because again of the ledger, the hyperledgers, and the data scheme that blockchain is built upon. But then when you think about a relational database, yes, it is possible to add data, edit it, modify it, and of course delete it as and when you require. Here again, in both places, there are many authorization techniques and safety measures that are put into place, but at the end of the day, it is possible very easily to change data in your RDBMS. Now, coming to the second question, it's what is blockchain technology? Well, you do have to know the answer to this in a clear and a concise way, because if you're at a blockchain interview, there is a very good chance you can get carried away with this answer, but then try to keep it very concise. See, a blockchain is nothing but a very simple incorruptible ledger that consists of multiple transactions that happen over the web. All of these transactions actually get recorded or they get programmed, right? It doesn't have to be a financial transaction, but it can be anything that can be put down in a text editor. You can have ledgers of these, you can have all the data stored in it, and you will have multiple copies of the data across multiple ledgers to make sure that even if there is one entity that fails in a blockchain, the rest of the chain has the data backed up such that it can pick it up and begin work, and in fact continue work without having any disruptions as well. So the technology that allows for this is blockchain, and it's been one of the most revolutionary technologies of our time, and it was made very popular to us by a cryptocurrency called as Bitcoin, and more on this in the next couple of questions. Now, moving on to question number 3, it states, what do you mean by blocks in the blockchain technology? Whenever we refer to blocks, right, understand this. A block is simply a list that consists of the records of data that's present in it. Whenever these lists are combined with each other, right, when there are more than one list, they're called as blockchains. The chain of blocks, right? A block contains a list of records. There are multiple lists. These lists individually become a block and eventually becomes a blockchain. It is as simple as that. Let's say, for example, there's an organization that has, let's say, 100 ledger books, a combination of which we entirely call it as blockchain. But then with these 100 ledger books, if you start picking it up one by one at a time, right? So there will be 100 different blocks, and there's one entity that's called as a blockchain that consists of these 100 ledger books. It's just a way of naming it, but then this is how it goes. It's a very important thing that you should know at this point in time. Moving on to question number 4, it states, how is a block recognized in the blockchain approach? Well, when you think about these blocks, this list, the amount of data that gets stored into it, all of these blocks has something called as a hash pointer. These hash pointers basically link to the block, and it makes sure that it has a link between the previous block, the transaction time in case if there's a transaction that happened in the data, and of course a very clear and a concise way of stating the block. There is a transaction at this point in time, this date up to milliseconds as well. So whenever having the recognition of a block is in concern, think about talking about a hash pointer and how it links one entity in the block to another, and any transactions performed in a block will be recorded with the timestamp of the transaction. Now, moving on to the 5th question, it states, is there any network specific conditions for using blockchain technology in an organization? But then when you think about it, right, it has to be a peer-to-peer network, and it has to have all of the wired protocols to ensure a lot of safety parameters and continuous connection from end to end. So what it really does is it validates the new block simply and helps the companies or helps the people who are willing to start up, this kind of a blockchain and bring it into their organization. It does it very easily because you really do not require any sort of third-party application. You really do not require any sort of expensive hardware to get started, to be honest. But then having the network is a basic requirement. So do talk about having the network and the protocols that govern the blockchain technology. But then do understand that there are no specific or expensive solutions to a blockchain requirement while beginning. Now, moving on to question number 6, it states, is it possible to modify the data once it is written in a block? Once a data gets written into a block in the technology of blockchain, the answer is no. It cannot be changed, because if you require any sort of customization or change or modification, all of the data that's present in all of the blocks must be removed, and then whatever modified data is there, it has to be put in to all the blocks. This is one very important reason that forms to be the entire foundational concept of blockchain, because at the end of the day, data is extremely cared for in a blockchain technology aspect. And here, when you're doing this, if you just modify it in one block and leave it, it really doesn't work, because blockchain doesn't work that way. So if you have to change something, you have to change throughout the entire blockchain architecture that exists, and then only you can have your new data or modified data to be present in a block. So when you're asked this question, make sure to present yourself this way. Now, coming to question number 7, it states, what type of records can be kept in a blockchain? Are there any restrictions for the data that are kept in a blockchain? Again, a very straightforward question. This is a very, very important question that gets asked a lot. Well, the answer is no for the second part of it. Is there a restriction to store any sort of data? No, you can store whatever is required, but then you must note, what you have stored, because at the end of the day, storage can be limited sometimes, because, technology, it works in a way where records get duplicated multiple times to make sure that your data redundancy is kept in check, and it is very much required to keep your data safe. So in that particular case, even though there is no restriction, it is always very valid to take care of the data that you put into a ledger. Now, what are the common types of records that are usually put in? Think about medical transaction, think about identity management, right? So, in India, we have something called as the Aadhaar. In America, you have something called as the Social Security. In America, you have something called as the SSN, or the Social Security number, and more. And then you have the transaction processing details, you have organizational details, management activities, key documentation events, and a lot more. So when all of these data are concerned, you might be asking a question of saying, is this all? Can I store only 6 types of data? No, because as I just mentioned when at the start of this answer, you can store whatever you want, but practically blockchain is used for this purpose. Now, with this, moving on to the 8th question, it states, what is encryption and what is the role of encryption in blockchain? Encryption, as you might know it, is a method you use to keep your data safe by changing its format, or by changing something in a way where it doesn't give out what it's meant to for the naked eye. You can have a lock and key system, you can have multiple ciphers, you can have multiple methodologies that you can use to encrypt your data. So whenever you're encoding a data, you're converting it from one kind of a format to another, where you can have it sent out through the network then, and then having the ability to know that someone in the network can capture your data and may misuse it is very important, because if you just send the data as it is, someone sitting in the middle of it during a phishing attack or whatever it is can take up all of your data and misuse it, right? So that's not what we want. So to avoid all of this, so we encode the data in a very strict way, in a way where only the receiver knows how the original data can be obtained from whatever was sent. This process is called as decoding the data, and doing this will make sure that there's overall security, your blocks are valid, and of course at the end of the day your entire blockchain is kept secure because of this. So at this point in time, it's very important that you understand encryption and you know how it works whenever data moves around in blocks, especially in the case of blockchain. Now, coming on to the 9th question, it says, what exactly do you know about the security of a block? Here's a very important question, and the answer to it is very simple. A block cannot be customized by all of the users on a network. It's only on priority authorization is required, and this authorization methodologies and protocols that are put into place will make sure that your data security is at top notch. That is, it has an excellent level of security. And when you're thinking about every single block, right, each of these blocks can be secured using cryptography, where you can have a lot of methodologies put into place where the organization or the person maintaining the blockchain really need not break his or her head about the security of the data, because at the end of the day, if it's in a blockchain structure, it's secure. Plus added parameters for the network makes it even more secure, and then individual block level cryptography methodologies will make sure the data is almost bulletproof in the network of a blockchain. Now, coming to the 10th question, it states why blockchain is a trusted approach. There are many reasons why one would go on to trust a blockchain, and here is why. The first thing what happens is that it is compatible straight with any other business application. One, because blockchain is open source. Second, as we discussed, it's completely secure. And third, even if it was intended originally for online transactions, developers have paid a lot of attention, especially to the field of security, because in today's world, cybersecurity, keeping your data safe, and all of these are primary concerns, right? So to make sure all of this is put into place, no matter what business you own, no matter if it's an online business, no matter if it's a medical institution, or whatever you can think of that you're planning to implement blockchain into, do understand that the data will be secure. It's open source, so you really don't have to put in a lot of money at the start, and if you have proficient developers who can handle it, then you will have a very effective chain at moving your data from one point to the other. So a blockchain is easily considered because of all of these factors, but the primary one being security, in my opinion. Now, moving on to the 11th question, it states, what is secret sharing? Does it have any benefit in blockchain technology? So coming to the answer of this question, whenever we talk about secret sharing, right? Secret sharing is basically an approach that we take where we divide the personal information, whatever data that is being shared into multiple units, and then we send it across to the individual users. So by doing this, what we're trying to do is that we're having the original information, and it can only be decoded when a member wants to share the secret, and all of them actually agree to share this particular data in secret, then only the data can be pulled out. By doing this, again, blockchain is proving that whenever it comes to security, it is in high regard. It brings out multiple advantages, especially in the world of security related technologies, and blockchain is at the top of it. So having your data sent out separately and having a common consensus to whom the data has to be shared to, and to when, where, what, why, and all of these other questions as well. So to do this, it has multiple benefits, and this is how secret sharing works. Now, coming to question number 12, it states, what is blockchain durability and robustness? I think by now you might have a clear picture of blockchain's robustness, because data is secure. If it goes in one of the blocks, it can be revived from the other blocks as well. And when you're thinking about durability and security wise, I think you already know how to approach those questions. Now, what happens is that whenever we have data in similar blocks where it's spread across a network, you can control all of these from one particular entity. It'll absolutely have no single point of failure, right? So think about a quick example about Bitcoin. Bitcoin was a cryptocurrency that was invented in 2008, and since then it has been working fine, and it's driving a lot of businesses without having any sort of significant disruption, right? If there is any problem that ever came with Bitcoin, mostly it was because of mismanagement, or let's say unethical hacking, and other simple things such as probably bad intentions or human errors. But then there is absolutely zero flaws in how Bitcoin works. So the internet itself, when you think about it, has been durable for 30-40 years now. Security, there is no beating blockchain. It is very durable, and it is highly robust, especially for storing your data and moving it across the web. Now, coming to the 13th question, it states, what is transparent and incorruptible in blockchain? Well, one thing that you really have to know is that in the blockchain technology, right, all of the data gets stored into multiple blocks, and every time there is a check-in that happens to see if the data is all right or not. So whenever you have a self-auditing ecosystem like this, right, the network has to look back to check if each of the data is okay in every single span of time, and this is usually a 10-minute interval. And since each of these group of transactions is called as a block, there are two very important properties of a block that we have to discuss. discuss. One is that data is very transparent because in general it is actually a public piece of data. In general, it's the whole data that's being sent. And the second thing about it being incorruptible is that no matter what, blockchain data cannot be corrupted because it takes a huge amount, in fact, an extreme amount of computing power to get a hold of the entire network that is working and then hijack it and mess with your data. This is literally not possible, but then this is literally not possible or very, very far-fetched even for people who would want to misuse your data. So in that case, data is very transparent and it is almost incorruptible in the case of blockchain. Now, coming on to the 14th question, it says, how does Bitcoin make use of blockchain? If you ever mention Bitcoin as a part of your answer, there's a very good chance this question can be asked as a follow-up. So what happens in the case of Bitcoin is that there are multiple wallets that users get assigned to, and each of these users with each of these wallets can have a part of the transaction, can have some data stored into them, and all of these data are stored in a ledger. So what these wallets do is that they have a piece of data called as a private key, or also what we call as a Bitcoin seed, and with this seed we sign transaction, we show proof saying that I am the owner of the particular wallet, and then whatever cryptocurrency has to be moved, whatever amount of cryptocurrency has to be moved, it gets moved around from one particular ledger to another or one block to another as per requirement. Mostly it's the cryptocurrency moving from one person's wallet to another person's wallet by making use of the seed. But then when you think about it, there are many ways one can move money in the case of Bitcoin, but the basic working of it, the foundational concept of it remains the same. So when you ask this question, make sure to answer it this way. Now, coming on to the 15th question, it states, is blockchain an incorruptible ledger? Well, as the developer claim stands, blockchain cannot be corrupted no matter what, because at the end of the day, the technology is built to be extremely robust and it offers state-of-the-art security methodologies in terms of your data, in terms of whatever governs the data as well. So if you're asked this question saying, can we corrupt a blockchain? The answer should be a very straightforward and a confident no, because that's what the technology is put into place for, to be incorruptible and to be highly secure. Is it doing that? Well, yes, since a very long time, blockchain has been growing out to be an amazing open source technology that is helping keep our data safe and secure across a network as well. So in that particular case, blockchain is uncorruptible. Now, when you're thinking about the 16th question, it states, what are the business benefits of a blockchain? See, you can talk about this answer to this particular question for a long time, but then try to keep it very concise, because there are multiple business benefits of a blockchain, right? So you can have your data in a consolidated place. It can be consistent. All of the errors in your data can be kept minimal. You can verify your data and see if it's present. You will have authority of your data. You will know where the data is moved from the origin to the place, if it's a shared ledger, if it's a common ledger, and of course at the end of the day you will understand that there is a good amount of trust and integrity in the flow of transaction of information that happens in a blockchain, because no one can get on a blockchain and misuse your data, as I mentioned, right? And then when you're thinking about immutability, immutability means that you cannot change the data once it gets into your ledger, and this will make sure that there is a very good amount of transparency and people cannot go on to misuse data by changing something of value there, and then that leading to a catastrophe as well. That cannot be done. And it's not just this, because let's say contracts are executed on business networks. Whenever you think about blockchain, all of these technologies that govern the blockchain is smart, it's automated, and mostly these businesses that impart blockchain have seen that they get an extremely high amount of speed of execution when they have used blockchain. The overhead costs are reduced, and of course their entire chain is at less risk, because at the end of the day, this is what businesses want and this is what blockchain offers. So it's a win-win at the end of the day, especially when talking to clients, when interacting with their data, and sometimes, not sometimes, when you think about it, 99.9% of the time data is confidential, right? In the case of businesses, this is where blockchain can help.
Let's have a quick quiz question, guys. And the question is, how does a private blockchain differ from a public blockchain? And your options are, private blockchains are open for participation by anyone, while public blockchains are restricted to authorized users. Your second option is, public blockchains require permission to join, while private blockchains are open to everyone. Or private blockchains are often controlled by a single entity, while public blockchains are decentralized and open. Or public blockchain use proof of stake, while private blockchains use proof of work. Please mention your answers in the comment section below.
Moving on to the 17th question, it says, what are blockchain requirements? See, one thing you have to understand is that blockchain is one of these technologies that took the world by storm, right? Because it is transforming the way we, in fact, send data across networks. And once this innovation started to happen, and since it's open source, many companies wanted to invest their time and efforts into seeing how they can best make use of this, right? So IBM was one of these companies to contribute a little bit of code to what we call as the Hyperledger project. And from what they say, the people at IBM, industrial grade blockchain technologies have multiple characteristics that make it bulletproof. For example, if you have a shared permission ledger in, let's say, an SOR, or what we call as a system of record, and a source of truth, it is made sure that your data can be seen by all of the participating members of the business network with complete transparency and good amount of security as well. And then when you have a common protocol that's agreed by all of the members in the network, right, this means that your network will only get updated, the data in your network will only get updated when there are network verified transactions. No one can slip in any amount of data into your network. It has to come from a verified source, and it will. Now, the third thing that IBM people say is that there's good amount of cryptography that makes sure that your data is even more secure. It is tamper proof. Authentication is required. All of your transaction that happens is 100% with integrity. So there is no messing around with data when it comes to blockchain. So at the end of it, there are many things that make a blockchain structure very important, very rugged, and a practical piece to be used in an industry level as well. So in that particular case, and then coming on to the 18th question is very important, because you have to know that this is a commonly asked question in a blockchain interview. It says, how can you stay up to date with the new and upcoming concepts in blockchain? One very important thing here is that the interviewer is trying to see your interests in the field of blockchain, your ability to learn new things. It may be complex things or simple things, and of course, how effectively can you learn these and use them in a production environment. So make sure you talk about the way that you used to learn new things and how you plan to see if it's right or not for you, and of course at the end of the day, how you plan to practically implement it, right? See, all of the IT concepts in today's world has been put to place to solve particular problems. In the case of blockchain, I think you would know by now, it's security, it's to make sure your data is rugged and to make sure that no one can mess with your data. Now, to do all of these, how can you practically implement the solution to a problem by working on blockchain? What have you learned? Where have you learned it from? And how best can you add value to the person who's hiring to your company? So when you think about it, right, this is what is required as an answer to this particular question. So talk about how you research new things. It might be reading blogs, it might be attending conferences, or whatever it is that takes to understand and learn the new and upcoming concepts in the field of blockchain. Now, do you have any experiences working in the same industry as ours before? This question is a frequent one, and if you are a fresher, this question might not apply for you because you might be just out of college. But even if you're a fresher or an experienced person, here's how you can answer this. If you have any sort of previous experiences either in your college or any sort of internship or any environment where you have worked on a current industry, right? So you can be working on building a blockchain architecture for a hospital, for a social media, or whichever industry that you've just applied to. So think about the company you applied to, think about what they do, see if you have done anything similar. If you have not done anything similar, even though you're experienced, do not say no. That's not the way to answer. One very important thing you really have to know is that you can talk about whatever you have done and tell them how you plan to bring that experience to this industry as well. There are many things where technologies or techniques that can be trickled down from one technology into the other, where they can outshine their previous technologies as well. So in that particular regard, make sure to talk about your previous experiences, all the tools you've used, all the techniques that you have implemented, all the problems you've solved, even though it might be not part of the same industry. And if that is the case, talk about how you will bring about the change and how you will bring about furnishing yourself in a way where you will bring that experience to help this particular industry. Now, coming on to the last question, it says, have you earned any sort of certification to improve your learning and implementation process in the field of blockchain? Certifications are very, very, very important in the field of blockchain, and not just blockchain, in any technological field, right? Because for you as a learner, you will get a lot of knowledge, you will get hands-on experience, you will be trained by professionals, you will become experts, and you'll become thorough in all of the concepts that you're learning. But how does it matter to an interviewer? See, an interviewer will want to understand that you're very serious about your career, that you want to build your career in that particular domain that you're certified in, and it shows if you're certified that you have a strong aspiration to learn maybe new things. See, you can be coming from a background of cooking, you might be coming from a background of architecture, from marketing, whatever it is into the world of blockchain. If you are certified by a reputable firm, it means that you have put in your time and your effort to learn new things. This shows that you're an effective learner and that you have a passion to go about doing this. So it's one very important thing that whenever you talk about certifications is firstly list all the certifications in a very quick way, telling the interviewer what you have done. And instead of talking about what these certifications are, please talk about what you learned from it and how it's been helpful in implementing a solution to a problem. It might be that you have worked on practical use cases, it might be that you have worked on industry level case studies, or whatever it is. Do talk about how you have driven value out of a certification program. A certification is something that you can have for multiple purposes, and the most important thing is that you use it to solve problems that we have today, right? So in that particular regard, more than talking about what certifications, talk about how you've used these certifications.
Just a quick info, guys. Intellipaat has recently launched advanced program in blockchain in collaboration from Belhaven University. In this online program, you will learn about distributed ledger, Ethereum, Solidity programming, and many more. Upon successful completion of this program, you will get PLA credits from Belhaven University. With this course, we have already helped thousands of professionals in a successful career transition. You can check out their testimonials on their Achievers. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height, so visit the course page link given in the description and take the first steps towards a career growth in the field of blockchain.